This one's too early, by the way. Hello, computer. Welcome back. Welcome in. Welcome back. I don't know. One of the other, or both, I guess. I guess welcome in is always, and welcome back is sometimes. Hello. Hello, computer. Hello, computer. Welcome back to the LLLL Interregnum period, episode whatever the next one is. I'm thinking the next one is episode 5. I don't know. I don't know how long it's been. I don't know anything, in fact. Hello, everybody, computer. Today, it is another long-awaited episode of LLLL. They've been asking about this one every other day, maybe not every day. They're asking about, when are you going to be doing the huffing and puffing episode? When are we blowing the damn house down, LLLL? When are we huffing and when will we be puffing? And today it's both of these. This is the concept. Has the bush green screened? Oh yes, this is the using a Colonq stream to write the emails I don't want to write. I see. Hello though, computer. Welcome in. Who's here? Who did they decide to put on my screen today? Who did they load up? Hello, Taimisi, welcome in. Hello, the 0x539. Hello, Caddy Shot. Hello, Jock BR. Hello, Niche Penguin. Hello, various robots. Do we need to say for the robots? Is it required to say for the robot? No, we'll skip the robots. Oh no, I'll feel okay. Hello, Prodsy Pod robot. Hello, Tiny Misi. Hello, Niche Penguin robot, and also Exor Xavier robot form. Hello. Hi. Hello, Exor Xavier Real. Hello, Poof. Welcome. Look at these nerds chatting, and streamer isn't even live. This is this is kind of good though. They call this the pre-gang. They're a notorious cabal. Hello, Compiling J. Hello, Blazy Knights. Hello, Slater USA. Hello, Bridgewater. Hello, Talon 1024. Hello, Kalinoscopy. Hello, Clit 404. This is a good name. Hello, Jacques BR Double. Hello, Control O. Hello, Ronmu. Hello, Freeful. Thank you for Yuri He sending love. Hello, Emails Shadden. Hello, Gira_R. Hello, Troopin Ponda. Hello, everyone. Hello, I may have borked it. Also me. Hello, IHQMD. Hello, FN_Lumi. Hello, 37 Chairs. Hello, Real Niceston. I'll be late today due to an appointment. Well, this is okay. You haven't. Thank you. I hope you have. This is good. Good luck. Good luck with this. Hello, Sight Soul. Hello. Who else? There's more. We're scrolling. Hello, Psychic Refugee. Welcome in. Hello, Nose Gold. I read Rose Gold as Nose Gold. This is sort of good. Hello, F Mega. Hello, I really want a gold tooth sort of badly. I feel like this would be good. And it would improve my, like, this would provide me with some kind of buff effect. Hello, F Mega. Hello, Venerok. Hello, Watchmakering. My house has some brick. Hello, Pippin Fool. Hello, CRM148. Hello, Greymouth. Hello, Stoic Mana. Hello, HR Rar. Hello, Semelo. Hello, Trap Exit. Hello, 403 Skill Not Found. Hello, Pro Teapot. Hello, Prowcash. Hello, Slater USA Double again. Hello, Bridgewater. Okay, we've caught up. Now. Apparently, when doing addressing stuff on x86, if you aren't using the stack related registers, it defaults to the DS segment register. This is like old mode, right? Is this the case? Maybe I don't really know what is this? What does it mean to not use the I don't know. Man, Sisk is so fucked up. There's so much fucked up and evil. And x86 in particular, right? Like, I was sort of pleasantly surprised the first time I had to look at, like, modern x86 stuff, because, like, I learned this from a book. Like, my first exposure to assembly language was there was a book in the library that was about, it was a guide to MASM. It was for MASM, which is the Microsoft assembler, I think. And this was well in the 16-bit era, I think. And there was all kinds of like bullshit about the like segmenting, right? Like segment, you have to because like obviously 16 bits, it's not many numbers, right? There's not many bytes you can index in this, so you have to do all kinds of evil bullshit to like address things. Hello, form sites. Welcome in. Smoking that shit, the XOR RAX. I'm playing around with ARM64. Yeah. I don't know. I mean, these things all have their own, right? I mean, I think it's just by virtue of like the thing being targeted for the machine, right? It's rather than human so much, right? This is the idea is for it's for machine to interpret quickly rather than human to interpret quickly. Yeah, there's their own problems, right? We certainly saw all kinds of fucked up nonsense on ARM, right? When we wrote that ARM emulator back in June, we found like there was so much bullshit related to like the timing of things, right? Like it's like yeah. Hello, Sir Elfman. Also, welcome in. I'm playing. Yeah, hello. I said this twice, or maybe 3 times probably. Hello, Crazy Kitty too. I need to do Linux for 3DS things eventually. Can you do this? Hello, Sun Demoniac as well. Aloha. Can we move? Let's get movement. Smooth movements silently. Can we go? Let's head over to here. Hello, A Squared 31415. Also, welcome in. Today is the long-awaited huffing and puffing stream, or maybe the puffing and huffing stream, potentially. This is episode 5, L Colonq Interregnum Period, which means, if you forgot what the interregnum period means, it means we can do whatever we wish. It means we are not beholden to the whims of the gods, and in fact, instead, we can choose our own fates. Our own fate is available to us. Did we end up solving the maths on Friday? Yes. We were victorious, I think, on Friday. If you recall Friday we were like, yeah, we're gonna do clone stuff today, but then like 1 hour in, we got distracted by a math puzzle that was posed by XOR Xavier regarding computing the units of a certain ring. Computing units in a certain ring. And we did in fact obtain a solution that was n cubed rather than n to the 4th power. And this is kind of good, I think. We did manage to do this a little bit. Segments are just kind of offsets. Yeah. The hello sorcerer, also welcome in. Like, I mean, I guess 32-bit also has the same thing, right? Which I guess I need to learn more about this, right? Because 32-bit you can only index 4 gigabytes, right? This is kind of the thing. So you need, and people are having way more. There's way more than this now. So I assume there's something going on here. Is very different than real mode segmented. Yeah. You just don't get to use segment registers. Whatever sort of math related fever dream happened, I missed for better or worse because Ham started playing Shenzhen IO, and this is for more than fair. Can we shout out Ham on Rye, please? Can we get this? Let's do this. Ham on. This is good. This is kind of good a little bit. This is our friends. The hello. Yes. Hello, I'm here again. I'm here again. We're figuring out how to start the thing. Unreal mode is something different. They're rerunning the Devil Glass. They put the Devil Glass on my screen. How are you doing, computer? How's it been? How's your weekend? I've had a good time. I did a lot of network programming. A little bit. This has been really good for me recently. I've been enjoying this. This stuff is sort of fun. I've been doing a little bit of networking. I made it so that a big fan of the computer. I love this too. I love going on there. I maybe go on there a little too much sometimes, but it's been good, honestly. What else do you need? I've been having a good time. We've sort of been snowed in here. We've been getting snowed in a little bit. Are you snowed in as well, computer? It's been, for me, we've just been buried under feet and feet of snow. And it's been so windy. It's been blowing up in huge drifts. I can barely see out my door. There's like 4 feet of snow on the ground or something like this. So to this end, we've been, I don't know. I've mostly just been going on the computer. I go on and cooking and going on the rowing machine. This is my life these days, my lifestyle that I've chosen for myself. And we've been doing a lot of network programming. I live in Australia. I have never seen snow. Hello from Australia, Piss. Hello, Tafir, also. Welcome. I've been getting to networking and I'm halfway through with pulling my hair out. Yeah, there are many nuances in this thing. Programming, yes. Hello, Sifon Altera. Welcome in. It's good to have you, friends. The programming today, by the way, is we're learning about compression and decompression more than anything. I don't know much about this. We did a little bit of experimentation in this recently when we did the thing. We've been kind of working up to this maybe a little bit, right? We did the thing where we did the clippy image format, their fucked up little bespoke thing, right? We messed around with some video compression stuff a while ago. We did some like error correcting code shit, which is like sort of adjacent to this a while back. But today we're learning about two things. I want to learn about Huffman table. I would like to learn about Huffman table. And I would also like to learn about deflate. These are maybe related. I don't know. We're gonna learn about these things. We're gonna learn about these things today. This is the objective. Among other things, this is the goal. Manchester encoding next, or is Huffman? Is this a place in the UK? What's another place in the UK? What's the most famous place in the UK? What's the most? I don't know. Maybe something like this. Hell, this in Michigan, right? London. I don't know. I feel like this is too much of a low-hanging fruit, or so. I don't know. Anyway, hello one plane, welcome in. Yes, we also have, I remembered what winter update was last time. Winter update on the thing that no one cares about but me. This did happen. You've seen this text. This is an interview with famous author George R.R. Martin. Did you not do Huffman stuff in college? I did not do anything related to this in college. To be honest, I think I mean I've ranted about this enough times. I feel like my college education was very lacking, in the sense that like it mostly provided structure and motivation to learn a couple of things that I would not have learned myself otherwise. But beyond this, I feel like it was very lacking in any sort of novelty, I guess, right? Like I don't know. Yeah, but I definitely did not even approach this. I did not even hear this word once. But yes, this is famous author George. This is famous author George. Can we bring this up? Computer science is especially lacking in colleges compared to other subjects. Yeah, I think this is a thing, right? I don't want to beat the drum 100 times. Modern CS degrees, yes, it is unpleasant, right? It's unpleasant because computer science degrees have taken on a dual role, right? They are both like there is an academic thing called computer science that is probably some kind of math subfield thing, right? And then there is a need for vocational training. There is a need for vocational training for computer programming, and I think it does a pretty poor job at both. Hello, Gendude and Andromeda. Welcome in. Hello. Welcome. Wait, are you Andromeda from Other? Are you Andromeda from Other, or are you Andromeda from here? Welcome, though. Either way, hello. A few I've seen is just like learn UML and Java and do some algorithm. Yeah, it's basically this, I think, in many zones. There's and then people complain because you don't learn Vue.js or something, and then you don't get a job or something like this. This is sort of crazy. All you do in 3 years. Yes, I think it's yeah. There's a lot of places like this, even some like good schools that do this. It seems like you do both well. Yeah. I think so. I had this impression too. You're doing for like electrical engineering. Where did Colonq leave his car? We're in the garage. It's fun to have this lowered shader resolution because we can like kind of like have these shaders actually run well. Now it's kind of good. It doesn't really diminish the effect at all, and it actually enhances it, I think. Anyway, George update. Before no one cares about this but me again, but can we get the George update? George update. George update. Brief George update. There's supposed to be another Fire and Blood book too. I do think if I can just get some of these other things off my back, I could finish, quote, The Winds of Winter pretty soon. It's been made clear to me that, quote, wins is the priority, but ... I don't know. Sometimes I'm not in the mood for that. Martin confirmed he won't allow another author to complete his books, noting the series would remain incomplete. This is like the most relatable thing of all time, by the way. I mean, it's you have to feel bad sort of for him. Like this is horrible, right? It does suck. Noting the series would remain incomplete if he were to die before the last installment. If that happens, my work won't be finished, he said, though he stressed that his health is fine and that he is, quote, not dying. Good luck with the hump fans and e-dating or whatever you were doing. I must shower and go to bed. Good night, piss. Thank you. Thank you. Enjoy bed. Enjoy bed and water also. Martin also said he will not give up on writing the book. I would hate that, he told the reporter. I would feel like it would feel like a total failure to me. I want to finish. Martin said in the new interview he has around 1,100 manuscript pages of The Winds of Winter written. He previously said he had 1,100 or 1,200 pages written in 2022. Martin also provided some insight into why the book is taking so long, explaining that when he sits down to write, he often finds himself unhappy with what he has written previously. This is all like, I feel like as a, these are feelings that we are well acquainted with. I will open the last chapter I was working on and I'll say, oh fuck, this is not very good. And I'll go in and I'll rewrite it, he told the outlet. Or I'll decide this Tyrion chapter is not coming along. Let me write a Jon Snow chapter. If I'm not interrupted, though, what happens, at least in the past, is sooner or later I do get into it. This is extremely real. This is the George updates for today. The latest and greatest George update. This is how I'm feeling. Perhaps, but 26 plus years ago when CS degrees were still newish, I was learning many things that folks I hear from major degree programs now don't learn. Yeah. I mean, I have basically the minimum possible expectation from a computer science degree, right? I like, if someone showed up with like a computer science degree and they were like, I need to be hired, I would be like, this means nothing to me, right? This means not to be crude about it or cruel, but like, this means nothing. This means that maybe you know what Java is. Not even that you know, like the lowest expectation possible is that like, you don't even like, right? I would not even assume you know like how to use Java. Like you know what it is. You heard of it once, right? You were instructed exactly how to install some old version of Eclipse or something in some class and you solve some contrived homework assignments 6 times, right? Like this is so like the expectation is so low. It's you've heard the word big O, right? Object oriented, orienting objects, shape rotating, consider. Hello Bogan Bits, also welcome in. Don't expect them to know. Yeah, I mean even this, you could forget, like this is just like some tool that you could learn, right? But like it's all like you need this basic foundation, I think, to like I don't know. Anyway. What else is... Hello, Mental Equilibrist. Welcome in, also. Just speedrun a CS degree, just spamming CS classes. I mean, basically, yeah. I mean, I did graduate in 3 years. So this was like... I had a lot of college credit going in, but I basically just took the classes that they required. And I went to, like, a pretty good school, right? Like, I went to a school that's probably, I don't know, pretty reasonably good for computer science, right? Like, I interviewed a fresh grad like a year ago, and I asked her, how did you build your graduation project? Like, what technology? She said Java and object-oriented, right? Yeah, like, people just come out not knowing anything, right? Like, straight up, like, it's not even a matter of, like, learning. Like, I know people want to frame it as, like, oh, we need to teach practical skills, but it's not this, right? They don't, like, they don't have anything. Yeah, unless they already knew stuff when they came in. Yeah, like this was my experience by and large, right? Like the people who were going to leave knowing how to program knew how to program when they came in or got very excited about it in like year 1 and then started doing it on the side, kind of, right? Like this is by and large how it goes. Hello Topocado, which means they're doing kind of a piss poor job at, like, I don't know. I mean, I guess it's who knows. I don't want to imply any, I don't know. I learned about 6 languages I did not use once. I mean, this is fine too. I think honestly, this is better than the opposite, which is learning nothing at all, right? Like, yeah. I don't know. It's crazy. Maybe I should just queue up some more grad CS classes and try to get out early, but I feel like that would be kind of a waste. So I'm trying to, yeah. I think like there are valuable things that are hard to learn outside of like the structured context. Like I sort of believe in this, right? Like there on languages I never used against standard. Yeah, but this is like valuable to learn, right? I think this is good though, right? I would rather, right? Like I think like, I don't know, what does it look like, right? Like can we see what this looks like? What does this look like? Can we make image? Can we make the 1000 by 1000 black image? Bring up 1000 by 1000 black image, Sprite, please. Like there's a bubble of like, can we get a bubble? Make some sort of orb. This is like things you might possibly use in a job, right? Like, and this is like all things. I'm putting all computer things, right? There are things you will use in a job. In fact, it probably should be more outside of this. There are many things that you could use in a job that like you might not like, that are not computer things, right? And like like what a university education could reasonably provide is like a good kind of a survey of a broad survey of red area, right? What it actually provides is like this, like is like this, and I think a lot of like the discussion about this topic is like they want to stop. People are like, you should stop teaching the green, start teaching the blue instead. And I think they should teach the freaking red, right? I don't think they should particularly care about the blue, right? I mean, the blue should sort of be incidental, right? You could get incidentally more coverage of this just by doing more of the red, right? They should just do more of the red. Hello, Aliens 2. Welcome in. I think this is good, right? People should be exposed to fucking standard ML, right? People should be exposed to like Huffman table, right? Huffman, like right, information theory stuff, right? Like there should be more, right? Yeah, it should not be a vocational training program for Vue.js or whatever, right? Or anything, right? It should like but it should give you the basic skills to like pick this up if you want to, like having more exposure. Nice to see Clippy. Hello, Fabius. Welcome in. Yes, Clippy, we've made this. Clippy can say things in an Emacs buffer. He doesn't really say very much yet, but he can say things. We learned how he works, runs away. It is unnecessary probably, but I think it's just good to be exposed to this, right? Like I mean, for me, I think something that's helped me a lot. Hello Desert FX, welcome in. Oh boy, I sure do love taking my groundhog for nice long relaxing walks along the beach in Novosibirsk. There should be a border circle, a circle with questions HR on the border of red, blue, and green. Hello. Anyway, I don't know. I feel this. I think people like a wide-ranging education is valuable, right? And even if you don't have a lot of depth in topics, awareness, yeah, maths circle. I mean, maybe this is a subset of this. Maybe this is there's a broader purple circle that shares this border and goes far deeper, called math with parentheses S. Parentheses S. Actually, speaking of jobs, I don't freaking get it. Why is there entry-level positions for people with a bachelor's and senior positions for who did a master's? Yeah, who knows? I mean, the degree thing it doesn't line up well. Hello, Sentai VT. Thank you for 6 or 7 months. This is good. Welcome in. This is hello, okay, hello. But yeah, I don't know. I mean, there's no point belly aching about it too much, but it is what it is. It is what it is to a large degree. But I think like, you have to temper your expectations of what a degree is going to be, and if you want to get something out of it, you have to kind of seek this out yourself, because I think you can, right? Like, if you are like motivated and like excited about it, right, you can expand green to red, right? You can get a lot of, right, but you have to kind of, like, you're not going to do this if you just kind of follow the course that is set in stone. You have to, that was written on stone tablets at the beginning of time. It's called expanding the green circle, right? This is the objective. I don't know. You don't need a school's permission to learn things. Yeah, we are attempting to expand from green to red here. Thank you, a Buff Seagull, for the resub as well. I heard someone say that programming should be taught like music schools. I want someone to explore that idea. What does this entail? I don't know very much about this. About music education. There's a lot to do on the computer. There's so much to do. There's so much to do on the computer. Every freaking day. There's major amounts. You do need the school's permission to learn things. Well, yes, this is true, but also the thing is, I mean, at the very least, the earning credit is easy. It's fairly easy, at least. I mean, it can be strenuous for sure, but like, you can sort of, I don't know. You get a lot of free time to do whatever you want, and like, you don't need, like, the degree signals so little anyway that it's like, well, you know, I don't know. They have to, yeah. Anyway, this is banish this to straight to hell. Banish this to hell and send it. Yeah, I don't know. I think there's no fixing it. Like fundamentally, I think the issue probably is most people are normal about computers. Most people are normal about computers, and not in the sarcastic way, not in the ironic way, right? We here are very normal about computers, smiling face, right? We're extremely normal about computers, but most people are just normally normal about computers, right? I think like, it's sort of difficult to create this, I don't know. I just feel like the I don't know. It's difficult to become a good programmer from a purely, like, I don't know, like at least in my experience and from my perspective, right? Like, the best people that I know all love it, right? Like, the people who I'm like, okay, damn, they're good at this, right? They love it, right? They're not into it because it's like, oh, well, this paid well, so I went to school and I did a degree, right? They're into it because they're freaks about it, right? They're into it. And I think like it naturally, like, I don't know. For me, a lot of the time in the past, like, the thing that was most useful in the workplace was the fact that I was into it, right? And not that I have any particularly deep knowledge in any one topic, but I was able to like be fairly successful in like in like what I was doing, and in a lot of places, because like I just like, I have been exposed to a lot of things, right? This is how I at my previous employer, right? It was the sort of thing where you had to kind of like advertise yourself to like projects, to like managers and things, so they would be like, okay, we'll bring this person on for this. And this is how I always sold myself, as just like a generalist, right? Of having 50% knowledge of 80% of things that might be relevant here, right? Like, it's not like I'm going to know how to do shit, right? But I know enough that I'm going to be able to figure it out, right? This is my DNA now. Yeah. Approximate knowledge in many things, like this exactly, right? And this is really valuable, and this is like what it's difficult to teach in a, you know, like, or like what they don't do very well, right? Like, you should just, it's really useful to just like know what a lot of things are, right? Even if you don't know much about them. Maybe I'm biased on this because this is the position I'm in, but I have found this very useful in my life, right? Like, knowing enough that you can start doing research and like trying to figure it out, right? Like, this is really good. I think This is a valuable guy. Hello, must underscore broke underscore. Normal in the way that they know how to use them at a surface level at best and have no further interests. Yeah. As with anything where money ends up being involved, perverse incentives, and I don't know. Like, sometimes the incentives can just be normal, but I think they just, like, I don't know. Sometimes they don't produce good outcomes. Wires. My stream froze because I had too many devices powered on at once. They plugged in too many wires to the machine. They put too many wires in there. I don't know. This is kind of good. I've been having weird things. I'm sort of worried that one of my discs is failing. This is a relevant concern for me. I bought a new disc because I'm basically, the streaming thing is making me have to be more and more concerned with data. I have to think about freaking data too much. There's too much damn data on here. Like now that I'm producing like so much, like before it's like, well, I have a couple 100 megabytes of stuff that I care about maybe that I could back up. Hello, Penguin Airlines too. Sideways, deeper, everything. Yeah, this is good. Now it's like I'm producing 40 gigabytes a week that I ostensibly don't want to lose ever, right? So this is like, this is crazy, right? We have like terabytes and terabytes of stuff. I have friends that highly recommend Backblaze. Yeah, I know Backblaze has like a backup thing. You had terabytes of Nix residue even before, but I don't care about this. They can be obliterated at any time. The data fasting. Hello, attention span. Welcome in. I started encoding with AV1 recently. Perhaps I should do this, but who knows? Who knows how it goes? I enjoy ZFS for this purpose. Yeah, I need to set up some kind of RAID thing. Probably I need to buy one of those nice little drive bays so I can easily like put more drives in. Come with 5.25 inch bays anymore. I don't know how to. I mean, what is this in terms of size? I'm making motions with my hands trying to judge this size. How much data do you have to deal with? Well, mostly I have to deal with recordings for all of the streams. UC Berkeley, Montana Annex. So it's 40 gigabytes a week new for 3 years now. So it's like, I don't know, it's like little over 5 terabytes I think at this point. The size is somewhere between 6 and 7. Yes. Put in optical drives. You can queue up a multi-day long FFmpeg conversion regime. This would take 100 years. It'd take 100 years on this. Government surplus tape drives. Hello, big thumbnail. Welcome in. Intel A40 recently and transcoding large videos in my TV collection into AV1. I see. Bought a 9900, which I guess gets us into the topic of the day, which is compression. I don't know. I've been thinking about this a little bit recently, computer. I've been thinking about PNG. We've been, a while back we learned about QOI, right? This is a guy we learned about, QOI, the quite okay image format, which is a very easy to parse, lossless compressed image guy. We implemented this a while ago, if you recall. We wrote a little decoder for this, and it's kind of good. Hello, error 204. It's at the very least it's very easy to implement. And we got some, but I was thinking like, okay, what about this PNG stuff, right? It'd be kind of cool to like, maybe PNG is interesting. I maybe want to learn about that a little bit more, right? Just because like it's something we use a lot, right? I'm always making PNG images. I'm probably making this like every day. We create one of these. Irfan View has QOI support. Oh, very cool. This is like a venerable Linux image viewer guy, right? I remember this, or maybe this is a window. I remember seeing this forever. Does PNG do? I've never used it though. Does it do Fourier funnies? I implemented a simple JPEG decoder and it was fun. I don't think it does this because I think this is. I don't know. You can probably do lossless stuff on this, but I feel like this is maybe more suit. I don't know. I'm not going to speak on this because I don't know about it enough. But I'm pretty sure it doesn't. I think what it does is. I am pretty sure this is QOI. When we open up PNG, get PNG image on here. Yeah, I don't think it's useful for lossless necessarily. PNG I think is is a guy called Deflate. I think it's a guy called Deflate. There's two forms, right? There's a pre-compression filtering step, and then there's also Deflate, which is this fellow here, which is kind of what's a name for it, I guess. Yeah. You can get an A310 for $110 from Amazon. Pretty good deal for just encoding. I see. So this is kind of cool. It's kind of cool. As stated in an RFC document, an algorithm producing deflate files was widely thought to be implementable in a manner not covered by patents. This is good too. And there probably is a nice little RFC about this or something. But this is just like a compression guy, like in the way that we know. In the way that we know, AVIF has pretty good lossless efficiency. It's using AV1 encoding for still images and beats PNG by miles. Yeah, I've heard this too. I've heard of this. Just a zipped BMP or what? The RFC is just pulling that one STB library. Hello LG, welcome in. So I think this is kind of motivation. I don't know. There is a simple implementation of this that exists. This is the puff part of today. This is how we're going majorly puff. There's a guy, can we find this? If I search deflate puff, is that gonna kill me? Is that a power word of instant death? No, this is how to deflate puffer jackets. Can we find this? Can we find this? It's in zlib. They put it in zlib. They put it into zlib. Can we go github.com madler zlib tree master contrib puff? Does this bring us to where spell invocation of the spell open? I've been encoding my videos to AV1 since mid 2024, and pretty much all my images to AVIF even longer. I should eventually publish my encoding lifts. Puffer, I hardly know her. Hello, Ringle Tingle TV. Welcome in. I've been learning more about Tingle recently as well. Ringle Tingle TV. This is can we find this? There's a character in The Legend of Zelda called Tingle that they bring up sometimes. This guy. And they invented, like, I had been aware of like one spin-off game for this, but our friend Dumb Moths has been playing like 1 million of these, or at least one that I didn't know about. And they just made like a ton of spin-offs about this. They released this in America. They're very strange games. Hello Kirsch, welcome in. Yes, there was more too. Yes. This is the one that Moths was playing. This is the plot is described as a regular man is sucked into a magical book and turned into Tingle. He's turned into some kind of elf creature and has to establish relationships with women in order to escape. It's a dating type game. It's a game about dating. This is the plot line. And there's also an Alice in Wonderland type of theming to this. This is crazy. Can we find the game storyline starts with an ordinary 35-year-old man just like me who watches a direct sales program on television and orders a book said to make its readers popular among women. When the man opens the book, he gets sucked into a picture book world. In this world, he becomes Tingle for some reason, wearing a green costume. Tingle meets 3 characters who accompany him on his journey to escape the world: Kakashi the Scarecrow, Bariki the Tin Robot Woman, and Lion the Lion. That's what they call me too. These characters are an L::Q, the L::Q. This is both my name and my attribute. It's my name and my type. These characters, okay, it's the Wizard of Oz. This is the thing, right? The player has to solve many puzzles that require the use of different abilities of Tingle's 3 partners. Kakashi lacks intelligence but is small and therefore able to get into small places. Bariki is very intelligent but heartless and can cleverly... He just sounds good. He's just strong. He just has a great deal of power. The party's last member, Lion, is more powerful than the other two partners, but cowardly. Many of the actions in the game are performed via the stylus. Another central gameplay element is the romantic interaction with 5 different female characters. The player has to find the right words during the dialogues and to give Tingle's love interests the best fitting items to win their favor. This is necessary for continuing the adventure. To complete the game, he must have some degree of a relationship with all of the girls, the babes, as they yeah. It's completely touchscreen controls, except for a small dungeon minigame segment in which a control pad may be purchased. Can't see the stream, but I'm certain no programming is happening. We'll get there. It's a technical day. It's gonna be a technical day. You know as well as I do, computer, that in 1 hour I'm gonna be saying right? You know that in 3 hours I'm gonna be saying to Real Nyston. Me and Real Nyston and XOR and A Squared are gonna be saying to each other. You know it's gonna happen. You know it's gonna be like this already. So we gotta, you can hold our horses. Sometimes you have to rein the horses back before I don't know. I need to freaking wire. Okay, don't worry about this. So we won't bother you. I'm speaking metaphorically. I'm speaking metaphorically. LLLL Colonq mod sim. Hello, thank you. Hello, Remblanc, welcome. Anyway, this is gaming. This is what I think games should be about. There's been some good games recently, I feel. I played I guess other things. I did play a game over the weekend. I played a game in the past, like a year ago or so. I think I talked about this, called Golden Idol. Case of the Golden Idol. This is it. And they made a sequel of this. Gaming on stream one day. Literally never. I will never do this. I promise to you. I will never subject you to this. This is my oath. Hello, Azrael IO. I just feel like it wouldn't be appropriate. It would be inappropriate for me to do. When are you gonna play Signal? I don't know. But I played this game, The Rise of the Golden Idol. It's a new type of game. I guess it's like a year old. It's a little bit good. It's like a detectives type of game. There are detective elements. It's kind of good and fun. I enjoyed this a lot. I'm enjoying these sort of deductive reasoning things. I'm trying to play them more in order to get I don't know. It's sort of, well, it's not really a point and click. It's sort of a word discovery sort of game, I guess, right? They're sort of unique in that, like, you click on things and obtain words that describing things, and you have to like fill the word. It's like then you have to fill them in like a Mad Libs kind of style in order to solve the puzzle. But they're like, it's sort of, they're good. They are. I feel like they kind of capture the investigative feeling without being too contrived. They're fun. Hello, Asher0_. Welcome in. And Hidoto also is here too. Anyway, but back to Puff. This is Puff. This is Puff. I have sparred for the first time in my life, and I'm humble. I see. This is Puff. It's from March 2003 from Mark Adler. And what it is a decompression implementation for Deflate that is slow. It is slow, but also it is easy, which is what we are looking for exactly. Hello, Zarek. Also, welcome in. Thank you for the streak. This is Puff. This is freaking Puff. So this is what it does. Shadows of Doubt. That game is peak investigator. Yeah, I need to explore these more. I need to play Obra Dinn as well. I have not played Obra Dinn. We gotta check out Obra Dinn. This is good too. I haven't played fucking I haven't played anything. I've never played a game. But no, I haven't. I badly need to though. It's yes. Hello, the Muffin 4. I apologize for my target. Well, you don't owe me anything. Thank you though. I appreciate this. Thank you for this. I like sort of the you probably noticed at this point, I like being like I like the being overly formal is really funny to me, right? I do this myself all the time. I'm always doing this where it's like I don't know, just being like way too much, doing way too much of this. It's kind of good. Have you ever played Zork? I have not played Zork. I should probably I've played very few. I suppose I've never played this. I've come across Puff. I was looking for simple C++ compression libraries this weekend for a simple C++ web UI service. Ended up just minifying the code into a single file, compressing with Zopfli and XXDing it into the project. I see. I feel overwhelmed, to be honest. Life feels heavy, and the only thing I enjoy right now is combat sports. Well, I hope you can get through this. There's more. It's a big world. It's a big world, and you can ultimately just do whatever you want in it. We used to do this with a classmate in school and refused to help anybody with homework if they did not abide by the code. Yeah, I don't know. These things are good. I like this sort of etiquette. I don't know. It's good. It's nice to be. I don't know. But anyway, this is only decompression, right? This is maybe not suitable for your needs, trap exit, because it only decompresses. Hello, bad cop _ also welcome. We shout out bad cop _ who is cool and my friend. Stuff that hurts the body often heals the soul. Yeah, maybe so. But I think combat sports are cool. I think if you're doing this in a safe way, this is good. But yeah, it is small, I think. Like it is not that much code. It's like less than 1,000 lines of code, lines of C, and it's also heavily commented, which is useful. And furthermore, it's I think they say it's like 1/4 as slow as like the proper zlib implementation of this. So that's not so bad either. But I would like to understand this. That's my goal for today. This is the objective for today. And maybe it's I don't know. Maybe you'd like to understand it as well, because I don't know, if you asked me, tabula rasa to like write a PNG decoder, I would throw up my hands, right? I don't know what this fucking is. But I would like to end today with a slightly better understanding of this than before. This is the only objective. Have you heard about Heaven's Vault? I think it might be a dangerous positive game for you, one that sucks you in until you've completed it at least one time. Has the best realization of discovering an alien culture and language I've seen. What is this? Oh. Moon-to-moon gliding feature. They do have moon-to-moon gliding. Archaeological adventure. I see. I know, there have been a couple of things in this. I know Chance of Sonar, but this is a little bit older. Yeah, I will investigate this. This seems like the sort of thing. I like this sort of feeling. I like doing this kind of investigation. My best friend does HEMA. This is this is like sword fighting, right? This is crazy when they do this. I've seen some like some contests of this where they like go in like the arena in full armor and stuff. Like they're in like an MMA octagon thing, but they're wearing like full armor. This is crazy. Coming out with plastic blades. Yes, of course. I mean, like there's probably I think there's like a relation with like fencing, right? Like there's like it's like longsword fencing, right? As opposed to like what's the guy they do with fencing? Épée. There are like multiple. What is fencing, right? You know this guy. Fencing. You're familiar. Right? There's foil, épée, and saber. However you say this, épée. Yeah, these are the ones. Hello, Agpen, welcome. I've never done this at all, but it always seems very cool. I'm sure it would be. I don't know. Like most things, it's probably like, yeah. It's probably pretty intense, I imagine. I had some friends who were into this kind of thing. My friend has his greatsword license now. How do you sword fight with foil? Like with tin foil? I don't know. I mean, I guess you have to you have to figure it out. How do I get a greatsword license? Yeah, who's the licensing body of this? I assume there's some kind of HEMA thing. I don't even want a greatsword, just the license. I didn't realize they Yeah, I guess this is HEMA here. This is HEMA. You get to be like this guy. You get to go in the Codex Wallerstein. They have the long sword, the rondel dagger, the messer, the sword and buckler, the halberd, the poleaxe, the spear, and the staff. Think of all the chicks you can pull with a greatsword license. I mean, like, I don't know. I feel like I don't know. I guess you can kind of go into this with a babe-oriented interest, but it seems like, I don't know. They do traditional stick fighting. The spear beats all other weapons easily. I've heard about this from time to time. Please get a greatsword license before you get your driver's license, if at all. It would be real. How long does it take to get a greatsword license? How do you do this? I'm searching this on the other greatsword license. I feel like the greatsword is not really the weapon for me necessarily. They're telling me about Final Fantasy 12. The robot is how do you do this? An arrow? Do you need a license to own a sword? I don't think you do. I don't think you do. What is this? Weapon requirements. Historical Fencing Academy. Historical Fencing Academy. This is like requirements to show up and do the fencing. But they don't even do greatsword, it seems. They're doing longsword, rapier, and sword and buckler. This is what they're doing for all age categories. And you have to have all sorts of protection. I see. Okay, I don't know about this. We'll have to learn more about greatsword licensing information in the future at some point, probably. The Hellish Quart is like the perfect game for this. Chaos Infused Y-hander. Yeah, this is more like this. It's more like this, and double black flame spell. The license is just to enable you to fight with that weapon in HEMA. I see. I mean, I understand. I wonder, like, is there like a standard body for this? I don't know very much about like competition for this for HEMA, right? Is there like, I assume there must be some kind of body that does this. Yeah, something like this. Hello, next time. Oh, giant. Yes, they're all making references to a thing. Have you ever tried any combat sports? I'm afraid that I'm kind of frail. I'm sort of frail. I'm sort of like, what is the thing? Like, I feel like I would blow away in the wind like a piece of paper or something like this. I feel like I would crumple like a piece of like a tin foil or something, like a foil. The Haskell qualifies as combat sport. I don't know about this. Please, Stabby, sign here. I can already see the legal issues. Hello, Ice Coding Cat as well. You are long, so you have advantage. Yes, maybe so, but I don't know. I mean, I have a relative who is very, very into this, who does boxing and things like this, and is a pretty good boxer. But I've never done this. You're less frail than you. I don't think this is genetic frail. I think this is lifestyle frailty. I think this is like, I don't know. Are we talking HEMA? Yes. Hello, Big Book of Bug. They're doing longsword fencing. You can be like these guys. Insult everyone here at once? Oh no, I don't think so. We wouldn't take it that way. Yeah. So, okay, the objective today is we need to learn enough about this. The goal is to understand how this goes. And in order to understand how this goes, they're talking about Huffman. They're talking about huff. So in order to puff, we have to huff. We have to huff in order to puff. So we need to understand this. We've looked at this a little bit in the past and we're like, "Oh, we don't know about this. I don't know what's going on here." I think we maybe can learn a little more about it. You should try kendo first. Probably. This is really funny. Yes, Big Book of Bug is good. This is our friends. You gotta know about this too. I was thinking of Hamming codes, but that's the first thing the article says. Not to be confused with Hamming code. Yeah, Hamming codes are an error correcting code, correct? This is yeah. These are error correcting codes. We did something for this a while back, right? We did where is this? Where is this? ECC? We had ECC day a while ago. Where we implemented some kind of simple error correcting code guy. Yeah, here. We did these Hamming 74, these guys. HEMA is kind of the ultimate sport, as it is composed purely of lesbians and dads who make jokes like, quote, smells like updog in here. Is this true? Is this true? What's up, dog? What is up, dog? This is ideal, I think. Yeah, this is a pretty good, I mean, in terms of your statistical makeup, you can do worse than this probably. But we are not approaching Hamming codes today. We are approaching Huffman coding. So what is Huffman coding? Can we learn about this together? I don't know what the fuck this is. I know there's trees involved. I know it's for compression. But what's the deal with this? It's a type of optimal prefix code that is commonly... We learned about prefix codes before. We learned a little bit about this. The idea here is, I think, right, is that it's rather than representing every... say you have a certain number of elements, right? A common case that we might have is that there are 256 possible elements, right? There are 256 guys, right? Or maybe there are, if we're doing like English, like letters, lowercase letters, maybe there are 26 guys, right? There's a certain number of elements, right? And like oftentimes we can do better than representing every element with a thing of the same size, right? This is, you can imagine this, right? And the realization, I think, is that the size that something is, it's like things that are used more often should be shorter, and things that are used less often can be longer, right? So the way you can do this is with something called a prefix code, right? The idea behind a prefix code is it's, you can always, like, things don't share prefixes, right? Let's say you're trying to represent things like with a certain number of bits, right? And you know the letter A is very common. This is like a common vowel, right? So you represent the letter A as, let's say, 111, right? The 3 bits 111. Like, no other letter can be represented, for example, by like 11101. Right? Because this they would share a prefix. You wouldn't be able to distinguish between A and the other letter. You do see, right? This is the property of a prefix code, right? And formally, right, a prefix code is a type of code system, which a code is just a general, like it's distinguished by its possession of the prefix property, which requires there is no whole code word in the system that is a prefix of any other code word in the system. It's trivially true for fixed length codes, right? So for example, if I just like, if all the code words are the same size, right? I can have a trivial code, right? It's called ASCII. All the characters are, let's say 8 bits long or 7 bits long or whatever you want to do, right? All the characters are 7 bits, right? In which case, there's nothing is possibly a prefix of anything else because they're all, right? There's no prefixes. They're all the same size, right? Like, right? There's nothing, you understand, right? But for variable length codes, this could matter. So you can see, for example, a code with code, if you have 2 code words, AA and BB, this has the prefix property, right? But this one, AB, AB, AA, does not, because A is a prefix of AB and AA. You see, UTF-8 is this also. Yes. And you sort of need to be this if you're going to have any sort of variable length thing. I guess there are other ways to do it. But like, yeah. I mean, like, I guess like variable length proof by, right? You understand, right? Hello, Kokupsi. Welcome in. There's a sense where like, how do you say? How do you say? C source code is a variable length encoding, but not a prefix code. Sure. I mean, there's sort of a sense where, non-fixed width instruction sets are kind of this also, a little bit, but they're not quite, right? They have a little more like we tend to attach a little more semantic meaning, right? I don't know, kind of, a little bit. They have to have a little bit of this attribute, right? Anything that's variable length does, right? It basically means you have to, like, if you have something that's variable length, intuitively, right, what it means is, if you have something that's variable length, you have to put something at the start that lets you indicate, kind of know how long it is, right? You have to be able to know when it's over, right? When a certain unit is over, right? Whether that, right? This is the idea. Hello, Wind Up Boy. Welcome, or at the end. It could be at the end too. You need to have some kind of indication that you're done. I guess of course you could also, like, you can imagine worlds that are not prefix codes, but instead you have a separator between each thing, right? You understand. You get what we're talking about. You get what a prefix code is. I think Huffman coding, the idea here is finding such a prefix code that is optimal in a certain sense, right? So given some data, given something, right, we can find such a code. Null terminated strings versus length prefix. Yeah, of course. But this is getting further afield from what this actually is, right? We're talking specifically about, like, this prefix code concept, right? Where we're representing symbols as sequences of bits in this case, right? And we are searching these guys, like, right? These sequences of bits, none of them are prefixes of other ones. You can see right here, right? Like, notice that space is 111, right? In none of these other things is there a 111 at the start. A is 010. In none of these other things is there an 010 at the start, right? There's an 011 at the start. There's an 010. This doesn't matter. This is at the end, right? You can still, you can always distinguish, right? This is 001, right? And there's no 000 at the start either, right? You see, you understand. And this is the table generated from the text. This is an example of a Huffman tree. Hello, Octorinsky. Welcome in. Wasn't it a thing that you can simply stuff all input in an adaptive radix tree and then read that out in the right order and you have Huffman coding? I'm 60% sure that I remember this correctly. There's a good chance I'm mixing something up. Hello, Octorinsky. I don't know. We'll learn about it maybe. So yes, right? And you can see that there's an advantage to this in terms of compression, right? If I take the string, this is an example of a Huffman tree, right? And I emit the bits corresponding to each character, right? These are shorter, by and large, right? These are not freaking, like, these guys are not 1 byte long, or even like there's only so many characters in this, right? But they're shorter, right? Like, if you used 5 bits for every character, which is the least, you could use it for, like, a fixed width thing, this thing would be 180 bits, right? But instead you can bring it down to 135 or 140. You could significantly reduce the space required. So this is a relevant guy for compression. Tree with no leaves that have branches. Yeah. Like, we need to learn about this. How does this work? How does it come together, right? Presumably there's some kind of analysis of, like, the frequencies of each character in the thing. Adaptive radix trees. I don't even know what this is. What is an adaptive radix tree? I should stop pretending to be like, yes, I know what this is. I don't know what this is. Do we know? Can we learn about this? Do they tell us about it on radix tree? Represents a space optimized trie, this guy, whatever this guy is, in which each node that is the only child is merged with its parents. The result is that the number of children, we're gonna have to learn about this. I don't know what the hell this is. I'm sure there is a limit to compression eventually. I mean, there is a limit, right? And the limit is this is like an information theory thing, right? This is like, there is like I don't know very much about this, right? But there is certainly, like, of course, like, you can consider the obvious absurd case, right? Like, you cannot compress like if I have a 2-hour long movie, I cannot compress this to 1 bits. I won't be speaking this much this week since I'm busy moving, but I appreciate the Europe-friendly stream. Of course, thank you. I appreciate this, iResterday. Please, good luck with your move. Also, speaking of this, if you are in the mode where, like, you are a VOD head where you cannot make the streams, I am trying something new. I am trying something a little bit new. there's a new thing that I've been trying out a little bit. I do upload the VODs to YouTube. This is a thing we do. Exactly Black and Exactly Silent. Yeah, you can compress this 2-hour movie, I guess. The VODs go on youtube.com. They're around on there. You may know of this. You may know about this. But there's also a new thing. There's a new thing. It's called youtube.com/@LLLL Meathouse. This is a new thing. Because people were like, I know there's a lot of people who just want to listen to programming. They don't want to listen to me talking about whatever I talk about. I mean, I'll still be talking about that quite a bit, but like, you know, at the very, I think there is probably room for a zone where like you put on the video, and then you hear someone talking about programming right away, instead of hearing me talk about PS1 games for 3 hours. So there's a new thing. It's LLLL Meathouse. It's here. LLLL Meathouse, and this is maybe not be super interesting to the people who are the usual, you know, the stream crowd, right? But maybe it's interesting to people who are watching this later. If you're later, hello. If you're hearing this in 1 month when I upload this, hello. The idea here is that these are very lightly edited. This has like, hello computer, welcome in. Today we're gonna do a little bit of an experiment. It just goes into the meat basically, and there are some distractions and tangents still, but it's by and large it is meat flavored. It has a meaty sort of flavor to it that you see. This may be of interest. I don't know. You have to sanitize the illegal characters before sending back to Twitch somehow. I see. They're doing crime on the VM. I'm eating a sandwich. This is good. What type of sandwich is this? What type of I'm fond of a Cuban sandwich from time to time. I kind of fuck with this heavily when I'm configuring. Yeah, I feel this, right? Also, Big Book of Bug. I don't know. People like this, so we're gonna try and do this a little bit. I don't know. This is the year of Mod and I we swore various oaths. We're always swearing oaths. And we swore an oath on Hook YouTube. Yes, I have this in my real browser. I just don't have it on here. We swore an oath that this is the year of trying harder. We're going to become try hard this year. This is my they're calling this the LLLL try hard era. I've always hated this as an insult, right? People always like, you know, this is the thing. It always ticked me off when people insulted others. We called them a try hard. I think this is horrible. You should try hard. I think it's good to try hard. Just in life in general, I think. I don't know. I mean, I'm exerting myself a little more. I'm eating awful boneless wings from the Amazon Bees DoorDash Ghost Kitchen. This is good. This is a little bit good. Swore a blood oath. Yes, hello Demonov. Anyway, we'd like to learn about this a little bit. What's the deal with this guy? What is the deal with this fellow? Hello, No Darkness Ploxer. Never want to push themselves further. Yes, this was always something that pissed me off a lot. Hello, Violet Marmalade. This really is grinding my gear. No, it doesn't anymore. I don't mean to talk about just like, oh, this makes me mad. This makes me mad and upset. No, because very few things do make me mad and upset these days. But I remember being peeved by people when I was younger, being like, I don't know, like I always was peeved a lot by like there's a certain archetype of person who copes with an increase in difficulty, like in school or whatever, or I assume that's similar in sport or any kind of endeavor, where they claim that they're, oh, I'm smart but lazy, right? I'm smart but lazy, or something like this, right? This is something that pisses me off to no end still, or at least this makes me irritated always when I hear this, right? Because it's like see, I don't know. You've transformed this into like I don't know. I would rather be not smart than lazy, I guess, right? I would rather be foolish and hardworking. It was better off if I was surrounded by people that pushed me. It means I didn't find the strength myself. Yeah, we can do it. We can all do it, and it's not too late. It's not too late for you if you're listening to this, or even if you're not. It literally is not. You can. It's not so dire. Okay. Given a set of symbols S, and for each symbol X in S, the frequency f of X representing the fraction of symbols in the text that are equal to X. Okay, cool. We can compute this trivially. We know how to average things. A sweaty WoW guild helped my career immensely. I feel like, honestly, like MMOs like this, you know of Larry Wall's Virtues of a Program? Yes, this is this is not contradictory, I think, also, but these are, yes, I do agree. What are the virtues? Hello, Liquid Cake 1, if I did not say so. Laziness, impatience, and hubris. I think these are all good. However, this is a different kind of laziness, I think, than the laziness of, like, I will never do anything in my life. Like, you gotta what did they say? One of my personal heroes, John Bon Jovi. What does he say? It's my life and it's now or never. Something like this. It is my life and it is now or never. I am not going to live forever. The shortest path, kind of lazy. Yeah, this is good. Yeah, kind of like this a little bit. Yeah, so we're trying to find this thing. They're describing optimality of like Can we find this? Can we find this guy? The basic technique works by creating a binary tree of nodes. These can be stored in a regular, sure, they're whatever. A node can either be a leaf node or an internal node. Initially, all nodes are leaf nodes, which contain the symbol itself, the weight of the symbol, so the frequency, and optionally a link to a parent node that makes it easy to read the code in reverse starting from a leaf node. Internal nodes contain a weight, links to two child nodes, and an optional link to a parent node. As a common convention, bit 0 represents following the left child, and bit 1 represents following the right child. So the length of a code is the depth, right? Is this the idea? The length of a given code word is its depth in the tree. Is this the concept? Can we look at this tree and compare? Is it the case that the length of the guy is the depth? Are you looking at BSPs? We're looking at Huffman coding, which uses these binary trees. Okay, is the idea that there's a number of children on each node based on the number of symbols in the alphabet? So if we're encoding the bits, right, there's 2, it's a binary tree, right? And so, like, what is A here? A is left, right, left. What did they bring up? Clone this. Clone this. What did they say A is? A is 0, 1, 0. So A is left, right, left. 0, 1, 0. What is space? Space is right, right, right. It's 1, 1, 1, right? So you can see how this tree corresponds to the code and how you could use this tree to decode things, right? Every bit that you read, right, you go down the tree. Right, this is the concepts. Oh yes, it is insane that they wrote this using this. I don't know. Are you applying for elite job? No, never. This is out of our own interest. 37 shares. We're gonna try and learn about the goal is to learn about deflate. I would say that the goal is decode a PNG today, but I feel like that's aggressive and probably requires a lot of header munching that we probably aren't going to do. But having a thing that does deflate is maybe a reasonable goal for today. I would like to learn how this fucking compression nonsense works. Closure seeks work to save space. Yeah. this is the guy. It would be neat to display a PNG though. I think we can do this. I implemented Huffman out of spite once. Okay, so we understand what the tree structure is, right? We're building a tree that encodes the shape of these code words, right? This is the concept. And to decode using this, it's pretty easy, right? All you have to do is given a bit, right? You just follow the trail of bits until you reach a leaf, and then it's like, okay, it's that symbol, and then just restart for the next bit, right? That's pretty easy. Does this make it easier to encode, right? Encoding is also pretty easy, I think, because I mean, like, you find, I mean, this doesn't help you find a letter is the issue, right? This doesn't make it any easier to find X, for example, right? Because in order to find X, you like, this is not a search tree, right? It's kind of the right, like there's nothing in this that, like, in order to find like where X is in the tree, I think you have to, at least naively, you have to iterate over. You have to walk the whole tree, right? Maybe there's another trick. We'll see. But we have a slightly better understanding so far. Okay. Internal nodes contain a weight. We also don't know why they contain a weight. Probably to make constructing the guy easier. Maybe we'll see. We'll see. A finished tree has up to n leaf nodes and n-1 internal nodes. This is just how binary tree works. You index into a hash map array. Yeah. You can build a table to find this. Hello, attic null. A Huffman tree that omits unused symbols produces the most optimal code lengths. Yes. This is Wikipedia. This is wiki.com. Wiki.org. The process begins with the leaf nodes containing the probabilities of the symbol they represent. Then the process takes the two nodes with smallest probability and creates a new internal node having these two nodes as children. Okay, so you take the thing that's less likely, right? The two things that are less likely and put them behind another bit, right? The weight of the new node is set to the sum of the weight of the children. Then we apply this process again on the new internal node and on the remaining nodes. That is, we exclude the two leaf nodes. We repeat this process until only one node remains, which is the root of the Huffman tree. The simplest construction algorithm uses a priority queue where the node with lowest probability is given highest priority. So we create a leaf node for each symbol and add to the queue. This is like not hard. This is not hard at all. Actually, hello, Failure, welcome in. So you just repeatedly split things, right? You repeatedly split guys until you find until when do you stop? Well, when there's more than one node in the queue, when you haven't looked at all the nodes yet. I see. Is there a reason why you don't have to look at a given node twice? Is there a reason for this? I mean, I guess sort of the parent of two nodes always kind of captures the right. Like I guess this makes sense. Cool. So it's dominated by having a good priority queue, computing the tree, right? This is the thing. If it's not hard, we can't do it. Not after you decided to try to always try harder. Yeah, we have to try. We have to. What is this? Is the year of die hard, of die hardman. How many leaf node symbols are you going for? 256 are a big number. I mean, you can probably. I can imagine if I'm predicting how Mafia works here, right? I think there's probably a thing relating to like you could probably do this on bigger alphabets just by, like, for example, on bytes, right? If you consider 2 byte pairs rather than 1 byte, you can, like, there's things you can fuck around with here. We'll just do bytes. I think this is probably the most relevant thing. This is Death Stranding. Yeah, like there's a movie called Die Hard, right? There's a movie called Die Hard, right? I've never seen this. I don't really watch these movie things that they do now. What is this? Die Hard 1988. This is a film. The joke is that this is a Christmas movie. They always talk about, oh, it's a Christmas movie. It's because it's set during a Christmas Eve party, right? It's no joke. I mean, I guess it is, sure. But this is always the thing that comes up. And then later on, there's a guy. They made a new guy called Hideo Kojima, who is a Japanese game developer. It is a Christmas movie, yes. And this guy, he makes video games. He made various games for the MSX. He made Snatcher and Police Knots. And he's been making games called Death Stranding. And they put a character in the game, and one of them called Die Hard Man. I think because the guy likes movies. I don't know. It's a whole thing. I've never engaged with any of this beyond a cursory level, but I think it is funny to say. I think it is. I don't know. Maybe this is like one of the funniest things to me is like making references to things I know nothing about. Like it's really good. Like I think this is fun. How is he? Well, he's connected indirectly to Christmas through this thing. I think, right, through the naming. Right. There's at least a 2-degree connection. A Finnish tree is likely coniferous. Okay. If symbols are sorted by probability, there is a linear time method to create a Huffman tree using 2 queues. The first one. So this is actually. Why would you just not do this? Okay, this is way better. And we also are not. Okay. Also, spoiler alert: we're not going to implement a priority queue in the like. What? How do you do priority queue easily? This is heap. Right, we could write a heap and do priority queue with a heap, but I'm not going to do that. So instead, we're gonna sort and use 2 queues. What is sort and use 2 queues algorithm? Use 2 queues. The first one containing the initial weights along with pointers to the associated leaves, and combined weights along with pointers to the trees being put in the back of the second queue. This assures that the lowest weights are always kept in front of one of the 2 queues. Start with as many leaves as there are symbols, and queue all leaf nodes into the first queue by probability in increasing order. While there is more than one node in the queues, dequeue the 2 nodes with the lowest weight by examining the fronts of both queues. Create a new internal node, as you do with the sum of weights, and queue the new node into the rear of the second queue. So you can do that. This is not so bad. The remaining node is the root node. The tree has now been generated. Once that has been generated, it is traversed to generate a dictionary which maps the symbol. Okay, so you do make this fast lookup table. So right, this is good. Hello, Happy Nora and Nefrayu also. Welcome in, Nefrayu. Hello. This is hello, welcome. If node is not a leaf node, label the edge to the left child as 0 and the edge to the right. Yeah, sure. Sure, you just traverse the whole tree, and then you put in the codes in a hash map or something, right? Like it's not or in an array, right? If we have bytes, we just make a 256 element array. Sure. And time complexity is not obviously generating this is not important because most of the time like n is 256, right? N is not like growing to huge things. Okay. The hello Happy Nora, welcome. Thank you for Janet A3 Wave. This is good. I've got this one too recently. I've been doing this. Janet A3 Wave. It goes like this. This is from our friend Janet A Carr, who is also cool and good. You might know about her, you might not. Okay. Decompression. Decompression is simply a matter of translating the stream of prefix codes to individual byte values. You just traverse the fucking tree. This is not hard. It's pretty easy to do this. I think this is not so bad. You traverse the tree. Hello Salad Forest. Welcome in. We're talking IRL. What about I mean, here they just talk about compression, I guess. This is, sure. I mean, I guess you just use the table to put... Okay, this is not hard to do. Hello, a Statin channel, also. Welcome in. Hello. We have to keep this queue running. We're falling behind. It's evil. It's evil that they do it to us like this, that they subject us to such indignities. We've been subjected to such a horrible fate. I have to wait 50 seconds to do this. We should check out a statin too, who is doing Game Boy programming, which is near and dear to our heart. Okay, we're not going to be proving anything about it probably. So what's the deal with deflate? How does deflate work? Because like when you think about this, in order to decompress things, you need the tree, right? You kind of need you sort of need the tree. So if you're gonna have the tree, you have to like convey either the tree or like the information to reconstruct the tree somehow, right? Like you can't squeeze blood from a stone here. You can't pluck one hair off of 9 oxen. You have to have a little bit of so how does this work? What is the deal with deflate? A deflate stream consists of a series of blocks. Each block is preceded by it's abstainer because you've never boosted, I think, Fabius. This is the concept. You've never used the boost redeem. So you are yes. Hello Lane VT, also welcome in. Hi friends. Hello. We know this person too. Hello. Can we shout out Lane? Thank you for the raid, friends. We're learning about deflate and Huffman coding today. This is the goal. We are going to do some compression. Welcome in IP Savitsky 234 and Sang Durenard. And hey, listen, look. Thank you for the follows. Welcome in. Please check out our friend Lane. Lane is working on a cool language. Lane and or Kalindra working on a cool language called Celis. It's like a sort of a rusty flavored language. I think they just got type inference working, which is kind of very exciting. Hello Razieleron also. Today I learned that variadic functions have indefinite arity. Do you mean specifically or in general? Do you do this with a classifier trained on the console font? Oh no, this is I'm not doing anything fancy with it because I do if you mean does it properly like do things with like how do you say, like the shapes of characters? I don't do this, but you can control it in various ways. You can probably see Lane on the side. It's just code here, but you can put videos on this. Hello Tawny Code Cat also. And thank you Hellpie for the resub. Like you can say stuff. You can change colors of things and letters that are on things. You can see here. You can just send redeems in the chat that do this. And you can put videos and emotes on this also. So it's kind of flexible in this way. Tree friendly scheme. Maybe so. We might do it in our own language. I don't know. Maybe. Maybe we'll do it in our own language. This is sort of appealing. But no, the video thing is it's a Rust program that spits out it like does 3D rendering of a 3D model. It's an animation of this guy, and it just renders it to a little frame buffer and spits it out in the console. And you can also see it in your own terminal. Sorry, I'm just like, I know when people like this, I'm like, I have to show my thing. Does this still work actually? I know we this machine, Colonq.computer, had my host was like, I have to restart you a while ago. No, it dies. No, it dies instantly. I'll figure that out at some point. This does not actually work. He's exploding. I need to finally move everything off of this machine. It's mainly the IRC that lives on there and a couple of other things, but it's just like this random old Debian box that I like manually start a bunch of system controls, like systemd services on. Hello Zia Xenos as well. Welcome in. Thank you for the raid. Thank you. I shall good night and lurk as usual. Thank you, friend. Hello Tobo Wolves. Hello Zia. Zia is cool and also good. Hello. You need to check this person out. Normal raid. Random Debian box. It's just I forget what's on there and I forget how I'm running things. I kind of let it rot. Hello Serial Keck also, and Tobo Wolves and Adam Anthos. Let me shout out Zia too. Zia was playing Valhalla, which is a cool game you may know about. Do you know about this? Do you know about this? Like where is this? Steam VA11H. How I'm just writing this and it's gonna find it for us. That's actually how it is. Yeah, this game from 2016 has somehow remained extremely in the collective consciousness of online, despite being 10 years old. It's kind of good. It's a little bit good. There is supposedly a sequel that happens at some point. It's kind of greatest export of Venezuela. They've had quite a saga on here, the Osukeban games. But it's you have to sort of root for them. But it's a cool game. I think Zia is doing a thing where like she is playing the game according to the dates in game. Right, like they're like it's like a visual novel sort of thing, and things happen at certain days. Right, there are like days of the year. I think Zia is trying to play this game on the days that correspond to the right. I don't know. This is sort of cool. I fell off, yeah, but sometimes you can always get back on. Hello, Spiral VX too. I should say this too. If you're new here, if you like this, what is this? It's guy talking about computer. It's man talking to you. If you're like, damn, I need more of a strange man talking to me. This is our we have a Discord and IRC server that are linked up. This is where we live. Anyway, it's a good game. One day Nirvana, the sequel, will come out. I'm asking. Oh, the BPM. Yes, the BPM is it refers to something. It's called my heart rate. No, I'm kidding. It's my CPU. It's like a CPU load average thing. It refers to the rate at which my heart is beating, but it's a metaphorical heart. It's another kind of heart. It's not a human heart. A squared. This has happened to me recently as well. I've noticed that they do this. I don't know. It sticks around for a little minute sometimes. And the blood pressure is like a disk usage thing, and the arbitrary counter is the number of times people have mentioned heart rate or BPM in the chat room today. The hello failed doctor, welcome in. Computer this is true. It's extremely true. Okay, so what are we learning about? We're trying to learn about PNGs today. If you don't know anything about computer, you've probably heard of this. You've heard of PNG, of portable network graphics. Hello, Res Mason, who has January treating you. It's good so far. It's good as hell. It's kind of good. I think I'm enjoying this a lot. I had a lot of fun at MagFest. I'm having a lot of fun going online. I'm having a lot of fun. I don't know. It's portable network giraffes. Hello, Star Kaiba too. We're thinking about this, and you've heard of this, right? PNG, portable network graphics. I'm Lily. Hello, Lily. Welcome in. We have a new penguin. Yeah, we were discussing this the other day, Niche Penguin. We're actually operating in a 4 penguin paradigm currently. Lily Storm 9. Well, welcome back. Hello. You've heard of this image. You've heard of this kind of image. You see this? It's portable network graphics. It's a kind of image, right? You know about this. You've seen this on your computer before. This is an image that is losslessly compressed, right? You may have also heard about JPEG, right? JPEG, JPEG. JPEG is another kind of image that is lossily compressed, right? They're both compressed, but they're compressed in different ways, right? Where JPEG, if you like compress them over and over again, they get crunched up. They have like artifacts and stuff. They have different styles of compression. There are schools of they subscribe to different martial arts schools. And the school that PNG subscribes to, do I look like I know what a JPEG is? It's the school that PNG subscribes to is called deflate. They use this technique that Phil Katz made 36 years ago now, excuse me, called deflate. And the idea behind deflate is that it performs compression using a technique called huffing. It's called huffing coding that another guy came up when Huffman was at MIT. This is actually insane lore. In 1951, David A. Huffman and his MIT information theory classmates were given the choice of a term paper or a final exam. The professor, Robert M. Fano, assigned a term paper on the problem of finding the most efficient binary code. Huffman, unable to prove any codes were the most efficient, was about to give up and start studying for the final when he hit upon the idea of using a frequency-sorted binary tree and quickly proved his method the most efficient. In doing so, Huffman outdid Fano, who had worked with Claude Shannon to develop a similar code. Building the tree from the bottom up guaranteed optimality, unlike the top-down approach of Shannon-Fano coding. So he literally did this to get out of taking an exam. They were like, yo, you have to either like prove that this is like find the most efficient code, prove the most efficient code, or take the test. And he was like, none of these are the most, we have to make our own code. We have to make our own guy. Hello, Drain Gang Lazar. Welcome in. Also, welcome. We are draining out here every day. The quick draw thing, it's tough to write tech history on the general populace. Yeah. There was something about this. I'm building an online exhibit of classic Mac color pickers, and I've had to address the question, isn't that just an image? Why not, just slap an image on the screen? And part of the answer is PNG is only 30 years old and JPEG is from 1992. Yeah. Anyway. Hello, Bedhead Kitten. The idea behind Huffman coding is it lets you make long things shorter. It's a technique for this, right? And the core idea, right, is let's say I have some text on the computer, right? Let's say I write some freaking text on here, right? Let's say I write, hello friends, hi, right? This is a string on here. Do you see it? Do you see it, right? The way that this string is represented in the computer typically is using there's this thing called ASCII, right? You know about this. You know about ASCII. And ASCII just says, okay, you represent each letter. There's a number that corresponds to each letter, right? This is how we represent the letters. ASCII mean anything, right? We can probably see this in Python if we say like, can I be like this? Is this legal for me to do? Can I say like ord x for x in this? Yeah. So here's the numbers, right? So like H course is the number 104, right? And usually the way they line this up also is computers like working, the convention has become working with 8-bit numbers, right? So typically the way you'll represent a string like this, hello friends, hi, is with a bunch of 8-bit numbers of bytes, right? So numbers between 0 and 255, right? So that's kind of how this lines up, right? There's a big long series of these. But this is wasteful, right? And the realization behind Huffman coding, yeah, ASCII is 7 bits, right? But typically you're not like, it's much easier to work with things if you're like aligning them to byte boundaries, right? This is sort of the basic unit a lot of the time, right? So like this helps unless you're on Windows. Yes, of course, there are endless nuances. So the realization here, right, is that you could do better than using 8 bits for every character, right? And how do you think about this, right? First of all, in just this string alone, we're not using 255 total letters. What are the letters we use? We use H, we use E, we use L, we use O. We use F, that's 5. We use R, that's 6. We use I, that's 7. We've already had E. We use N, that's 8. We use D, that's 9. We use S, that's 10. We've already used H and I, right? So there's only actually 10 symbols we need out of the... So you could already squeeze this into 4 bits if you wanted to, right? And you could squeeze it down even smaller by recognizing that some things occur more often than others. For example, there's only one N and there's only one D, right? But there are 2 E's and 2 I's and 2 H's, right? So you could imagine a world where you use maybe less bits for the things that are more common, and you could maybe get away with using more bits for the things that are longer, right? This is what Huffman coding is, right? Huffman coding is given some text or given some some data, right? That has, right, computing like a representation for each thing, like each like letter, right? Each element, based on the frequency. Hello, Mr. Kingdom Hearts boy. Welcome in, and Sarnal. Yes, we're doing compression today. Yes. Yes. Hello, clap_TR too. Hi. And Just Jane. Welcome in. Thank you for they call this the classic Just Jane dead FF. We shout out Jane too. Does it go? Okay. Anyway. So deflate is built. The thing that like this, you're like, okay, why does this matter to me? Right? It matters because PNG is built on this. PNG is related to this, right? You can see they're talking about Huffman here, right? So what's the deal with this? A deflate stream consists of a series of blocks. Each block is preceded by a 3-bit header. The first bit is like a terminator. If the first bit is 1, this is the final block. If the first bit is 0, there are more blocks. The second and third bits are like they're a little 2-bit tag thing, right? If it's 0, 0, this is a stored raw or literal. So this is an uncompressed section between 0 and 65535 bytes. Okay, fair. If the bits are 0, 1, this is a static Huffman compressed block using a pre-agreed Huffman table, right? So they have already computed this table using the Huffman thing. Right, this table for like, okay, A is 0, 1, 0, but X is 1, 0, 0, 1, 0, right? They've computed this table already, and just for fun mostly, and to learn real nice, and because I have an interest in decoding PNGs eventually, and just for fun, right? I don't know. I was reading about this last night, and I saw like, we're in the interregnum period, so there doesn't have to be a meta narrative motivating this. I just was looking at this, and I saw like the Puff implementation, and I was like, damn, we could do this. But anyway, so there's 2 ways they could use a Huffman table, right? There's either a pre-agreed Huffman tree that's defined in the spec for a deflate, or if it's 1, 0, then it's a like they provide the Huffman table. Hello, Ziona Gavo, also welcome in. And then if it's 1, 1, it's reserved, don't use, haha. The classic. What to stream about? I do this every time. Attention span. Well, in general, my usual method is I try and spend the day before figuring out what we will do the next day. I think this is accessible to you, Ziona Gabo. You can learn about this. Hello, Standard Air DK. Yeah, sometimes we decide the hour after. I've actually realized that there's a tier list to like, and then we don't. Hello, yes, it kind of goes like this. The tier list of like stream is like this, actually. This is good plan. This is number 1 is good plan. Number 2 is no plan. Number 3 is bad slash half-ass plan, right? This is what I've come to recognize about myself. Why are you capitalizing the first but not, because I'm evil? They're all lowercase. I just forgot. Forget. I cannot erase. This is how it goes, actually. I would rather have no plan and figure it out on the fly, but this is when we kind of have some kind of plan. Yeah, sometimes no plan is better than good plan even. The best thing possible for the stream is we get distracted by something very interesting. That is explicitly the best ones that there are. Yeah, and terrible plan is also above bad plan. Hello, Origin _999. Welcome. A half adder is a half-assed full adder. The a half adder is just like this is just like, this guy is he's so small. The half adder is like 1 XOR and an OR or something, right? Is this him? Half adder, or is it 2? Or it's like he is super tiny. He's nothing. There's nothing to him. Yeah. It's an XOR and an AND. He can't even carry. He can't even pick anything up. What you do to not regularly forget things you learn. I forget things I learn all the time. The only way you will not forget things you learn is if you try and use them and apply them. But I think it's also fine to forget, right? Forgetting is like natural, I guess, kind of, right? Like having perfect recall is like an unrealistic expectation, right? Like it's better to like, if you learn a lot about something and you forget half of it, you still like have retained half of it. And then like it'll be easier to pick it up the next time, and you know it exists, right? And you know a little bit about it, and you know like it's like, right, this is like, it's not like nothing is ever like progress or like learning things. It's not like driving a truck forward maximum velocity. It's like ocean waves, kind of, right? Like you move forward and you move backwards, right? You go forward, you go back, right? It's sort of like this. Hello Nico Dio, thank you for the lurk. And sang during an hour. I'm walking the paths by forgetting and remembering makes more sturdy and clear roads. Yeah. This is exactly it. Okay. So what actually goes in the blocks? Most compressible data will end up being compressed using method 1.0, the dynamic Huffman encoding. Instructions to generate the necessary Huffman tree immediately follow the block header. The static Huffman option is used for short messages. Okay, sure. Can we learn about what this actually is? With compress, okay, there's two guys. There's two guys. Compression is achieved through two steps: matching and replacing duplicate strings with pointers, and replacing symbols with new weighted symbols based on use frequency. This is the Huffman coding part. This is like what do they call this? Like run length encoding sort of thing, or like, yeah, not even this exactly. It's just like replacing long like runs with like, yeah, not even run. I don't know. Anyway, within compressed blocks, if a duplicate series of bytes is spotted, a repeated string, then a back reference is inserted, linking to the prior location of that identical string instead. An encoded match to an earlier string consists of an 8-bit length and a 15-bit distance to the start of the duplicate. So they save these guys in 2 bytes. I've been thinking about that. Has the NFT dust settled where you can make the blockchain transactional MMO without worry yet? I will never do this with blockchain, but like, I don't know. I feel like blockchain is too poisoned. Like doing like proof of work, it's too poisoned by speculative assets is the thing, right? Hello, White Fluffy Sin, also welcome. This is really good. Yeah. It's speculation is the hell, right? This is the thing. But like it's the basic difficulty of the thing is that MMO is like uncomfortably close to this, right? Like where were people like making like doing like absurd economic shit online before cryptocurrency? It was like gold farming, right? Like this was a thing like forever, right? Like I remember people have been talking like people like selling WoW gold or whatever, right? Which is obviously against the rules of everything, and I would never endorse this. But this is like a thing that has existed for a long time, right? And like so like fundamentally the MMO thing is just like too close to like, it's too close to this, right? They are brothers. They are brothers. World of Warcraft's brother is NFT. They are brothers. In an evil way. Yeah, the only difference is centralization, right? Which I think actually doesn't matter to most people. Like most people don't give a fuck about like Bitcoin being decentralized or whatever. I give a fuck about this a little bit. I'm sure some of you give a fuck about this, right? But like I like most people care about like I can get rich quick. They're caring about this in right, which it doesn't even matter. I know a guy who farmed this while being jobless back in 2008. He ended up never looking for a job because he was so busy making 500 euros a month. It was extremely silly. Yeah, the fun thing about this is that like it is related to gaming, and you can be good. You can be good at this. The tech is so cool, but the fact it's used for money is so cringe. Yeah, this is how I feel as well. Hello Coos, welcome in. Where is the thing? I've been like, people don't even know the level of shit you can pull off in these video games. I saw this recently. Can I find this? Do they have this? I don't know if I can find this. I don't know if I can find this. I don't know. There's crazy business out there. One of my favorite things to do. I'm interested in like farming in games in general. Maybe I'm like a freak for this. I like if you have housing set, that's enough to do basic living, honestly. Yeah, this is like basically me. Like the like this is this is how I'm making this work, right? Like I'm renting for cheap from family, and then like I have enough funds to like for my living expenses, and this is the certificate transparency, use this stuff for something halfway sane. I don't know. Who knows? Hello Joel 360, welcome in. We love this character. We love this. Hello Musha 68k also. Hi. This is hello. Welcome back, friend. Okay. So they're doing some kind of back reference type of guy with duplicate strings. It's the most computationally expensive part of the deflate algorithm, because they search. This is not just like runs of the same character. This is just like any string that occurs more than once. Big ups to one of the biggest MMO gold farming pioneers of all time, my goat. Yeah. This is insane lore. I don't know. I just like, it's so frustrating because I have so many interests on both sides of this, right? I love being a privacy freak. I love distributed system. I love cryptography. I love hash. I love Merkle tree. I love farming gold in Dire Mall. I love performing the like. I love watching somebody run around as a mage in Dire Mall for 40 minutes, collecting all of the mobs, and then cheesing them by doing pathing abuse, right? I love this. I love every one of these things individually, but you know, I don't know. So how frustrating. Anyway, this is gonna be, we're gonna have to figure this out. I think actually this is one of those guys that is hard to compress but easy to decompress, right? Like computing this is sort of annoying, I guess, but you can always just like not do it. But then also like using it is easy, right? Using it is you just dereference the back reference, right? You just look at the thing and you put it in. So that's not very hard. And then the next step is the Huffman coding. So what the hell is this? This is okay. Can we see? Sure, they talk about Huffman coding. Sure, a tree is created containing space for 288 symbols. 0 to 255 represent the bytes. Okay, 256 is the end of the block. You stop processing if it's the last block. Otherwise, start processing next block. I see. I don't understand why. Don't we already have like a last block indicate? Maybe this is a different type of block. The 257 through 285 are, when combined with extra bits, a match length of 3 to 258 bytes, and these are not used, reserved, and illegal. I don't understand what these guys are. What are these fellows? A match length code will always be followed by a distance code. Based on the distance code read, further extra bits may be read in order to produce the final distance. The distance tree contains space for 32 symbols. I see. So there's another tree. They have another tree. They have a 288 symbol length / literal tree and a 32 symbol distance tree. I see. For the okay, good. Had this level of concern over compression instead of 200 gigabit every. I mean, this is the kind of stuff that the game developers don't have to concern themselves with. This is the sort of stuff you just get if you do zip, right? Like this is just like what you get when you do this. I know, yeah, there was that thing recently with Helldivers where they were just like duplicating all of the data to try and improve load times or something like this. Like they had some. What was the idea behind this? Right, that there was something with like probably like I don't even know what this was. I don't even know why they did this. You can imagine something with like some disk thing, but like I don't know. Yeah, this is what libraries are for. No one is writing this except for us. Because we are like, you should not write this probably. This is the exact kind of like ideal code for libraries, because it is like very generalizable and also needs to be very fast to be good, right? Seeking performance suffering during without duplicating data for sequential writes. I see. The hardware has become so expensive that programming resource-friendly games will become a thing again. Yeah. Yeah, and PNG also doesn't know about this, right? PNG, this is just like what PNG has in it, right? PNG presumably is just like there's some metadata, and then there's like, okay, here's where the data is. And then what the data actually is inside of it is this stuff. Hello Greymouth, welcome in. Okay. What to learn? I love being forced by sheer hardware needs. It's kind of good. I don't know. It will be interesting to see if this produces outcomes, but I feel like it's unlikely. I keep thinking I need to buy more RAM now before it gets worse, like how stock people say buy the dip. Here's a deflate stream in some format. Yeah. Okay. Do we know about what kind of this? Do we know about what kind of this, how this works? Do we know about what kind of... It would be interesting to find... We'll need to find some deflate files before we mess around with other things. But for real project, these are not tasks to add to your plate. These tasks are serious projects in and of themselves. Yeah. It's fun. Like we're gonna write like a bad implementation that we don't want to probably use very much. I mean, maybe it's worth using for like loading some PNGs or whatever in a little game project or something like this. But we're not gonna drive the whole world on this. Okay. Use it all the time. Yeah. Do we have like a do we have an RFC of this? We do have an RFC. This may also be worth looking at. Yeah, good. Bring him up. And he is maybe more worthwhile to read than just looking at. They use zlib format. So I guess a good place to start is like, it seems like there's going to be a lot of nonsense just getting the tables, right? Like if we look at the Huffman table thing here, right? So there's two trees here, right? There's two trees here. These are encoded as canonical Huffman codes by giving the bit length for the code for each symbol. This is canonical Huffman code is a way to store Huffman. It's like a special Huffman code that has properties that let you store it easily, right? And then the bit lengths themselves are RLE'd. So it's like right. So they have like it's like compression of the compression thing, right? Because obviously like these are gonna like be a lot of space potentially. Okay. Maybe they'll talk about this though. They talk about their goals and things like this. Sure. The specification is intended for use by implementers of software to compress data into deflate format and or decompress data from okay, that's exactly us. It's intended for us exactly. They want us to do this. I have 64 gigabytes DDR4 I'm criminally not using. This is kind of, it's probably better to have it. They want us here. A compressed data set consists of a series of blocks corresponding to successive blocks of input data. The block sizes are arbitrary, except that non-compressible blocks are limited to 65535 bytes. Okay, a reasonable number. Presumably they have a 16-bit size somewhere. Each block is compressed using a combination of the LZ77 algorithm and Huffman coding. The LZ77 thing is the what do you call it? This is like the back reference guy, and Huffman coding is what we are studying. The Huffman trees for each block are independent of those for they're entirely within a block, right? Which makes sense. You can also probably be better doing this, right? Because like a Huffman tree for a specific input is better than like, you can kind of imagine this, right? Like it's more tuned to like, I don't know. The LZ77 algorithm may use a reference to a duplicated string occurring in a previous block up to 32k input bytes before, right? So the LZ77 thing doesn't, right? It doesn't care about the blocks as much, right? It's just on the whole ass input, which is also sort of fucked up. The RFC 15, this is 1951. Each block consists of two parts, a pair of Huffman code trees that describe the representation of the compressed data part and a compressed data part. I assume they mean every non-compressed blocks. The Huffman trees themselves are compressed using Huffman encoding. Okay, we need to learn about this Huffman encoding thing also. What's this? What's this? What's this canonical Huffman code? Canonical Huffman code. I think this is what they're talking about. A canonical Huffman code is a particular type of Huffman code with unique properties which allow it to be described in a very compact manner. Hello, Kanusaru. Welcome in. Rather than storing the structure of the code tree explicitly, canonical Huffman codes are ordered in such a way that it suffices to only store the lengths of the code words, which reduces the overhead of the code book. So presumably they're putting this in such a way that there is like a right? You can sort of imagine this, I think, right? I can imagine that being a thing you can do, right? Maybe you like you have some ordering of the inputs, and you can use this to kind of squeeze them into a bind, like knowing their lengths, which tells you what the depth is of the tree. Got a boost and go to enjoy the sesh. Thank you, Asento. Good luck with whatever you're doing. We will be rooting for you. Thank you for stopping by. Regardless, it's very kind of you. I appreciate this a lot. I may have found a big beef recipe that is a banger. A Scottish dish called mince and tatties. What is this? What is this? Mince and tatties. Oh, mince and taties, maybe, is this. This is potatoes. Hello, Mexico. Welcome. It's a Scottish dish which consists of minced beef and mashed potato. Other vegetables or thickening agents are sometimes added to the dish as well. It was frequently served as part of school meals in Scotland during the 20th century. This is sort of ideal, I guess. There is no set recipe or form of cooking. It consists of varying amounts of minced beef. Is minced beef just ground beef? Yes. Onions, carrots, and other root vegetables, seasoning, and stock. I have no rotten food in my zone. I would never allow this. Meitsuka is live, given that she's here. No, I think she was live when I went to bed. Meitsuka, there's no way. There's no way about this. Extremely United Kingdom food picture. Please check out Meitsuka, who is cool. Yes. Someone on the Discord IRC drew a cool image, a goodnight computer image with a fox in it, and then someone I think Lotus was instantly like, "Is this Meitsuka?" And I was like, This is crazy work, but we do need to make people aware of who Meitsuka is. If you don't know who Meitsuka is, you should know this. They're cool and they're doing cool programming. Are we scranning it up? I mean, I've said this before. I feel like I'm actually I feel like I'm predisposed to like UK food. I love this. I love this. I'm sure, like, I've never tried this, but I'm sure I would love an eel pie or something like this, or whatever the fuck they're eating over there, right? I love this stuff. I feel like it's like baked into me to like be like, yeah, I want to eat like meat pies. I want to eat like meat and mushy peas, right? Like, I see these things on Scrandle that everyone makes fun of, and I'm like, that's like what I eat. That's like what I'm making for myself in my natural habitat. I'm creating these things independently. Our RFC 1950 and 1951 related? Who knows? Anyway, what's this canonical thing? Okay, this paragraph is just telling us that it's important it's important to have it be short. Eel is very good. Please melt the cheese on the fries. Like I'm eating just like cheese daily. Like I'm eating just like bread and cheese and like pickles and stuff. This is like what I eat. Okay. Since a canonical Huffman codebook can be stored especially efficiently, most compressors start by generating a normal Huffman codebook and then convert it to canonical Huffman before using it. Okay, this is good to know. In order for a symbol code scheme, such as the Huffman code, to be decompressed, the same... Okay, you need the same tree. In standard Huffman coding, this model takes the form of a tree of variable length codes. This introduces two critical inefficiencies. Okay, it's expensive. It's expensive if there's many symbols, and traversing the tree is costly. Canonical Huffman codes address these two issues by generating the codes in a clear, standardized format. All codes for a given length are assigned their values sequentially. This means that instead of storing the structure of the code tree, so there has to be some notion of ordering. This makes sense. Instead of storing the structure of the code tree for decompression, only the lengths of the codes are required, reducing the size of the encoded data. The thing I remember about Huffman stuff was that single bits operations are kind of fun to make efficient. Like, you're constantly bit shifting and needing to store where in the current byte the bits you care about are. Yeah, we did a little bit of this before. We wrote this very poorly with like a bit stream abstraction for the Clippy thing, right? The canonical Huffman algorithm converts a standard Huffman codebook into a standardized or canonical form. This is achieved by ordering the symbols according to a clear convention. First, sort all... Okay, it's literally... Okay, it's what we thought it was. You just do the Huffman thing and then sort things that are the same length. Okay, fair. But then you have to adjust them a little bit in order to have them be like in... Sure. Thank you for the streak also, Masica. Thank you. It creates a variable length code to every symbol in the alphabet. More frequently used symbols will be assigned a shorter code. Sure. The letter A has been assigned 2 bits. The bit lengths stay the same, with the codebook being sorted first by code word length and secondly by alphabetical value. Okay, sure. But how do we know that the first three length symbol is 101, right? How do we know to start there? Each of the existing codes are replaced with a new one of the same length using the following algorithm. The first symbol of the list gets assigned a code word which is the same... Oh, they do that. Okay, that's literally what they do. Okay. The first symbol on the list gets assigned a code word which is the same length as the symbol's original code word, but all zeros. This will often be a single zero. Each subsequent symbol is assigned the next binary number in sequence, ensuring the following codes are always higher in value. When you reach a longer code word, then after incrementing, append zeros until the length of the new code word is equal to the length of the old code word. This can be thought of as a left shift. By following these 3 rules, the canonical version of the code book produced will be this. Okay. This is understandable. And this causes the prefix rule to be... This works because you're appending 0, right? So like every one is a drop. Okay, I think I like this. You can also consider them as a fractional binary number, sure. Okay. This is cool. Okay, can we start doing some programming? Let's start thinking about this a little bit. How are we gonna write this today? How would we like to do it? I think probably we will look at our... I mean, who knows if we even get... We'll figure it out, right? We're not even on deflate yet. We're just on the Huffman guy, right? And let's of course do it in eLisp. This is the most useful thing. Can we get a slash marker? I've never used this in my life. But I sort of, I don't want to, because I sort of object to the idea that this is the, I don't know. I don't want to create a view of things where like the talking about things is nothing and then the programming is the something. It's in the mix. It's in the freaking mix. A diagram to see what we understand. Well, I think I'm gonna write. Let's do the Huffman thing. Just I think we do understand enough probably that we can write a thing that at least does some Huffman stuff, right? Can we call this what do we call this? Like let's just call it deflate for now. Time to break out the UML. Oh no. Oh, this will not be a Rust file, I fear, real nice. I fear this will not be a Rust file. I fear we may have worse things in store. What does Salad for S think about this? Is this real? We were over there on Sunday. I don't know, we played some Yume Tuki. This was kind of good. We gotta go. Oh no, my friends, none of this. Can we go back? I'm going to grab a seltzer. There's no seltzer in the house even. They took it all out of here. It's all gone. Anyone still do UML still? I'm sure there's people doing big UML. Can we call this deflates.el, please? Okay, here we go. Here we go. I was pressing Alt S in Blender. Today we're doing eLisp. We need this in eLisp most of all, right? Because right now we have no good way to load images into eLisp, right? We have this shitty Farbfeld thing, but we're constantly calling PNG to Farbfeld. So we need a good way to do this. Haskell January 2026. It's 2K26. eLisp is a terrible. Why is it terrible? Is it terrible by virtue of it not being fast? Well, yes, it's not fast, right? It's not. We're not aiming for fast. We're aiming to understand something. eLisp is sensible. It has decent data structures, right? We have things we can use. We'll be fine. I think we'll really be fine. It's good at throwing trees around. We'll be okay. Deflates/Huffman coding. Okay. So what are we doing about this whole thing? The year of owl Lisp on the desktop. Hello. This is kind of true, maybe. And fighting analysts, welcome in too. Stick with your tools, craftsmen. Who up generalizing their classes, RN. It's an RN sort of situation. Can I click buttons? Can I be a button clicker today? Okay. What's the first thing we should do? Well, we want a way to generate a Huffman table from a way to convert a unibyte buffer to a single integer. This would be good, isn't it? Right? I think probably isn't even named .puffer. Isn't even named puffer.el. Yeah. You know what? We're gonna rename it just for that. It's called puffer.el. Now we've changed his form. His form has been modified now. Okay, this is what we call him. Okay, let's define some things. Do we want to? Well, the first thing we want, I think, is a way to generate a Huffman tree from a string of text, right? This seems like a fun thing to do, right? Just like, or let's say this, right? Let's say require cl lib, and let's say cl def struct. I don't know, what do we call him? P Huffman, P Huff, and P Huffman. Yeah, I mean, this isn't too bad. Again, we're gonna write again. You could expect our version. We're going in with this with the expectation real nice. And expect our version to be orders of magnitude slower than a good version. But we are not trying to make a fast version, right? We are trying to obtain an understanding. Huff new. And what do we have in here? We have some kind of we'll have some kind of hash table. Let's call this I don't know. Like symbol codes, ht creates. And then of course fighting aliens. This is good. If you need a sub, just ask me also. I don't want to just like be like if you're like, damn, I need a sub, these ads suck, you can literally say this at any time and I will give you a sub. This is fair. Hello Prowcash's friend. I like it because it's funny. I think it's the funniest one of all. And there aren't many other good options, I guess. Like, we're already using Q. W is a little too overconfident because this indicates victory. Victory, I guess. All the vowels are sort of out. I don't know. You know, you have to pick one at some point. I think L is a pretty good one. It also has like it's humorous, right? L, it's like losing, right? What do they say in that one song? The shape of an L on your forehead. The shape of an L on your forehead. It's like this. Anyway, we also have the tree. We have the tree. And our basic guy here is going to be P Huff, right? I think this guy actually, I don't think this defines a guy like this, right? P Huff, we're free to define him ourselves if we wish. Or let's call this generates. And this is gonna take some string s. Generates Huffman, like what do we call this? We call this Huffman. It's in addition to the tree, I guess. What do we call this guy? What's his damn name? Where's this guy used? I don't know. Like, let's say Huffman tree for S, right? So S is some string. We need to get, first of all, we need to get the bytes of the string, which is the thing we're always struggling with. It's always fucking miserable. Like, if I say hello, right? I can say, like, seek into hello list. Wow, it's bytes. Hello Kinslayer. But I think this is actually evil. Like, if I say, like, insert char cowboy, this is evil. You can see this does not do the right thing, right? There's like a thing you have to do, like, it's like string to, is it string to unibyte? Yeah. String to unibyte on this? No, it's string as unibyte. Yeah. Yeah, okay, that's what you actually do. You have to string as unibytes. And then yes, it made him say if I slay. Bob the tree, P Huff daddy. Actual decoders like to build a table you can index with the next n bits to figure. Yeah. Well, this does it for us, right? This gives us this string, saying string as unibyte and then converting it into a list gives us a list of bytes, which at least is kind of sensible. I don't know. Maybe we probably also want some kind of abstraction for a bit stream. This is something that's going to come up again and again. So let's call this bit stream too. Still proper code back into emoji. I mean, there's no way to. There's probably is a way to be like, yeah, this is UTF-8. If I say string as, like, this is not useful. I don't know how to. Yeah, it's probably, is this also? Yeah, this is also obsolete. You're actually supposed to say encode coding string, which is actually way better, probably. Coding string, and I can tell it explicitly what this is. If I say UTF-8, okay, that's much better. And then I can also say, like, seek into this string, and then decode coding string UTF-8. And this does not work. This is evil. So that's sort of unpleasant that it does that. I don't actually know why. It's probably that the string is not the right way. If I say string, I don't know. We'll see. Hello, Doc East. Thank you for 18 months. Also, welcome in. Good morning. So how do we fix this? Seek into maybe does something that we don't want. Seek into maybe very strange. Very strange computer. Like, what is the result of this without this? It's just this, yeah. And why does, like, very strange. Very strange. I don't know why we don't round. If I do it without the conversion to lists, does this do anything? Yes. So somehow the seek intos are lossy. So what is just encode coding string? This is this, and it has what is the... Is this just printed this way because of pretty... like, these are not... Seek into seems to make multi-byte strings. Yeah. We're like double encoding, right? Is what's happening here. This is the thing. It may actually be better to just never do this with a list anyway. I think we probably want to just use the string. Yeah, eList does it in a particularly horrible way because they represent these as the same type. Hello, Maud. Welcome home. How are you doing? You feeling okay? No? I'm feeling good. I'm doing well today. We've both been a tiny bit under the weather. I think Maud a little more than me. Maud has been very under the weather recently. Do not use a string. Well, of course we could use a buffer, but I don't want to use a buffer. I don't like using buffers. I'm kind of a buffer hater a little bit, honestly. I think when you use a buffer, you have to worry about so much additional stuff, right? You have to make sure the buffer is unique, right? So that you could have this thing be re-entrant possibly, or you have to... It's more annoying, right? Need to find something to eat. Have a good rest of stream. Thank you, Standard Air DK. Please enjoy food. Enjoy food. You can apply, yeah, we can apply Unibyte string. Yeah, this is the thing. This is the general thing. This is kind of gross, right? Like, we've certainly done this in enough places, but like, I think it's best just to not use a list. We'll just use we'll just use this proper. How long is this? It's 10, right? It's the right. I just don't understand why it prints like this, and it prints like... I mean, of course, this is the actual character. This is this thing being pretty... I don't know. It's funky. There's some funny business happening. But I think this is what we want. I think it's probably that unibyte and multibyte strings maybe get printed differently. Like, this is like a canonical... I don't know. There's so much weirdness surrounding this, but we'll just find the right thing to do and just do that forever. Okay, let's call this bitstream new. Let's call this... What do we need for a bitstream? Well, we have a string, and then we have two things in it, right? There's two things to be aware of, right? I mean, really the best thing would be a vector of bytes, I guess. We can probably do that. Like, it's not like we really need to round trip. Seek into probably does this for us, right? If we seek into this vector, yeah. How do we get data from a file? F-read bytes. Which probably uses a buffer internally, of course, but like it's fine. It abstracts this away from us, right? I don't want to be thinking about buffers at like during my thing. And like where point is. Like, this is all very grossly... It's stateful in a way I don't want to deal with. Hello, Kevin RPB, though. Double. Triple, even. So we have who is F? F is a third-party package. It is f.el. The DFU fuck. Hello, Trader Tinks. Welcome it. Is this a mistype situation? You're trying to type somewhere else. Hello, welcome. Let's call this bytes. Bytes is, I don't, whatever, it's nil. We have an index. We have an index. And we also have a bit index. How do we do this in our little Rust guy for Where is clippy.rs? How are we doing this over there? I think we thought about it a little bit over there. Yeah, we did. We literally did this. Okay. Classic. Cool. Let's start like this. We can make these guys. This is like this, right? Why am I writing it in a horrible way? Yeah. Makes a unibyte string. Yeah. It does make a unibyte string. We'll probably use that eventually, right? But there's also a world where we want to, yeah, we're not going to mess with it ourselves, right? Really, the thing that we want is a vector of bytes, right? So like, we either want freed bytes will handle this in some cases, but if we have a string already coming from Emacs, like we just need to know how to get a vector of bytes easily, right? Because we're gonna play with it in the REPL a bunch at first, right? That's what we'll do. Okay. Regardless, it's worth being aware of this. What are the bitstream things that we want? We probably want defun p bitstream that takes like, in this case we want an abstraction for a series of digits, sure, but that's like what we want, a vector of bytes, right? This is the guy we want here. They call this natural. Well, I mean, maybe they call this what do they call this? They call this functions from a natural number to this, right? This is what we really want. We want a function from a natural number to a Boolean. But this is also not the representation that is the most amenable to our manipulations. You take I don't know, a string. That's slow. It's slow, but I mean, again, your approach, you're approaching this from 10 different angles here, right? It can be fast or it can be clean, right? The thing, you're silly. Don't let me tease you. I was thinking about this the other day. I feel like we have a very adversarial mode of communication, real nice, where we're always kind of butting heads about things, which is sort of inevitable because, like, I don't know. This is you tend to get technical about these things, and we tend to be like. And I hope you never take offense to this. I definitely don't mean to be like I hate you. I like you a lot. Thank you for coming around. I'm a big fan of the. But I hope you know you don't have to fight if you don't want to, right? I don't mean to. In fact, it's all right. I'm not trying to create war. Yeah. The how you get disqualified in my job interview? Yeah. Okay. Can we say create let's call this from string. Create a new bitstream from the string s. Say neovim sucks one more time. Can we encode coding string? This is the guy we want, right? Yeah. UTF-8. Hello, Rayman Grove. Also, welcome in. Thank you for the follow. Seek into vector u. Can we p bitstream new bytes this? Just not good enough. No, I don't think so at all. I think honestly, again, Emacs is hardly even a text editor. It's just I want this to work so we can test it on guys, just so it works in general. Yeah, good. Good. And we'll also have a bitstream from file if we want to, right? And this is easy enough to this can be like if I say fread file today.txt, what's your problem? Your fread bytes, of course. Right, you give me a unibyte string, right? So I can just say directly seek into fread file path vector. Sure, all is well. Create a new bitstream from the file at path. Good. We'll have these for the future. And require f, please. Text buffer based operating system. Some people disagree. Yes, of course. It's certainly not for everybody. Your fread bytes again. Don't make the same mistake we made twice. Okay. What are the operations we want to have on bit streams? Can we also say, like, I want to have, like, can we call this, I don't know, can we call this bit streams? Can I also say, do we have outshine? We don't have, I would love to fold, oh, we can fold on these, hell yeah. I don't know why it folded all the, why can't I just fold functions too? Since when can I do that? Since when does that work? I set a lot of goals for 2026 and I already feel the weight of them. I think you can do this, right? You know, like, it depends on if your goals are super ambitious or not, I guess. Tapple has kneecapped my, oh, I apologize for this. I have set you down. I mean, a fun thing to do is to try and implement some of the type systems in Tapple, right? Just read, like, kind of read casually for a while and be like, okay, I'm gonna implement a little type lambda calculus, right? Like, this is kind of good, right? You can, they're often very accessible, especially if you're like, I think they like, there's a lot of like ML source code, right? So if you're writing, like, a lot of them will be very easily portable to Haskell. If you have an interest in this, you can definitely write some little type checkers in Haskell as you go through the book. What are the basic things we care about here? Right? What do we care to do? Well, we want to read 1 bit, right? We want to be able to read 1 bit. This is basic operation. What is the interface we did in our Clippy guy? Read 1 bit, read multiple bits. Like, if we're only popping, this is kind of fine, I think. Let's just do that. Let's call it pop bit. ELIS functions first class values? No. Not in the sense, it's a Lisp 2. So there's a separate, there are function values, they're in a separate namespace though. So normally you pass functions around by passing their name, which is effectively the thing. Yeah. And there are like lambdas obviously that you can pass around, but like this is also its own can of worms, how this works. It's closer to common Lisp than the scheme. It's like sports betting, but for my feeling of overall correctness, yeah. It gives you the function somehow, either as a name or as some kind of closure object or something like this. So what's the deal with this fucker? What's the deal with this fucker? Hello, Ben Chilling 1. Yo, hello. So there's a couple of checks we need to perform, right? When IDX is greater than or equal to the length of p bitstream bytes BS, right? We're like, I mean, honestly, this is unless, right? We return nil if that is the case. How are you doing, Ben Chilling 1? Welcome. If we are in range, then what do we need to do? Well, we need to get the byte at index, right? We need to say val. I don't know. Val is, you know, the byte. The byte is I'm sick but optimistic. This is good. I hope you feel better soon than Chilling 1. Hello, Led and Jin too. Welcome. Looks like assembly. This is usually not a bad bet for the stream. This is Emacs Lisp. We are implementing Huffman coding. Is the idea. We're gonna try and do some compression and decompression, but we also do write assemblers a lot on here. On any given day, there is probably a reasonably good chance we are doing something like this. But not today. Seek alt p bitstream bytes bs. P bitstream. We also need to. There's probably a way I can there's like a fancy guide to like deconstruct guys, right? I think there is. I know there are some cool guys for deconstructing like binding keys in A-lists automatically. I wonder if there's a guide like this for EIEIO objects, which these technically are. Is there a way to install an Arch package from an unstable repo, but only until it hits the main repo? I'm unsure, but I'm sure someone here knows. Old McDonald. Yeah, this is what they call the object system. Have you read about refined types? The what do they call this? Refinement types? refine like this kind of thing. What is this in like Liquid Haskell? Yeah, I haven't used Liquid Haskell very much, but I know some people who were very into this, right? Who were very involved in this thing. This stuff is cool. It's like it's a little bit different from the sort of like it's like a different approach, right? Like the dependent types people like want to like right. So doing like dependent types in like Colnq or Idris or something like this, right? Typically what you're doing is you're like you're defining like say you want to like like write the type of like, I don't know, like all odd integers or something, right? Like the way you're going to do this in something like Idris is you're going to like define like odd integers are basically like they're like basically, or like the odd natural numbers are basically just like the odd numbers, right? And you're just gonna like define them this way and then have operations behave differently, right? Whereas here, right, you're and then you're like it's like very like constructive, I guess is the way you would say this, right? Whereas in Liquid Haskell, right, you can just like write assertions just as like normal code, like shit that returns a boolean, and then just like have an SMT solver check them. And this is cool for a lot of things. I have done a lot of stuff like automated theorem proving built on top of SMT solvers. And the sort of the snafu with these guys is that it can be very hard to know what sorts of things that Z3 or Yices or whatever the guys are able to handle. This is the thing, and I assume that the Liquid Haskell people also have this kind of problem sometimes, right? Like it's very difficult to know what the limitations are because it becomes just like, okay, what can Z3 handle? And what Z3 can handle is not at all obvious usually. But this stuff is very cool, and if you have any interest in this kind of thing, it's worth checking this out. This is different from this, I think, Big Book of Bug. This is like can we see this? Do you know about TLA plus? I know about this, but I have not used it. I have not played with this guy at all. Yeah. I would love to hear about if you have any experience with this stuff, Ben Schilling. I did this. I was kind of in this little. Yeah, this is all related to formal verification for sure. This is like this is a formal verification tool explicitly, right? Just reading for now. Hell yeah. I worked in this area for a long time before I was streaming. So I have some difference to Colnq and OCaml. I mean, Colnq is written in OCaml. Colnq is an ML. Colnq has a much more powerful type system than OCaml, in the sense that it's more expressive. You can express more things. It's dependently typed. Colnq is not Turing complete. Colnq, I mean, so we're talking about Colnq or Rock or whatever, right? I mean, OCaml is also French, right? OCaml is also like an INRIA thing. RPC 2.0. I'm pretty sure. In comparison to Liquid Haskell. Oh yes. So they just have a different approach, right? Like how do you like the way Liquid Haskell works, right? Is you define sort of restrictions on types, and then these get through, like the type checking basically happens inside of an SMT solver that just like tries to like resolve, like make sure your thing all like lines up well, right? Make sure your thing, like basically as you write these types, right, you're basically creating like a big formula, right? And that big formula states like, okay, is the program valid on all, like for all variables, right, for all inputs? And the SMT solver's job is just to be like, can I find a counterexample? Writing in Colnq, it's kind of more like you're defining structures, and then you can like it's more of like a how do you say like it's like a constructive logic versus classical logic sort of thing. It's kind of hard to explain if you're not like into it, I guess. Writing in snake case, asking for solid reasons. Oh, this is Metal Gear joking. I don't like the piano numbers like cons for 0 than 1 like in others, but I think one and others are just suck. Are just hello
so
Kappa 5421. Welcome in.
We don't have your name recorded.
And Zoltix underscore. Hello. Also successor. Yeah.
Record your name. We're supposed to record your
yeah.
name
It's just
now,
like a different
please.
approach.
Okay, we're gonna do.
It's a different way that it's
Thank
done.
you for the sub also, by the way.
Does that make sense? Are you using Haskell? I write a lot of Haskell sometimes, and I wrote Haskell for work for a long time, but someone just asked about liquid Haskell, so we've been talking about it. Hello, Luminary Shade. Welcome in. Are you a Haskeller? Some are saying it's Haskell January. We're currently writing eList though today. I think did you use Ada? I have never used Ada also. Yes. I probably should not even say that. I feel like the amount of information I have collectively given out about like what I was doing for work is enough to exactly identify who I am at this point. So like it's finished the first version. It's called Unhinged. Well, this is good. They took the damn hinges off this. Can we pop some bits, please? Bitstream, I can send the repo, and you're welcome to do this if you like. It might be easier to look, we have a Discord IRC here. If we ask don't ask you mean the, what do they call this guy? The, Akinator? Hello, Kali Shinrei, also welcome in. Get Bitstream IDX. BS. Okay, sure. So what do we want to do with this guy? Can I share you something? I mean, you're always welcome to. You can share stuff if it's good, if it's cool. Even if it's not cool, it's fine. If you think it's cool, that's good. As long as it's just like it's not like a crime or like. I see. What is this? Is this like some kind of Gumroad thing? Is this like an ARG? What is this? This is crazy. Oh my, is this like is this robot? This is cool, I guess. I don't know what to make of this, I'm afraid. This is yeah, I don't know. I hope you had fun. The Computer the IRC channel. Yeah, there's a Discord and an IRC. The everything, there's only one channel in the Discord and they're linked together. Capstone at runtime, this seems absurd. I don't know. Well, maybe. It's maybe not the worst thing if they do like, I don't know. Anyway, let's get down to business then. We have a given byte. We need to get a thing. We need to get a thing off of this byte. We need to get the bit at index BIDX, right? So this is also not hard, right? We just need to say like the bit is what is the guy LSH byte by BIDX. LSH the byte by negative BIDX actually, right? This is the concept, is we want the bytes from least significant to most significant, presumably. Did they say this in Deflate? Do they have a feeling about this? They probably do. But in general, I feel like least significant bit to most significant bit is the right order. This is something sort of distinct from endianness, right? This is like a bit order question. The packing into bytes. Here we go. That seems promising. The variable number of bytes. Bytes within a computer do not have a bit order. A byte considered okay, it does have a most and least significant bits. Sure. Sure. Okay, wait, so there, for as far as the bit stream thing goes, byte rather than we describe. Okay, sure. They don't specify this maybe. We'll put least significant bit first. This is fine. So shift over by this, and log into this with, I don't know, this guy. Can we orient this in a way that's not going to cause us to be horrified? Okay. And then we just need to increment IDX and BID, or we need to increment BIDX and then IDX, right? So like we say CL incf the BIDX. Also, this should be BIDX. P bitstream BIDX. It's postfix. Oh, this is really good. It transpiles the CU at self-hosting too. This is really exciting. Okay, to be honest, I misjudged you. I was like, because people are always coming in and being like, well, I made this thing. It's like, and I like to humor this a little bit, but this is very cool. Potentially, can we we are fans of Forth and things like this around here. I like the how do you call this? Like the postfix languages a lot. Have you seen Factor? This might be something to investigate. If you're interested in the postfix sort of stuff, and concatenative languages in general. Factor is pretty cool. It has some, it's sort of annoying in some way, but it is a very cool thing. Hello Ivalon, welcome in too. Hi. Well, you can't just assume these things real nice. And you have to make it right. You gotta. I don't know. I mean, this is a very niche thing. I would not assume anyone has seen Factor. But maybe they have. Zed Shaw is or was a big Factor fan. Oh, I didn't know this. I'll bother him about it at some point. I know Zed Shaw was looking at Raku last night, which was kind of good. Okay, increment BIDX, please. Can we just do this? And then get it again when it's greater than or equal to 8. Then we set it to 0. We increment IDX and we set F BIDX to 0. Okay, that seems fine to me. Maybe. Legit thing. Unicode characters all over the place. Yeah. Another thing you might be interested in if you're in this space, is like the APL sort of things, right? Like Weewa is basically this. This is sort of a real guy, right? This is sort of a real fellow. Yeah, APL is my inspiration actually. Weewa is a postfix array language that is like an APL sort of fellow. This might be a fun thing to play with. But it's like kind of has an intention for like, this is like a, I don't know, the people like this this guy here. Anyway, I've heard mention of Factor, but only understand how a Forth can be functional style, though I do not know concatenate. Oh yes, so the basic idea behind this big book of bug is, so Forth, it seems like it's a very stateful sort of guy, right? It seems like, okay, I'm popping and pushing to a stack all the time, right? This is a little bit different. Thank you for the quarter-century resub, the Yellowberry HN. It's crazy how old we're all getting. Welcome in, though. I appreciate this. The idea is, instead of thinking of the language as pushing and popping to a stack, you think of it as composed functions. Big Book of Bug. This is the idea, right? So instead of it's sort of hard to type these guys well, right? Let me write test.hs here, right? Instead of thinking of like pop as a guy that modifies a stack, what if I thought of pop as a guy that's like, I don't know, like this a little bit, right? Like maybe he's a little bit like I don't know, like let's say we have like an integer. I'm gonna monomorphize this just for the sake of the demonstration, right? Right, maybe he's a little bit like this. I like this rest equals rest, right? Maybe it's a little bit like this, or maybe swap something like this, right? Maybe swap is something that's a little bit like this. Right? Do you see? Do you see kind of going this way a little bit, right? Y, X, right? Do you see? It's sort of hard to type some of these guys well, but like you get it, right? You get that there's kind of like this sort of concept, right? And then your program is just like a bunch of compositions of these things, right? And there are obviously difficulties. You can't really do like the fourth style control flow, but you can do like higher order functions well, which is what factor does, right? Like factor, it's all about like they have a way to like quote things, right, which is basically a lambda, and they have ways to like, you know, perform, like see here they're saying maximum bot, they have age, which is just like this is like a quoted function age, right? And then right, you see, right? So it's very focused on, yeah, this is very cool, right? It's sort of like, you can sort of imagine it in a, like, it's very like a point free Haskell, right? Like you can imagine like Haskell, like when you're writing in like this point free style, a lot of the time you're writing like you know, with the dot, right? You're hitting them with the dot occasionally. Like, and there's a style of code that you write, you just kind of chain. Lumi is a big fan of this. If you've ever seen the Haskell that Lumi writes in the Discord, Lumi is always writing these very point free programs. I would say that like something like factor or like the concatenative languages, they're kind of like they're a functional language that's more focused on function composition than function application. Maybe is the way to say it. I don't know. Or like the structure of the programs is like this. What is the streamer etiquette when watching someone else? Do you stroll in there as Colonq, or you adopt an alter ego and slide under the radar? I think it depends a lot, right? I mostly just use this account. I don't really have an alt account that I use these days. I do. I mean, there is etiquette. Like, I don't know. I mean, etiquette is all in the eye of the beholder. I do feel a little uncomfortable. Like, I don't. The worst feeling is like, how do you say this? There is sort of a thing, right? Like obviously, like on Twitch TV, like there's kind of like people are on the grind set or whatever. People are trying to like become popular or whatever, right? So like there's always a sense, like I always have like a worry that I'll be perceived that way. I don't wish to be perceived. Not really partial application, just like composition of functions, right? The like rather, right? Like you can think of your program as like a big chain of composed functions. Yeah, in general, the rule I think that I like to follow is like, I definitely like not mentioning that you are a streamer is the thing to do, right? Like, I think it would often be sort of a faux pas to like go into someone's chat room and be like, hey, like, you know, even if you're a little bit coy about it, right? Even if you're like, well, I did on my stream the other day, I did X, right? This does sometimes come across as like, I don't care, of course, right? You can say this here as much as you like, right? I'm going to recognize that you're doing this, but I also don't care. So you're welcome to do whatever you know. I'll tease you about it maybe, but I'm not going to be bothered. But like this is generally something I like to. I basically I just like talk like normal. I mostly I'm a bad chatter. I only post emotes, right? Like I'm like I go into the big chat room and I just type this. I'm the guy posting this, and this like every day. I don't know. Hello pasta linguine pepperoni. Welcome in too. But in general, I think that the etiquette is to not mention this. Of course, it's difficult sometimes, right? Because it's like sometimes I go into a place and a bunch of people are like immediately like, oh hey, I had a thing earlier today, right? Not to be like weird about I went into someone's chat and then someone was like, when are you streaming? Like they like respond to me and they're like, when are you streaming? And now I feel bad, right? Because it's like, well, I want to respond to this person, right? Because like they care about what I'm doing, but also I feel like I've gone into someone else's thing and like just like made it all about me, right? Which is, so I don't like, I usually just don't respond to these sorts of things, right? And sometimes I'm weird and like if people like say hi to me elsewhere, I'll like DM them. I like spam DMs on them and like be like, hi, I don't want to like clog up because I have like a Thank you HRR, and welcome in RK Atomic. It's mostly just like the thing I like to be aware of, right, is that when you're in someone else's chat room, it's their thing, right? This is their thing, right? So like it's best not to any like I don't know, but yeah, Listening to yappers. Yeah, me too. Me too, big. And of course, everyone has their own standards for this, but this is just what I like to do in general. Learn a bit. Yeah, I feel this. Okay. Can we let's star this, please? Can we also return the value? Okay. Is this a sensible looking bit stream for us? Pop 1 bit from bitstream. Yes. Pivoting. We're so back. Yeah, this is a fun thing to look at. Okay, they're yelling at us about this. Does it actually hurt us at all to use? I think it's all positive. We can use ASH and not have the warning. Okay. Do you have an interest in this question, 37 chairs in particular? Like, is there something you're trying to, like, I never know, like, I think these things are so interesting. I don't know. It's probably kind of indulgent, but I am just, like, generally interested in, like, I don't know. Like, I'm a freak, right? I don't have a good read on, like, social dynamics intuitively. So I have to go out there with my little microscope and my pith helmets. I go out there with my like little pith helmet and microscope and something. Yeah. For someone like Zed, right? I usually just lurk over there because I don't know Zed very well, right? And we're not like you know, we've hardly interacted. I think we've like raided each other a few times, right? So I don't know them very well. So it's the sort of thing where mental clear. Okay, we got to lock in. But it's the sort of thing where like I'm I definitely don't want to like go there and then it becomes all about me and they're like confused about this. So I would typically just lurk. But if I'm in like Prod's channel or something, or like I will say things because like we're friends and we know each other. Hello lolcat swag. Welcome. Can we have pop bits NBs? Pop bits NBs, and you know what we're doing? We're just calling it multiple times. We're just calling this thing multiple times. Meow, real. This is kind of good. We love posting meow in the chat room. Okay. How does this go? Have you ever heard of the Esterol language? I don't think I have. What is this? What is this guy? Oh, I see Esterel. This is another Inria guy. I see. I have not heard of this at all. Is this like a concurrent? This is very cool. Okay, yeah. I will like. I have not seen this at all. From Bitstream BS, building mealy state machines. This is very, very cool. Can we just be like I mean, I guess we can just do times it, right? We can say let ret is 0. Do times what's your flavor? Can I give you underscore? Is that legal? Can we legally do this? And what is result? Result is evaluated to get the return value. This is deprecated. Okay, we don't care about this. You are just p bitstream pop bit b's and setf ret. What's the order we're going in? We're going freaking least significant to most significant, right? This is the concept. This is the freaking concept. So we should how do you say? I guess we can go. What are we doing in the Rust side of things? Are we actually popping these guys backwards over here? Oh no, we're doing the right thing. Okay, we'll do the right thing too. ASH this by I guess we should just keep track of this then, right? This by the shifts, and we should set this to log your ret this, and we return ret. Okay. They produce finite state machines. Programs written in SRL can be formally verified. That's the question. Thanks for the answer. Yeah, this is cool. There's so much just like the field of this kind of stuff is so broad. It's unreal. There's just so many things. Like it's crazy. Okay. Do we also want? I mean, I think this is fine for now. Can we test this? Right? Can we say, like, if I say p bit stream from string, and I say, I don't know, setf test bits, how do you extract the data from OpenCFace and use it for your avatar? I have a custom guy. Hello, Serial. You don't have to call me boss if you don't want to. Also, people just started doing this out of nowhere. My ego is big, but it's not this big. I'm not this evil, but you can. It's fine. We kind of it's less like boss, like you're the boss of me, and more like I don't know. Like it's like calling your friend boss. I do this a lot too to seem relatable to others. In order to have the character of like a Uncle Buck type of character, I'm always going out to people and saying, "Hey boss, hey big dog, hey hoss, hey horse, hey hello big horse," and things like this, right? Does this exist? No, it's private. It's privet. Can I get this? We have role. Can I get clone git at github.com LColonQ role? Can we get him? I have my own little fork of OpenCFace. I was originally using their thing more. Now I just make it talk directly to my message bus. I eventually am going to use like MediaPipe or something instead of using OpenCFace for this, I think. Calling Da Ren. Seni Ursa. I don't know who this is, I think. They're streamer. I don't know them. I would probably say hello. I'd probably say hello. You don't know me. Sup big dog. Yeah, you should do this for real. Oh, speaking of this also, I don't know if we have any Europeans in the crew right now. There's a thing coming up called FOSDEM. There's FOSDEM. I pretend not to know them. No, you can pretend to know me or not know me to your leisure. I know it would be kind of embarrassing to be seen with me in public. There's FOSDEM soon. This is in the 31st of January and the 1st of February. It's a weekend this year. And this is how do you say? People are doing a little bit of a meetup here. I will not be there. However, they're doing a little bit of a meetup, I think. You should inquire after this in the Discord IRC if you're interested. I know there's quite a few clonkers who are going to be there. This is a thing. At least 5 people at this point. This is crazy. I'm very glad people are. Yeah, this kind of rocks. Anyway, I have a little guy. It's just a guy on top of OpenCFace called Roll. And Roll just connects to my message bus. It just runs the OpenCFace tracker guy in a loop, connects to my message bus, and sends the relevant info. Oh, I see. So I won't tell anybody about this. I'll keep this secret. Don't worry about this. Well, it's called Roll after Fig Roll. It's after this, right? Because it's all Fig themed. It's after these guys, which is like a big Fig Newton, I think, right? From Asia Minor. They invented this in Asia Minor. It's like I don't know, something like this. It's a Fig roll sort of. Anyway, can we say things like, what if I'm saying like what if I say words? What if I say p bitstream pop bit from test bits? It's 0, it's 0, it's 0, it's 1, it's 0. That's 5, 6, 7, 8. What is this number? If I say 0, 0, 0, 1, 0, 1, 1, 0, this will be backwards. This is the wrong number. It's backwards. But if I say 0, 1, 1, 0, 1, 0, 0, 0, it's 104, which is the right freaking number. I forget that a squared can read ASCII bits, can recognize English, recognize like the letters in this is a powerful skill. Does multi work? Does multi work? Or can we do this? If I say 8, wow, it's 101. It's the right guys. What happens when we die? Can we go off the end? You can split it into 4s, yeah. I guess this helps, right? And then it's just knowing hex mode, right? Okay. We get integer p nil, and that's evil. This needs to be we need to do early return here. We need to do early return. This guy should probably be something like, I don't know what he should be. We can't really early return easily here. Maybe we can. Is there just a return guy in who knows? Who knows, I guess. Let's sort this out a little bit here. Let's say when let bit this we do this, or I guess it could be an if let sort of situation. Otherwise we set f ret nil, and we could also put this guy in a little bit of a situation like this. We could say you gotta be ret has to be true too. They both have to be true. It's a double truth. We're doing a double truth on it. And this can be like this. I think this is acceptable. Can we redefine the guy? Remake him. Spawn him in. Now if I say this, wow, we're getting numbers, and then if we go off the end, wow, we get nil. Okay, that's kind of good. I like this interface a little bit. So there's bit streams. How can we go from here? Let's think about huff. Can I fold this now? Is that a thing that's allowed? Yes, we can. Good. I can almost somewhat read American Braille visually, still learning this one. This one's really useful if you're trying to play Pokemon Sapphire. If you're hopping on Pokemon Sapphire, and you somehow forget how it works, this one's really good. I have a not so secret code 128 puzzle that no one ever seems to notice. I see. A really silly thing I taught myself. I can read 128 barcodes by eye. I see. This is insane skills. How should I name my computer? He needs a name. I mean, I feel like it's often you want like a naming scheme for the whole thing. We don't even need this to create. Of course we don't, but we will need this eventually. Hello, sun too. Hi. So generating the Huffman tree for S. For the string S, right? The first thing we're gonna do is we want to get the string bytes, of course. The bytes. It's gonna be seek into how do you say? How do you say it? How do you say it? Encode coding string S UTF-8 UTF-8. Yeah, we'll want to peak in addition to a pop, right? These are, but we probably want peak bit and peak bits also eventually, and maybe even random access, which is something we can do. Like read n bits from starting from this bit, or starting from this bit index in this byte. Like these are all very doable. Convert this to a vector. We have a bunch of bytes now. So the first thing we want to do is compute frequencies for all the bytes, right? That's pretty not hard. Compute the frequency table for bytes, right? This is pretty easy. We're gonna return a hash table. We're gonna iterate over the bytes. We're gonna write. It's not so bad, right? This is ht create. This is each in bytes. Can we iterate over a vector like this, or are we in hell? Is this a thing that we're allowed to do legally speaking? No. We are in hell. There probably is. There's like a seek map, right? Is there seek each? There is seek each, but of course it's not. It's arguments are in the wrong order, and it's also not anaphoric. And it's also not documented. It's also an alias for seek do. Okay. Cool. Well, regardless, we can make do. We can certainly make do. So for every byte in here, right? We're mapping over bytes. We're returning ret at the end. For every guy in here. Oh yes, also this is a thing we do. We say hi to Sun. Sun comes in and says hi, and we say hi back. I don't know who wrote this, but it's been written in stone since the beginning of time. When Sun, this is the order of things. This is how it's set up. Thank you, Lol. This is, I don't know. It's one of our traditions, I guess. We're doing it like this way. A little oh yeah. Okay, can we CL incf ht get ht get ret x0? I think that works. Does CL incf hate us? CL incf hates us. Does it hate this? It doesn't like the default value very much. You know what? We're gonna write this without using setters. We'll say get 0. We'll say +1. Or well, we just use this. This is fine. And then ht set ret x. This guy. Okay, good. Okay, so we can get the Huffman frequencies of some bytes. I can say p huff freaks. Get me some freaks, please. Can I have I don't know. Seek into, I'll just use a normal string, it'll be fine. Hello world. Hello world. Vector. Can you show me what the hash table is, please? There we go. Hello Machka6 too. Wow, we get various frequencies. What is 111? What is 108? What is 108? What are these guys? 108 is this. How do you know my name? I'm scared. Oh, do you know each other from elsewhere? Is this it? What is this is L, this is O, right? These certainly seem like letters that are repeated in Hello World. Okay, good. Okay. Okay, we have bytes, we can get freaks now. So freaks is p huff freaks. I have not even memorized the ASCII table. I have not. I confess, I man ASCII and search through this every single time. They gave us freaks. And then this is a matter of, well, there's two things we're going to want to do, right? We're going to want to compute the tree using the algorithm that we know, right? And we're going to want to yeah, freaks was a proposed name, I think. We're going to want to, I read this in the one book, you know the book. We're going to want to canonize this, canonicalize this, whatever the word is, right? We want to convert it to the canonical form, I think. Yeah. Let's see this. Let's go. So what's they give us the funny algorithm, right? There's a funny 2Q algorithm to do. Which I figure is probably what we should do. I mean, it's not like any of these are going to be particularly hard, right? We could, you know, like we could do this in O(n) log n time, right? If we had a priority queue, but I'm not going to implement a fucking priority queue right now. So we'd be writing it in n squared time because I'd be, you know, doing a linear search over the list to get the lowest priority every time. So in fact, I think we'll do the dual queue thing. The dual queue thing maybe is, I think we probably have some kind of convenient double-ended queue that we can work with. I think this is a thing, right? ELISP has this. There's a guy for queues. We can get away with that. It probably even is fine. Is it double-ended though? I don't know if it is. Queue create. Constructor of objects for type queue. Do we know about you? Oh, I see. You can add them to the front and the back, and they can be removed from the front. This is good. This is what we really need. You can use queue and queue prepend. Good. You can make them. Good. Okay. What library is this? Just queue. It's built in. I'm pretty sure it's built in. Yes. No, it's an ELPA library called Q. Well, sure. It is third party. Where is this from? Who is making this? No, this file is a part of Emacs, it claims. So maybe it is built in. Maybe it's on I don't know actually. It claims that it is here. But yes, I mean, honestly, a lot of these guys do not have. This is sort of the most consistently fun part of doing this. Copying, yeah, who knows? Anyway, we have two queues, right? There are two queues we have to consider, right? There is the initial queue and there is the combined queue, right? There is the IQ, right? There is the IQ, and there is the CQ. These are our dual queues. And what do we do with them? We have to populate the initial queue with we have to sort them by probability first of all. We should just do this in Huff Freaks. Which I guess we have to do it here like this, right? Like can we say symbols? Symbols is HT keys freaks, right? It's all the symbols that actually occur. And then can we sort by we can sort by a comparator, right? We want to sort by a comparator. And the thing we want to sort by is, we can get a comparator like this, right? We can say on I don't know, this, and then something to transform these guys, right? So this might be, I don't know, lambda s ht gets freaks s. I think this should sort by frequency. We can see about that. I mean, for now we can just return symbols and see where it leaves us, right? Like if I say p huff generates foo, right? Is O 102? No, that's F. I think we're sorting the reverse order. Like if I say FF O, if I say this, it's putting the least, of course, because we're doing this. Let's say I guess we do want less first. We want least common first because these are the guys we're going to DQ first to combine. Okay. Good. So first of all, we want to enqueue every guy in symbols, right? So for every fellow in symbols, we want to queue appends. IQ, no, not queue append. We want to queue NQ. IQ it, right? This is the guy. It might be an ELIS file skeleton written with Emacs maintainer colored glasses, right? Can we get Q also? Okay. Then what? So while there's more than one node in the queues, right? While there is like we probably want to like have a thing like this also. Can we have huff queues? Or rather CL defstruct the queues. The constructor, I don't know, P. What's your flavor? Are you evil? Are you evil for this? Hello Zarithia, welcome in. Q losing its meaning real fast. We're gonna say it 100,000 times. Huff Q's new. Did I watch YouTube Colonq that I started this morning or Groundhog Colonq of the Now decisions? Hello Pete's Eater, welcome in. I mean, what's streamer programming right now? Oh, you don't need to admonish us. We're working on. We're trying to learn about compression a little bit. I don't know very much about this. Maybe you don't know. Maybe you don't know very much either. But we're gonna try and learn about it together. Hello, Pete's. Can we shout out Zarithia too, who is cool? And also Pete's, who is cool. And also Yellowberry, who is cool, and others. For third party is I see. Okay, well we have the IQ, which is a make queue, and we also have the CQ, which is a make queue. I want to do this because we're gonna need a function to like pop the lower guy. We're gonna need a guy to like, you know, honestly, let's just put the freaks in here too. Let's put the freaking freaks in this. Let's get them free. Let's get them a little bit freaked up. Oh, this has to go around the whole thing. I forget. Yes. Okay. So for this, we could just say, I don't know, Q's. Q's is P huff Q's. New. Freaks. Like so. Hello, Tomwhile. Also, yes, of course. I would prefer if you watch Twitch and keep me company, but you're welcome to do whatever you want. I have no, you know. I think if you're speaking tactically, you know, I can detach myself from my, you know, sometimes like as a commander on the battlefield, it's a circumstance I find myself in fairly often, right? As a commander on the battlefield, sometimes you have to deaden the heart. And sometimes you have to detach yourself from your personal feelings about the situation and speak purely tactically. And I would say if I'm speaking purely tactically, because it probably depends on you know what you're interested in more than anything. I think yeah, I don't know, that sort of fizzled out. Perverts pronouncing DQ as like deek. It only outputs from one end. Yeah, it's not a double-ended queue really. It's like a half guy. As workout podcast in the mornings. Yeah, this is convenient because you can pause it. This is true. Is this a good format? People who watch, like, do people like this? I think this is how I'm going to proceed for the year. I don't know. Maybe the meat house thing is freakish, but like I think it's kind of good. Let's call this. Let's make a few guys here. Let's call this P huff Q's huff Q's adds internal. I have hired an editor. I actually have 2 videos edited that I have paid for that I have not uploaded yet because I want to. I don't know. I'm agonizing over them. Say hello Snecrowave. Welcome in. That doesn't count then? How does it not count? I've done this. I think it's more an issue of can we call this initial? Hello Snecrowave. Welcome. I don't know. All is well really. I don't know. Things are going well. Let's call this V. Let's call this V. We want to enqueue these guys as nodes. Well, I guess the leaf nodes are what is a node? Well, a node in this case is going to be either an integer or a list, I guess, is how we'll consider it, right? That's fine actually, I think. It faded to black with the text of several hours of unrelated yapping later. Yeah. Okay, let's consider. Maybe re-edit. Yeah. I thought having someone else do this would solve this problem for me, but it has not. Now I'm like, I don't know. Add V to Qs. Sure. You're just Q and Q into the IQ, right? You're fine. You're just this. P huff Q's IQ V. Q's V. You're not bad at all. Okay, do we also have adds how do you say this? Add a what do you say about this? Adds like, what are we calling this? CQ constructed? Constructed is what we're calling this. Compound or something. Combined probably is the thing to do. And this we want to put it in the front, right? Well, no, we put them in the back. Okay, this makes sense. I guess we're always putting things in the back. Okay, you're CQ. This is fine. You are P huff Q's add initial Q's. Convert a tree to graph is probably pretty easily. What's next then? So I think we're gonna do it like this, right? So every node in the tree, a combined node is a list, right? Where it's a list of the weight, followed by the left and right side, and the leaf node is just an integer. So in general, right? We can say things like defun P huff Q's like pop least. I don't know. Return the head, the smaller I don't know, pop the smaller side of Q's, right? This is what we're going for, right? And we probably also want a guy to determine the weight of a node, right? We probably want defun P huff node weight, or node freak rather. I don't know. I guess we have the frequencies here, so we could say like huff. Well, I guess we don't really. Well, we're fine. We'll deal with it. We can say like this. No, we do want this. Huff Q's node freak is what we'll call this. And this will, given Q's and a node n, determine the weight of n given Q's, right? Because we're storing the freaks here, right? So we can say here, in the general case, we don't know what the fuck this is. Unknown node type, and you are n. If this guy is integer p, then it's ht gets p huff Q's freaks. Get the freaks out of there. Bring up a freak or two if we can get away with it. Otherwise, hello Dental Dam. Also, hello. Welcome in. Dental. Well, it's spelled D-E-N-T-L Dam, like D-A-M-N. You hate it as much? Sorry, my mod was just like, I hate that. No, I don't know. I might love it. I don't know. I don't know for sure though. This is just Car and welcome in though, Dental Dan. I'm sorry to immediately subject you to some kind of interrogation procedure. Welcome. Hello, welcome in. We have iFreak which is p huff q's node, or not buff q's, huff q's node freak of q. Can we not peek? Can we say q head? Q head? Oh, this is the struct accessor. This is evil as hell. This is evil. Q first is what we're gonna look for. Okay, this is, man, these names are the devil, aren't they? They really do evil stuff to you. P huff q's IQ. Q's. There is the I freak. What about the C freak? The C freak is the exact same thing, but it's on the CQ. And then it's just a matter of saying, I don't know. We want whichever one is least, and I guess we'll prioritize iFreak. Like, it doesn't actually matter, right? Apropos library. I didn't realize this was a thing. What is apropos library? Variables and functions defined by so is it just all? I see. That's kind of cool. I assume it's like the library in the sense of like the file dot. Well, maybe not. I don't know. This is kind of good. Freak instead of freak for some reason. Yeah. Okay. Anyway, if less than C freak I freak, then it's then the answer is Q. Is there Q DQ? Do you remove from the front? Yes. Q DQ of like this guy. This fellow. Otherwise, it's the other fellow. Otherwise, it's this guy. The other problem is that these guys could be nil. These fellows could be nil. There could be a nil type of fellow situation. I think we can probably handle this sort of nicely in a whenlet. If we just say, if we replace these guys with like IV, right? Presumably Q first will return nil on an empty Q, right? Q first make Q. Surely you don't return, you don't throw an error. Thank God. Thank God, computer. Okay, CV is then this. And then you can be CV. Single ELIS compilation unit, as it were. Yeah. They have like the notion of like, what's your problem? Oh, you need to have Qs on you. You need to know about Qs. That's your whole reason to live. Okay. We can pop least from Qs now. I trust that's reasonable. Okay. When we're generating things, we want to pop 2 guys for this, right? We want to pop 2 guys. This is what we require. And we should actually just, rather than nil checking this, I think we're just going to add a condition that at least 2 guys exists. Let's call this P huff Q's at least 2. This is a very awkward and specific function name. Return non-nil if Q's have at least 2 elements. And this will just be Q length of huff Q's. Let's say we can actually just be like length. That's probably better. Return the combined length of Q's. Maybe a little nicer here. IQ of Q's and Q length P huff Q's CQ of Q's. Okay. Double length mode. Okay. You have not a space. This can just be okay, while we're gonna want a tree in progress too. There's a tree in progress too. But I guess we just get this out of the, there isn't a tree in progress. We're actually just setting, we're gonna mutate pointers in the, so it'll be okay, I think. We'll get away with this. Can we say while greater than or equal to P huff Q's length Q's 2. Honestly, it's easier to listen while it's greater than 1. what are we doing here? Well, while there's more than one node, we dequeue twice, right? We just take the two least guys, right? We take the two least guys and put them as the children of a new node and enqueue this. So this is actually very easy, right? Like we have C1, which is P huff queues. What are we calling this? Pop least queues. We have C2, which is pop least queues again. And then we're just going to enqueue this. We're just going to say P huff queues add combined. And it's a list of these guys, right? We need a way to get the weight. We have a way to get the weight. We have puff queues node freak. Right? So first of all, we have to sum these guys, right? So this can be plus P huff queues node freak of C1 queues. Add this to this of C2 queues, right? This is the combined weight, and then we have C1 and we have C2. This is good. This is good as hell. And we never actually. Okay, I think this is actually all we need to do. And this is guaranteed to terminate, right? Because we're popping 2 every time we add 1, right? This we're adding this 2 queues. And then the final result, the final thing is we just need to pop from either of them, right? Which we cannot just reuse pop least for, because this is illegal, right? So honestly, we can just say P Q DQ P huff queues IQ queues or this or the CQ, right? We know there's one element left, so we just take whatever one is not nil. Does this work for us? Is this good? No. Wrong type argument P huff queues 102. Well, that's no good. We're calling something in the wrong order, probably is what's going on here. I bet we're fucking something all up. Can we get this in a way that's amenable to? We say huff generates hello, and we run this. You'll yell at us about it. Okay, what is the problem? What's the problem with you? What are we saying here? What are we saying on this guy? We're trying to enqueue in something, and this guy is it's inside of the call to add initial. What are we saying in add initial? Add initial. Oh, it's the reverse order. That makes sense. Okay. And now we're trying to add 2 things that are nil. Why would node freak return nil? What is your problem? What is your problem? Why would node freak ever return nil? Well, I guess the thing could maybe not exist in the frequencies, or it could. Well, let's see. Let's say node. We can just say let's res is this for now. And we can say message node freak for this, and it's n res, and we return res. Okay. Okay. Do we have messages? Well, we have node freak. We're calling this on nil in the first place. So why is that? Why the hell does this happen? Where do we call node freak? We call node freak in 3 places. We call it here. Yeah, I know about the debuggers, but we will not use them. Of course, this could be nil. I mean, well, no, the whenlet will fail if either of these are nil. So this is impossible to call this on nil. It's only possible that it happens down here when we queue these guys up. With C1 and C2. So one of these guys is returning nil, which is crazy because the length, that should not happen, right? The length is greater than 1. The length is greater than 1, so therefore C1 and C2 should always be... Let me just message what C1 and C2 are. Yeah. Yeah, anything that changes the window configuration is not very... Yeah, like there is potential... They are both nil on the first call. Are we just not returning... Oh, we're not returning the pop, probably. Yeah. That's what's going on here. Where's pop least? No. Why are you nil? Well... Can we see what's going on here? Message pop lease, message... Here. I bet we're just failing this whenlet probably. Can we see? What's going? Yeah, we're not even getting in here. So why is this? Oh, because there's nothing in. Yes, of course. We're doing this fundamentally in a silly. This cannot be like this. This cannot be like this. This should be more like this. If IV, then this. Otherwise, it should be some... I mean, I guess we can just bind... We can do it in a way that does not involve like us having to construct some gross value. Let's say this. Let's say cont and IV CV. Or rather, let's say this. If we don't have IV, then it's the like we want to DQ the C case, right? That's what we desire. If we don't have CV, we want to DQ the I case, right? If we have and not IV, not CV, we want to return nil. Otherwise, we have both of them, in which case we want to compare them. Right? That's the remaining case. Yeah. This is it, I think. Something kind of sensible. Something vaguely sensible. Okay, well that's something. Here's a little thing. We have one tree. There's only 2 characters here, obviously, so it's not very interesting, right? This is just telling us nothing, right? It's telling us 0 is O and 1 is F, or vice versa, maybe. The other way around, I think. What if we give this a longer string? I don't know, if I say hello world. Welcome back, Fade. Well, that gives us a little bit more of an interesting string, or interesting tree, doesn't it? Can we see about this? Can we read this somehow? Right? Like, what is 119? 119 is W, right? So this is a guy who's pretty far down, right? It's telling us that W should be the left side of this. Like, W should be 111, right? W should be 111. I guess we should come up with a thing that maps the characters to their codes. That's the other thing we need for like the result of a Huffman guy, right? So in addition to just this, so I think that's fine. Let's say, I don't know, tree. The tree itself is this. What should we do in order to map every guy to his corresponding code, right? We just need to traverse the tree and keep track of where we are. Right? The easiest way we're going to do this is just like let's write this call. Let's call this huff. We'll do this very statefully. Let's call it, what do we call it? Symbol codes. Symbol codes is ht creates. We'll make a new hash table, and then in order to populate this guy, we'll just call this, I don't know, populates symbol codes, given the tree, and given symbol codes and the tree, right? I think that's fine. And this can be like this, and then we can, at the end of this, we can just say p huff new symbol codes tree. So what's this populate symbol codes thing, right? This is our remaining guy to write. P huff populate symbol codes. What's your deal? Well, you need to take the tree, and you need to take a hash table, and you need to fill the hash table based on what is around, right? Based on what is in the tree. And this guy, we'll just make him be recursive, right? This is what we shall do. Well, we have codes, we have tree, we have fill codes based on tree. We should also have a path that is the current path to this guy, right? Based on tree positions rooted at path. I don't know, something like this, right? So what should that path be? We should start off with the path just being 0, right? Although I guess this isn't very good either, right? 0, we need to distinguish 0 from the symbol 0, right? It's kind of annoying, isn't it? Right? Like there has to be like a, I guess we can just make it nil at the start, and then we can handle it specially from there. So how will we do this? Let's think about this. Let's think about this a little bit, right? It's just a big cons, right? If integer p tree, right? Then we're just saying set f, or rather ht set. Hello, thank you. Thank you. Hello, Alpha Links 00. Thank you for this. This is kind of good. This is kind of good for real. HT set, the numbers are just like the actual characters, right? HT set codes tree path. If we are not an integer, right? If we are list p tree, then what we are doing is we're just recursing to both sides, right? We're just calling p huff populate symbol codes, and then path can be, you know, if path is an integer, right? So if path, then we want to compute how will we do this? It's usually like, what is the order that we go for this, right? It should be the first bits, the least significant bit is the higher in the tree. Least significant bit is higher in the tree. So as we go further in the tree, we want to append bits, right? So we want to shift path left by 1 and logior this with 0. The logior here does not matter, but yes, you understand. Otherwise, if path is nil, then this is just 0. And then we want this to be on cadder tree. On the other branch, it's cadadder tree, and this is 1. Right? And otherwise, it's a malformed Huffman tree. Okay, good. Okay, what if I call something like this? Well, that gives us something. It gives us something for sure. Let's use their example from Wikipedia, I think. What's the text they use? This is an example of we need longer text to make it be interesting. This is an example of a Huffman tree. Can we look at this? P huff generates. Okay, we got a tree. We got also. Does this tree look reasonable? We have 36, 8, 4, 24, 2, 12, right? These are the numbers. We have numbers like this: 36, 28, 4, 12. Is there a 5 in here somewhere too? Yeah, there is. We got all the freaking numbers that we thought there were. Yeah, we're cooking tonight. Yes, indeed, Wind Up Boy. We're going Huffman a little bit. We're kind of I want to know more about this because I know little. What's this hash map look like? What's this mapping look like here? What is A? What is space? Space is 32, right? What is 32 is mapped to 7. What is 7? Can we see this? What is 7? 7 is 111. That looks like the right number to me. That looks like the right freaking number to me, friends. Can we check our numbers? What about A? What is the letter A? A is 97. I guess I can just look these guys up, right? I can just say symbols do not represent characters. Well, this is for deflates, right? We're just writing Huffman in general, right? Of course, there are more things in deflates, right? There's like more guys. Yeah, we can man ASCII. I just want to look. I can just do that in Emacs though. I can just look them up. I can say p huff symbol codes. I can set f test codes to this, and then I can just say ht get test codes A, for example. This is not right. This is not we have fucked it all up, right? Some of them are right, but A is not right. It's giving us 1. It should be 2, right? It should be 2. Why is A wrong? Huffing symbol code sounds like an illegal thing, but like, what about, like, for example, if we look at P looks like a promising guy. Dump the table with their character values. Yeah, so we're computing different. I think our lengths are right, but we're computing. Oh, of course we are, because the choice of branch is arbitrary, right? As we saw in the canonical thing, the only thing that actually matters is the lengths, right? The lengths are the thing that's optimal. Like what the exact values are can differ, right? The thing that matters is the length, right? Can we like, and I think the lengths here do line up. The problem is also these numbers that we're storing do not properly represent, like, right? We can't just store 0, right? That's not a like, or like we can't just put 0 in the table, the symbol codes table, right? That's not a useful thing to do, right? Because how do you disambiguate 0 0 versus 0 0 0 then, right? This is just not a useful thing. Can we put our guys, can we convert our guys to canonical, right? Because I think that's what we're actually going to want to do. Like like how do we do this? How do we do this? Can we go to canonical Huffman code here? The canonical guy, we know they are sequential, right? We're putting them in sequential some kind of sequential order. Can we get away with doing this? Like, of course, the thing you're supposed to do here is put these guys in order. Oh no, maybe you can. No, you can't. You can't. I'm lying. If you make a tree, it automatically keeps you from having. Yeah, sure. We already made the tree, right? The tree. This is just the table, right? The tree, like the tree, is right. Okay. What is the? So. Okay, I'm gonna go get water because I'm realizing I'm not drinking water and we should do this. You should get up and stretch too if you've been sitting. We'll come back and we will figure out what the deal is with these canonical encodings, canonical Huffman codes soon. I will click the button for now. I'll be back soon, maybe 30 or 40 seconds even. Let's click. Okay, see you soon, computer. That's the wrong button. This is the right button. Hello, we're back. Hi. Back again with one of the most high-flying action Huffman coding-based streams on Twitch TV. Hello. The most exciting Huffman coding-based episode ever. Hello, Poof. Welcome. True. Thank you. Okay. Let's figure this thing out, right? The canonical version of Guy. We can, of course... I guess all we really need is... Good luck, I'm out. Okay, bye for now, CRM148. Thank you. Thank you. Take care, please. What do they say? Adieu? Adieu? Please take care. We only need to know the length and the position. Right? We need to know, like, okay, how long is the code for a given thing, right? And how like what index is it in that length, right? This is all we really need. And like, can we look at the canonical guys that they're doing here? Can we see, do they give a little example of this? Yeah, here they go, right? This is the nature of the beast. This guy is the nature this is the nature of the fellow. It's kind of like I think probably it's not always going to be like this, right? This is sort of an example that I think is sort of difficult to generalize from, because there's only one value of length 1 and 2, right? So this means that, like, right, like we're just like, I don't think it works well. If there was not just one value, I think there can only, of course there can only ever be one value of length 1, right? Because you can't otherwise you'd cover all possible prefixes, right? And in general, the number of values, maybe it always does work. Does it always, in canonical form, does it always work out that, like, the first value of a given length is like 1110, like n, like where if the length is n, is it always n minus 1 ones and then a 0? Is that actually true? It can't be true, right? Because you run out of, like, this is obviously untrue. There's only 2 possible values you can represent like this. So I think the intention is that Hello, Paxonian. Welcome in too. Hi. Can we? I guess we can see. I'm trying to see if we can get away with doing this without, like, I mean, obviously the naive way to do this is just to collect all the things of a given length and then sort them. Well, we can just do that. That's fine. So what that means for us is, oh, why did we explode? Why did I kill chat? Why did I do everything wrong? Why did I? Well, anyway, a brief moment of skill issue. Let's fill them all with lengths instead. Let's traverse the tree and fill with lengths. And then from there we can, if we like, right, like if the smallest yeah, I think we'll just do the sorting and then just assign them, rather than trying to do some nonsense. Let's call this symbol lengths. Symbol lengths. What tree? We have a tree. The Huffman tree itself. Like, we're computing this. Let's map over the tree, and instead of storing the exact path, let's just store the length, and that makes things a lot easier because path below length, I don't know, something like this. We have a tree, but is it optimal? I mean, we're doing that. We're following the algorithm that they say. I don't know. Also, we're like, yeah. I don't know. I think it's probably good. Okay, we can populate symbol lengths like this. And then in order to actually find the symbol codes, we're going to want to... I was gone, sorry, no worries. I figured you were just kind of shooting the shit. Don't we need path? We're gonna get path separately, right? Because we don't need path. We only need the length, because then we can, once we have the length for every symbol, we can group these, right? We can sort them. And then from there, we can populate another table that actually contains... And that table will be a little more workable to working with integers, because we know that the way that's set up, I think... well, maybe not. We'll see. Yeah, I think we'll be okay. Well, let's see. I think the prefix property guarantees that we don't have weird cases that we can only disambiguate by the number of zeros, right? Did we start with frequency sorted list? Oh, we did that. We're already like computing the thing, right? Like we are like already like we can take a string and we can get both the Huffman tree and like we could walk the tree and get, right? We're trying to go into canonical form now. Process the data in actual stream. No, we are working with, this works with strings only. But I don't think it matters, right? Because the Huffman thing, like, it doesn't like we can eventually, we're not even working with decode. Thank you. A tree node isn't both a leaf and a fork. Well, I mean, that's true here too, right? This is our tree, right? The tree, thank you, Topocado. The tree, the nodes in this tree, right? It's kind of hard to read like this, right? But this tree is composed of, there are combining nodes, which are a 3-element list, where the first element is the weight of the node, and the subsequent elements are the 2 children. And there are leaf nodes, which are simply integers that are like the character. So this 101 is a leaf node. This 97 is a leaf node. This 8, 101, 97 is a combining node, right? And this tree here is material. It's the same as this tree, right? We are representing this tree. It's just, right, like we have this. I'm sorry if I wasn't more clear about this, but we have done the tree part. With nodes and edge lists any day. Yeah, this is probably the better thing to do in general. I don't know. I'm also kind of an adjacency list fan a little bit sometimes but this will do here for our purposes. So we want the canonical symbol codes now. And this is just a matter of counting up, right? Like if we know all of the symbols and we know all of the symbol lengths, we just can sort on this, right? We can just sort on this thing, and then can we like sort on a list of pairs easily? Like if I say sorts I don't know, this won't work. Like a breadth first sorting, you can bin them to length in one operation. But if you have a most significant bit operator, you can bin them to length. You can bin them to length in one operation. Don't know this language. The final encoded version that shows why it's compact. I don't know. I think we're all getting mutually lost in the sauce. Let's just see. Oh, you mean on the canonical form thing? If you can, I mean, the reason for the canonical form thing is that you don't need to store the code book, right? The advantage here, you don't. Thank you for Morse. Thank you. Hello, Droolbite. Welcome in. I joined school for IT. Well, this is good. I hope you have a good time. And if you have any, yeah, I hope you have a good one. And if you have questions or anything, I'm sure we can probably take a stab at them at any point. Welcome in. And Cosgrim, welcome in too. Okay, we got to clear up here. The advantage of the canonical form is you don't need to store these numbers, right? Of course, these are the same length as the original, but you don't need to actually store the numbers. You only need to store the lengths for each thing, which is more compact, right? I am pretty sure, right? Here they talk about encoding it here, right? And we're also storing the symbols in order, so you don't actually have to store the symbols either. You just need to store the number of bits, I think. Here they're storing the code, but I don't think you need to store the code. Yeah, they go further. You only need to store the number of bits, right? So literally all you do is you just take the whole alphabet, right? And you store the number of, yeah, you need to know how many symbols there are, right? But let's say your symbols are all bytes, right? You can store this with just like a list of like how do you say 255 numbers, right? And the numbers themselves can be quite small because they can be at most 8, I think. No, they can be longer than 8, but like I think they're still at most 8. Yeah. So like you can really squeeze this down really tiny, right? You don't actually have to store the symbols themselves. Yeah, if we need to compress that, what if we? I mean, this is what they do in deflate a squared. I think this is probably what you're joking about. They run length encode that list too. Just symbols but sorted by bit length. Yeah, you have to save the bit lengths, right? That's like the core, the essence of the information that is relevant to reconstruct the thing. How is quantum computing? I would not worry about quantum computing at all because it's probably not even real. This is probably a thing that is made up. I don't know where to begin. I'm a humanities student with a bachelor's degree in fine arts and am mostly in awe. Yeah. Well, computers can also do things more than one at a time. They can do multiple things at the same time, but fundamentally they are machines that are they are a machine that looks at a number and decides what to do based on what the number is. Yeah, they put multiple computers in the same computer sometimes. And also, like, one of the fun things about computers is you can make them talk to each other, and this opens up a whole world of new stuff. Like, this is what when people, if you talk about threads, right? People talk about this all the time. This is what a thread is, right? Running multiple at the same time. You can talk directly to the computer. Sometimes you can. Okay. Hello, Medusa T. Dustin. Also, welcome in. This is good. I really like this little stir the pots. This is good. This is good. I did a study on this. Qubits could. Yeah. I mean, I think the quantum computing thing is. This is. If I break anything, just put it on my bill. Yeah. You can barely break anything. Also, you can mess around as much as you want, and you probably won't break anything. There is fun math behind the quantum computing stuff. I know some people who have been involved in this. I do not. How do you say? I am not very hopeful about this being like a thing that you can build a machine that does it. Right, I don't know. I think the quantum stuff is such like a crazy, like, there's so much like crankery that happens in this area that I have I have very little confidence.
Unfortunately, we don't have your name recorded. This is the hint for Colonq to record your name. We're supposed to record
multiple versions.
Your name
this is like
now,
rocket sizing where there's minimum and sub minimum.
We're gonna do that.
Yes.
Your name's gonna
Thank you for the resub,
Thank
Medusa.
you for the sub also, by the way.
Thank you. Quantum is so cool. Yeah. I don't know about this stuff. Continue making gizmos. It's going to be fire. Kind of huge. A little bit huge. This needs to be me soon. Thank you. Thank you for whatever this is. Thank you. Beeps and dots, pondering my orb. Yeah, we've achieved the first ever Twitch stream where I have to be worried if people are saying slurs in Morse code. This is the first ever Twitch Morse code moderation scenario that we've ever created in the world, I think. Yes. No, I have to go major Gizmo style soon in terms of I have an idea for a thing for the anniversary, and I've been kind of tinkering with this, but I don't know if we're gonna see if we get there. Just meows. Okay, this is good. If it's meows and purrs and things, this is what I assumed, of course. If I were to assume anything, it would be like, oh, they're posting meows and purrs and stuff like this. Okay. There's multiple canonical guys. Let's just do the one they say that they're doing. And then see where we go from there. Can we do this? Can we say P like, I don't know. P huff canonical symbol codes? Can we get the canonical symbol codes, which will also be... We should probably also put the symbol lengths on here. Good night, Niche Penguin. Thank you. All my cat's meows are cursing and slurs. You have a fluid ME terminal in Greg. What did I want to do with it? I see. I'm sorry. The okay, can we say huff? Can we say symbol lengths like in the good old times in 1890s? Yeah. We're kind of they're calling us 90s kids around here. They're saying we were born in the wrong generation. Okay, symbol lengths. You are nil. I don't know, something like this. You're nil too. You're all nil, by the way. Okay. Is this canonical symbol codes? We compute this off of symbol lengths. I think that's all we gotta do. That's all we gotta do. We need canonical symbol codes though. P huff canonical symbol codes. And this takes the lengths. Compute canonical Huffman symbol codes from lengths. You had a good idea? Codes are just strings. They are just strings, I guess. But they're strings that are maybe not byte aligned. The characters 1 and 0. We can certainly do this, but I think actually we get away with just using integers. It'll be okay. It'll be okay, I think. If we save them alongside the length, we're good, right? And in fact, in general, we won't actually have to use the, like, we can just reconstruct these and use the, we'll be good. We'll be totally fine. Okay. How do we construct these guys? Well, we need to compute a list based on, we need to partition, so we have symbols, right? Sims is HT keys lengths. Binary input from L colon Q. The sound of Pokemon scary screaming, 6 chords, then 8 repeating, and it should be in C minor. Pokemon cry sound. It's fine. It's fine. This is good. Unless it's not. No, it's good. We have a bunch of symbols. This is the what was I on? I think it's fine. I think it's gonna be okay as well, Medusa T. Dustin, personally. What we are doing right now. Yeah, I guess it is what we're doing. Yeah, sure. Yes, you're totally right. Yeah, sorry. I'm being a goober, right? This is like reconstructing them from the lengths is exactly what we are doing. So I'm just thinking about it sideways. Let's how do we want to put these guys in some kind of order, right? We would like to, do we have a good way to partition? Can we partition men partitioning stream? Is there like a partition? There is. Partition by is not what we want, I think. We want group by. Is there group by? Group by, I'm thinking, is the character we're looking for. Separate into an A list whose keys are FN applied to the elements of list. Keys are compared by equal. That seems like exactly what we want. What language is this? This is Emacs Lisp. Is there in fact group by? Oh, there is. We're so back. Okay. This is just now ht gets lengths it over sims. Okay. Let's call this length let's call this groups. I don't know. Let's just return grouped for now. I never learned Lisp stuff. You should try this at some point. It's kind of fun. Can we say symbol lengths? Evil deeds have been performed. Is this just Huffman generate is being evil to us? It is being an evildoer. He is being an evildoer. In what way? We're adding this. Populate symbol lengths is, oh, of course, we're passing this nil. We should be passing this 0. Did you say ht get? Okay, there's test lengths. We have various lengths here. Good. The shortest guys are 3, the longest guys are 5. That is aligned with our Wikipedia knowledge. Our knowledge of Wikipedia. Pokemon birth, life, and then death. Oh, I see. This started to play and it coincided exactly with the mental clarity. But I think we can replay it. If I go back to bells, it should be in the bells cache. It should be in the bells cache still. Those bells cost 4. What did they call it? Life cycle of a Pokemon, but it put the fucking funny character. I don't know if the Unicode support is gonna. How can I get this on Wikipedia? I need to get the character. I need to obtain the character. So I could say I think we write them like this: friends, life cycle of a this. Maybe. Well, I don't know. We'll see. It's probably in the database somewhere. We could get it. Okay. Okay. What are we doing here? What's going on with this? Man, box. They turned him into a square. He is rectangular. What is the? We have the lengths. We can take the lengths and we can say p huff. What are we canonical symbol codes from tests lengths? Okay, well we can. I won't do that again. You're welcome to do this. You can do whatever you wish. Well, we have 3, 32, 97, 101. This is grouping like we anticipate. So what else? What do we want to do within each of these guys? We want to sort them. We want to be doing sorting within each, but I think actually we can just, we're going to build it. This is going to be very mutable. So I think we can handle like this, right? Let's say ret is ht creates. And then let's loop over this. So for each thing in grouped, we have a group. Right? This is our thing, right? Is there lambda that does pattern matching? It does. It does pattern match. This is good. This is a little bit good. Can we say we know their flavor? We know their flavor. We can say it's len and it's x's. I don't know, something like this. And we can say stuff like this. Then we want to iterate over all of these, right? We want to iterate over every one of these fellows. We also have a thing called cur, which starts at 0, right? So let's iterate over each of these fellows also. And every time we finish one of these fellows... How do we start, also? Can we look at the canonical Huffman code again? The first symbol that is okay, the first symbol gets all zeros. And then every subsequent symbol gets the next number in sequence. But you have to increment first, right? So we're going to have to be very careful about like performing the correct modulus. Right? This is the thing, right? Because I assume we're gonna have to like, is this a wrapping increment? Or does it not matter? Maybe it doesn't matter. Let's not worry about it at first, and then we'll see if we get the right results, and then we will worry about it if it matters. I think that's fair. At the end, so this is just saying, for all of these guys, we're just gonna say, well, each in sorts, catch you later, Lonk. Thanks. Catch you later, Jewelbite. Thank you for coming around. It's good luck with your thing. If you have any questions about this, you can ask here. Or we can. This is where we go. This is where we go. Yeah. Okay. We'll do this. And then we can say things like, I don't know, just ht set ret it plus it cur, I guess is the thing to do. And then cl incf cur, something like this. Hello Yusuge777. This is Emacs Lisp. It's a Lisp kind of guy. Can we say setf cur to ash cur 1? I think that's mostly what we're trying to do here. We don't actually need the length, right? We just use that for the... Okay. Can we canonicalize Huffman? Well, no. We need to return ret. Of course. Of course, we need to return ret. Okay, what's this looking like for us now? Well, it's gonna be hard to read this example, I think. Can we see what it's all about? Can we see what's going on with this? I mean, this combined with the lengths is enough to allow us to encode things, I think. But can we try, like, what's their... Their example here is they're saying A equals 1, 1, B equals 0, C equals 101, D equals... Right? Can we produce this? Right? If I say ht a list, right? From, I don't know, here's a list. A is I have to go since it's getting late. See you around. See you later, yesterday. Good luck. Good luck. A is 2. B is 1. C is 3. D is 3. What do you say about this? You're telling us that A is 0, which is not correct. You're telling us that B is 1, 0, which is also not correct. You're telling us that C is 6, which is also not correct. And you're telling us that D is 7, which is also not correct. No, maybe it is correct, actually. Oh, it is correct. No, the B is wrong, right? The A-B thing is wrong. Like, why the fuck is A 0 when B is... That doesn't make any freaking sense. Well, we'll see. Oh, you know what's happening? We're not sorting by the lengths. We're grouping by, but we're not sorting. We're only doing the sort once. This needs to be... You need to be sorts on less than car Yeah, this is you. Copy my symbol and make that hair with your video. What are they doing on my head? Are they playing Fallout? They're playing Fallout. No, this is a little more animated, maybe. I don't know. I was trying to mess with Fallout 1 recently too. This seems like a kind of appealing game. Okay, now it's B. It's dumb. Oh, it's dumb moths. I see. I see now. The this is good. This is good. What is moths doing today? What is the dumb moths gaming du jour? Okay, are these numbers more sensible? I think our wraparound situation is not quite where we want it to be. After incrementing append zeros. Yeah. Playing DS bad game? Okay, this is good. This is extremely classic stuff. Can we say bin 6, bin 7? Are these actually right? Is this actually correct? Yeah, it is. Do we have like a... We need like a better example, because I'm still convinced that this example is like kind of degenerate in certain ways, and that it doesn't fully demonstrate what we're trying to do. Crafts inequality. I see. The Kraft Macmillan inequality. I see. A necessary and sufficient condition for the existence of a prefix code from a given set of code word lengths. So this is exactly what we're trying to do here. What is old Kraft telling us about this? How high can it go? Very high. You can elevate this substantially. Oh, is this soy milk now? I see. Oh, this is good too. It's nice how many people are interested in this guy. On this machine it's gone higher, because I think this guy has on the old machine it was 800 or so, I think, because it only had 4 cores plus like whatever the threading. This guy is stronger, I believe. No, he's still 8. We've definitely seen him above 1,000 on this machine though. Yeah, they're saying I have 16 hearts. Isn't that like a book or something? Is that a thing? 3 Hearts and 3 Lions. 3 Hearts and 3 Lions by Paul Anderson. This is a thing, right? This is a book. This is a book from the 50s. Yeah, I like these lions a lot. These kind of rock, actually. Look at this is good as hell. There was a guy who had shapes inside of him instead of hearts, and lungs and things like this. But this is sort of good. Okay, I'm still convinced we're doing something. Is it possible for this to produce a bad outcome? I guess we can just see. Let's just try it with another thing. Let's just try it on test lengths instead and see if it produces... Like, if there's any duplicates, we know it's wrong, or if there's any things that share the same prefix, we know it's wrong. But this seems like kind of fine. Count how many symbols exist for each bit length, and they can figure out the starting code for each symbol by looping over the lengths. And they finally go through the symbols in order and assign each symbol the next code for that length. That's what we're doing now, I think. Like, we've done this now. I think these are right. Often, fellow, you can import and compare outputs. I don't know if there is. But I think we're good. Can we, like, encode things? Let's write a guy who actually, like, does the compression. That's maybe the useful thing to do. Can we, like... So we can generate this generates a table for some given text, right? And then we'll want a guy who, given a table, and some string, and a string produces a... Like, the compressed version of the string. They sort 0 times. Oh, I see. They have a per length table. Sure, we don't care about this. Of course, this is a faster way to do it, right? But like, I don't want to. We could certainly keep track of the per length thing. Well, I guess Oh, this does imply that that the starting value for each length is known, though. That is interesting. Which I guess makes sense, right? It's always going to be 1, 1, 1, 1, right? Because, is it? Is it though? It seems like you have beaten the goal of today. Well, we've not finished the goal of today, but we have at least done the Huffman thing. I think. Let's. But I'm still a little bit confused about some of the properties of the canonical thing. Can we try some stuff then? Sorting values break me. Without what is this? What is this? Without I don't know. Is Jonathan Graph involved? You have a tree that has leaves that don't end in 0, right? But are those better or worse? I don't know. Well, let's see. Can we just write some guys who compress? Really, the thing I want to do is I want to implement. I want to like compare this against something real. This is a good impulse, I think. Can we call this compress? Compress takes H, and it takes a string. Compress the string S using Huffman tree H. Okay. So what's the deal with the compression? We kind of want a writable bit stream. Right, this is what we actually want. We want like we don't want. Oh man, everyone's live today. We have the slab, we have side there, right? This is kind of huge. This is sort of huge. We have this bit stream abstraction here for only reading, right? It would be kind of good to have it for writing too. Thinking about it. Maybe we change his name to Bit Reader or something like this. I don't know. That's kind of fine, right? Bit Reader or bit stream Bit Reader. I'll stump you with a new friend. Maybe so. Maybe so. Let's have a bit writer as well. What does a bit writer entail? Well, I think it's the same thing, kind of. We could just build up a guy. We could do this with cons probably pretty easily. I was away for a long time. Why is the Clippy in the corner? Oh, he's been hanging out. I'm glad you're still here. It's glad to see you again, Paxonian. I definitely like remember you. It's always good to see a familiar face. Clippy is here because we have resurrected him from the dead. We have performed a necromantic ritual. This is mainly it. But we could just cons new bytes in the front and keep track of the bit index of a thing. It's kind of gross, maybe. This PDF has a lot more pictures than the wiki. Can we see what Stanford CS 106B is talking about here? I see. Do they tell us about it? Do they have some funny stuff? Familiar ASCII faces? Yeah. Very cool. Can we yeah, they have various tree pick. We'll keep this open in case we need it. Do they talk about the canonical guy here? Do they talk about this? They have the trees but leave codebook as an exercise to the reader, I think. I see. Well, they talk about it. This is good though either way. We'll consult this potentially. Let's write bit writer too. I kind of like having bit writer around. What's the deal with bit writer? What's his deal? Can we are vectors strictly pick fixed size and I think they are, right? Like I don't think I can append to a vector. Probably not, right? It'd be nice to be able to reuse the same kind of representation. Maybe you can. Can we see what the deal is with vectors? You look at the vector group. Yeah, I don't know if there is a good way you can do this. I guess maybe it's called array. Yeah, I think probably not. Well, let's just build a cons list. It's your favorite type. It is. It's right here. We can prepend at least. We love prepending. And BIDX can just be. We can start off having U be 0. It won't be, again, this is not going to be slow because we're only working on the front of the list, right? We're only working on, like, the con cells are only miserable when you have to work on both sides of them. This will be okay. Like, again, this will not be, like, the garbage collector thing came up in the Fourier thing because we were making millions and millions of these, right? I know you're being sarcastic. I'm literally interpreting your sarcasm in order to, you know. Okay, we have a bit writer. What's the deal with a bit writer? What are the operations we would like to perform? Well, the basic operation is push bit. Right? We love pushing a bit. Right? This is the thing. Push bit B to BS. What does pushing a bit entail? What does it mean to push a bit? What does it mean to push a bit to him? We got to be careful now because we don't want any extraneous bytes sitting around here, right? We got to be careful about this. I think in this world we go for a let's think about it like this. We check at the start when P bitwriter BIDX B's is a linked array lists. We like array lists too occasionally, but in this world we love the singly linked list. This is one of our favorite characters of all time. If this is greater than or equal to 8, then we're gonna set it to 0. Bitwriter BIDX is 0. We're going to set it to 0, but only after that we're also going to put a new man on. We're going to put a new man onto him. We're going to say not this. We're going to say setfp bitwriter bytes B's cons 0 p bitwriter bytes. In fact, actually this can be the whole shebang, right? If this is the case, we're gonna do this. Actually, let's just do this in a con because I hate if. If is upsetting to me. We'll do it like this way. If it's greater than or equal to this, we're just gonna put B in a new guy, right? And set BIDX equal to 0. Go to the triply linked list. What is this even? There's probably some kind of funny, like there are, like you can do like a linked mesh kind of thing, right? Like multi-dimensional linked lists where you can go and and in fact, this is actually like something that is not too evil, right? There are certainly situations where this is a sort of reasonable structure to have sometimes, mostly as like a domain modeling thing though, right? I don't know, like you can imagine, I mean, there are almost always better ways to represent it, but I can imagine, I don't know. You like traversing a thing where you have links going in different directions and you can walk over it is kind of a thing you do sometimes when you're scraping web pages a little bit, right? Like you can imagine, I don't know. This makes me feel, it makes me think of like Zork maps or something, right? Like our maps in like MUDs. You have a variable number of links in different directions. Can we do this and you don't have like a global view of what they all are to make it easier. You have to just kind of live off the land. Here we can just say setf let's just say this. Old is car bytes. Old is car bytes. In fact, I think we also want to initialize BIDX to 8 then.
this should be initialized to 8, right? Because then on the first push, we'll reset him back to 0, but we will add... This needs to be set to 1, actually. Yes. Because we're adding a bit immediately. Addicted to writing cons. We love writing it. It's one of the greatest things that there is. Get this out of here. Get the old value, and just say, well, what do we want to say? If we're pushing a bit, right, we're going from least significant to most significant, right? We're going from least significant to most significant. Like when we push a new bit, we are pushing a bit that is of greater significance, right? So what we need to do is we need to say setf car this to BX should go the other way. Now I think this will be the appropriate way. To ASH B P bitwriter BIDX BS. And we also need to increment this by 1. CL incf P bitwriter BIDX BS. Kind of gross, but we're okay. You need to be here. Oh, you need to be ORed with this, of course, right? You need to be logior. BS a register? No, BS is just a bit this bit writer thing. Hello, Talon 1024. Yeah. Okay. I think we're good. Maybe you need to just be B. Okay, we can push bits. What does this look like? If I say bitwriter here, if I make a new bitwriter, if I say setf test bs p bitwriter new, and I start saying stuff about it. If I start saying p bitwriter push bit 1 to test bs, right? It's 1. If I push another 1, it's 2. It's returning the return value. We should just make this always return BS. Actually, that's going to be the most ergonomic thing. It's 7. It's 15. Right. We're pushing. Wow, we've pushed 8. We've pushed 8 bits. If we push another 1, wow, it's 0. Now if we push this, it's 2. In reality, we want to push multiple bits. Yes, of course. Of course, we can just push multiple bits at this. We can push multiple bits at the same time, or just like do them one by one. This is going to be sort of unpleasantly slow, I think. We can probably get away with doing a better thing. I don't know. We'll see. We can think about it a little bit. I think doing them one by one is kind of fundamentally what is the thing to do, probably. There's ways you can get away with it. Have a cons for every. It's not a cons for every bit. It's a cons for every byte. It's a cons for every byte. We're fine. Of course, at the end also, when we need a way to actually retrieve these bytes. Let's call this bytes internal. Every time we say bytes, let's say bytes internal instead here. And the reason is I want the bytes accessor to be just like get the return the actual bytes in the proper order. Hello MXLX, welcome in. P bitwriter bytes. I want this to match the reader, right? Return the contents of BS. I don't know. And this is just reverse P bitwriter bytes internal BS. Right? So these are backwards inside because we're pushing on the front. So now we can say things like P bitwriter bytes on this, and we can get, wow, it's what it is. Wow. We're pushing bits. We're pushing freaking bits on here. Evil theme. We're going evil mode. Hello, Wertua. And wow, we pushed a 0. Remember we pushed a 0 as the first bit of this byte? Wow, we got the right thing. What about push bits then? What about pushing multiple bits? Well, it's not hard, right? It's as easy as just pushing them. We can't just provide an integer though, because remember, what if we want to push like 5 zeros, right? What are we going to give it as an integer? The number 0, right? It's not. It doesn't. We need to give it a length and also the integer, right? This is what we'll do. We'll just have it. We'll pass both things, right? And conveniently, both of those things are things we've put in our hash tables in the Huffman guy, if you recall. Bitwriter push bits takes a len. It takes an X and it takes B's. Pass it a string, yeah. Push len the least significant len bits from X to B's. This is what we shall do. This is what we shall do. We'll just grab len bits from X and push them to B's, right? Because of course, the way we do this kind of stuff, right, it'll work out, right? We can just like, if you say I give it 0 and I say I want to push 100 zeros, right? You can just do it. We're just gonna keep shifting right over and over again, right? It's fine. Okay, let's try that then. Can we say do times shifts len, and for each of these we're just going to say p bitwriter push bit, and the bit that we are going to push is going to be log and the low bit of ash x negative shift. This is the guy, and let's return BS at the end. Right? I think this is sensible. Call with one argument requires 2. We need to pass in BS. Okay. Now we have this guy. If I start saying things like bitwriter push bits, 8 bits from, I don't know, like what's a number? What's a freaking number? 200. 200 is a number. Wow. 215 is a number. Wow. What if I say 16 bits from 65535? Wow. We can do it now. We can push the bits. We can move some freaking bits around, gamers. So what's next for us then? Well, in order to do the Huffman coding, it's pretty easy now, right? We have the Huffman tree H. So all we need to actually do is we need to take each byte in S. We need to look the byte up in symbol lengths and symbol codes, right? So and that gives us a length and a number. And then we just pass that to the thing, right? It's really not so hard at all. So let's say BS is P bitwriter top 3 encodings: Gray encoding, Huffman encoding, Hamming encoding. Hello, Boothy_B. Thank you for the follow, Boothy B. They're calling them Boothy B around here. This is kind of good. Hello, welcome. The other radixes and literals, yeah, sure. But like, I'm not gonna, if I don't write them like this, like it's gonna print them. I could probably change how it prints them out, but I'm too lazy for this. Hello, Booty B. It's Boothy B. Excuse you. This is not Booty B. This is Boothy B. Welcome. I don't mean to immediately leap on you, Boothy B, and start harassing you or something. This is not my intention. Hi, hello. We are programming. Hello, Fluted too. Okay, let's do this then. We want to get the characters in this, right? So we can probably say, I don't know, seek into. We'll convert this to a list. Encode coding string. Encode coding string S UTF-8. Convert this to a list. Right? Obviously, this is mad slow, right? But it will do, right? This is just an example. Doing this on a string is just an example, right? We'll make it work. Actually, you know what? Does seek each map over? What does this map over by default? Right? Like if I say lambda x message val. Always happy to see some Emacs and Lisp in my feed. Hell yeah! Well, this is really good. Hello, welcome, and we do like this a lot. What we're doing today, if it wasn't clear, is we're playing around with eLisp. We're writing some eLisp to try and the eventual goal is maybe to read PNGs, because I've been doing a lot of stuff in eLisp. Like I've written a bunch of assemblers in eLisp recently. Like I wrote assemblers for like the Game Boy and the Game Boy Advance. We're trying to have like our own little like, I don't know. It's kind of complicated. But as part of that, I wrote a bunch of like asset processing stuff. It turns out, despite Emacs having PNG support, there's not really a good way to access that from eLisp, as far as I'm aware. Like, I don't think you can really read in a PNG and like read like the pixel data from this. On Meltpot, I'm a little too embarrassed. They're kind of, I don't want to. They're a little rough. They're only for my use. Emacs has PNG support. Yes, it does. Right. I can go to my docket, right, and I can like, this is an image. I can just embed this image, or like this symbol next to your name. This is an emoji, but like if I write like, I don't know, Joel in here, right? This is an image in Emacs. Anyway, the way I've been handling images so far is I've been calling out to an external tool called farbfeld to convert the images to like this raw representation called farbfeld, and then reading that in. And this kind of sucks, and I would rather just do it in Emacs. So we're writing like a bunch of Huffman code and stuff in Emacs with the idea of eventually doing a how do you say, like a PNG decoder. Because I think we need this, and then we need like we need to implement deflate to do PNGs. Project is great, thank you. Yeah, well, I don't know, we're having fun, we're messing around. We're gonna see, who knows how far we'll get, or if we'll finish it, but we're at least learning some things by tinkering with this. If I say hello world, this prints every character, right? Like you can go seek each over. Yeah. What if I put cowboy in here? What if we install cowboy installation mechanism? Cowboy, is this, yeah, this is evil. But like we need him to be a unibyte string. But I guess at base, is this a guy? This is an aux-v guy. What does this guy do? Can we I guess we can just say compress the sequence S, right? And not worry about this so much. Just assume it's a sequence from the start. That's not so terrible, maybe. Returning a I don't know, a list of bytes. Or a sequence of bytes, maybe, is the way we want to say this. Can we just say seek each lambda x over s? We're gonna return at the end of this. We're gonna return p bitwriter bytes from these, and for each guy in the sequence, right, we're gonna get a length, right? Which is, well, no, we don't even need to bother with this too much. Let's just say Oh, I should say also, Boothy B, if you're into the Emacs stuff, we have a Discord server it's like a one channel linked to one IRC channel. If you are a Discord hater, as many are, be included a little bit. And we do have quite a lot of lispers around. This is kind of the thing. Not to be like overly like advertising. It's kind of, but like this is a thing to be aware of. Okay, carrying on. We can just, all we want to do really is we want to say p bitwriter push bits, right, to b's. We need a length, and we need a that's good, I'll consider it. Yes, of course. Yeah, again, no, I always feel awkward like trying, you know how it is. But well, this guy does exist. He just doesn't believe in him. Why do you not? Oh, Zarlet is malformed. That's what it is. What are we doing here? We want to say HT get schemers and lispers are immune to advertising. Yes, you get it. h, well, we want to say this is p huff symbol lengths h, get x out of this. And we also want to say ht gets symbol codes hx. And both of these guys, we want to say if it's not there, error symbol in inputs did not exist in lengths table. I don't know, something like this. Something this sort of thing can be good. Hello Mod Clonq, also welcome in. She just came in here and I didn't mention this, and then she's boosting. She's boosting from the other room. She can probably hear me right now, but I think she's feeling a little unwell, so I won't bother her too much. Okay, what are we doing with this? We can do compression now, right? Can we perform compression? If I say, what's a good string? Well, I guess it's not really useful to test this stuff until we can untest it, right? Like, if I say, what's the funny example they use? Oh, it doesn't really matter. If I say setf test huff is p huff generates this is a test of Huffman encoding. Hello, computer. Okay, there it produces a table. And if I try to encode this string, can I do this? Huff. What are we calling this? Huff compress. Oh, or you need to of course have the test huff. Okay, cool. Well, it gives us some bytes. That's sort of cool. This is sort of very good. But now we need to decompress them also. This is the other way. How do we go the other way? What's the deal with this? And is it possible for us to decompress easily just looking at? Well, I guess we can go. We have code symbols. We also kind of want the other way around, right? This is, well, we want the other way around in a way that we want the tree itself. We'll have to think about how reconstructing the tree from just the lengths works, like the canonical lengths. Well, let's see. Oh yes, we have to do that anyway because our tree is now wrong, right? Our tree is not correct. How do we handle decoding these guys? I guess we can build trees like of all of the prefixes, right? Like we can do like a Hello, Kinslayer. Like, can we oi. We can probably do something good. There's probably something good we can do, I'm thinking. There might be there might be one good thing in the world for us. I think maybe it might be good if we like how do you do it? How do you do it? We might be able to Do we even want to save? I think we do want to save the tree. We definitely don't want to just like put this tree on here. We use that tree to generate the symbol lengths table. But then we want to use the symbol codes to generate a new tree is the thing. How do we get away with that? How can we get away with that? Do they talk about this on the canonical Huffman code thing? Do they talk about like They talk about reconstructing the code book. Good night, Kappa5421. Welcome. Or maybe I'm thinking about this whole thing in the wrong way. Maybe you don't have to I mean, the tree is useful, but the tree, there are other ways to represent this, right? Like, Like there's got to be a. We'll look at the main Huffman coding page again, right? Because we can like symbol codes contains all the information. It's just unwieldy to use for decompression, right? The do they talk about this? Simply a matter of translating the stream of prefix codes to individual byte values, usually by traversing the tree node by node. The Huffman tree must be somehow reconstructed. In the simplest case, you can pre-construct this. Okay. The Sure. Compress using canonical encoding. The compression model can be precisely constructed using just this. Sure. I guess we'll need a way to reconstruct a tree. So this will be the convenient way to do it. How can we reconstruct this damn tree? And what does it mean for us? Well, I think like doesn't bother reconstructing the tree exactly in deflate. Can we look at 1951 again? Do they tell us about this? They tell us about the funny tree guy. This is just a synopsis of the thing. All codes of a given bit length have lexicographically consecutive values in the same order as the symbols they represent. Shorter codes lexicographically precede longer codes. This is I think the property guaranteed by the canonical thing, maybe. But if it's not, maybe we can. They literally have the example from Wikipedia here. Maybe. I think so. This is literally that example. Okay, and they say, okay, assign numerical values using, okay, we're doing this basically. Let's see. Oh, and they independently find the value for the smallest code of each length. Cool. I see. And then do they tell us about actually reconstructing these guys? These rules are the canonical thingy? Yeah. They are the same. They're just gonna tell us about this a whole bunch. I don't think they talk about actually reconstructing the tree. Sure. I guess they're reassigning the codes at each node of the tree here. I don't know. You generally don't want to reconstruct the tree, but you need some kind of structure to like efficiently decode these guys. Like obviously I don't think a tree in general, like a binary tree represented as like with con cells is like the ideal way to do this in general. But I think there's probably a nice way to do it. What do we want this array to look like? What do we want him to look like though? Like we need a guy to know like at each bit, like it's kind of like a state machine kind of thing almost, right? Every bit tells us something. It's either we're moving for, like if you're doing the tree traversal thing, it's sort of obvious. You're either like moving towards a leaf or you're starting anew, right? You're done. You've arrived at a leaf and you can start again. What is the I'm trying to piece together like the trick. The need to read and inflate. No, we can work it out, I bet. Like what's a nice way to do this? What is a nice way to do this? I mean, we can have an array. We can have a mapping from how do you say? I mean, it's not hard at all, actually. You literally just flip. This is easier than I thought it was. You can literally just flip the code book. The way we're doing it with the hash table lookups, I think we're fine. We can just get away with just straight up flipping the code book. We don't need the tree. We do need code symbols. Where is tree? Yeah. We do, like, the prefix property already guarantees this. Can we get code symbols? No. This is just the guy flipped, right? This can just be do we have, is swap a character in this freaking language? Do we have, is this a thing that we have for free, or do we have to create this? We probably have to create this. We probably have to go flip style ourselves. Okay, we can say ht from a list map cons cutter it car it over ht to a list symbol, or let's call this, I don't know, symbol codes. Well, we have to bind it separately. Fuck. Symbol codes is this. You are symbol codes. You are symbol codes. You can be indented the appropriate amount. Then we can get the symbol, the code. Yeah. Okay. We have code symbols. We have symbol codes, right? And then it's just a matter of, because these guys, because of the prefix thing, right? We can just always just like look up like what, like we can always be like, okay, read one bit, right? Add this to like our current candidate value. Look up that candidate value in the table. If it's contained in the table, well, we know we found something, because it cannot be a prefix of anything else, right? Like if it's not right, like then we just keep going. I think we're not worried about this. Let's just write this: defun p huff decompress hs decompress the sequence of bytes s using Huffman tree h. Yeah, obviously zlib does something way smarter than this. Returning. Okay, we can just say this. This is fine. So we have p bit stream like we want bit stream from bytes, right? This is what we want more than anything here. Or bit reader. We want bit reader from bytes. From bytes, and this is just from the bytes s. Sure, you're just s. Seek into u vector. Yeah. I'm Nightmare Freddy and I'm in your bits. Yeah, true. This is like a Greg Tech kind of moment. This bit reader from bytes s. Okay, where do we go from here? Well, we want to just read a bit. We want to read one bit at a time. We have like code. We have a code. The code starts at 0. The code starts at 0. Kyoke and Kyoki's raid. Hello, evening_blue. Welcome in. You may have arrived at the wrong location. Welcome in. Hello, hypnotic_games. Welcome in. Thank you for the raid. Hello. Can we shout out hypnotic? Hello. Hip. How are you doing today? How was your stream? TK_games. There it goes. How did it go? Welcome in Hypnotic Games and Sammykins and D-Decimator. Hello. Was a good stream. It's good to hear. Hello, if you don't know me, I'm LLLL. Hello, Drip Advisor. We are doing foolish things on the computer, as Real Nice implies. We are currently writing a thing to do Huffman coding in Emacs. We are messing around with this a little bit. Hello, Inspirator AG112. Welcome to. We are decompressing now, Freefall. This is the current plan. Although we have to think where we are here. Game apparently runs with 8 gigabytes. Oh, I see. This is good. This is good. Hello, Gingivitis too. Hi. I feel more. Hello. So how are we going to do this? We have to handle the 0 case a little specially, right? I guess we don't have to. We can be 0. We can be normal about it. So what are we doing here? What we do is we read 1 bit. We read 1 bit. This is the case. Is your game Hypnotic Games? I don't recall. Do you have like a Steam link or something that you are currently pursuing? Do you have something up? I would love to look at this if you're doing this. It's a shop sim. Yes, I think I recall this. We've talked about this. Reciteer Bobble Shop Simulator. Yes, we did see this. We know this guy, I think, maybe. Can we get this? Can we get this? Is this the one? This is kind of good. This is kind of good for real. Does it go? Is this the one? That is the one. Hell yeah. Hell yeah. This is very good. Does setf returns the correct thing? So we can do evil stuff now. We can say bad things. I don't think there is a while let. Oh, there is while let. Okay, we can get away with bad stuff. Good. Is there while let? No, there's just normal while let. Okay. Can we while let b p bit reader pop bits from b's? This is what we shall do. While this is true, is that BPM reader? It is real for some definition. It does not measure the beating of my heart. I guess not my real heart though. It's sort of a false heart scenario, I would say, Drip Advisor. Can we say, what are we saying? What the hell are we saying on here, computer? We're saying something, I think. We might be saying something soon. We're saying setf. Well, what are we saying? We're saying setf code, or rather setf code to logior code b. At the end of this whole thing, we're gonna shift code left. We're gonna say setf code. How do you say ASH code 1. Right, that's for the end. In the in between, we're gonna check some stuff. We're gonna check I don't know. Let's see how we will do it. Let's see how we will do it. We'll say if let v ht get p huff code symbols h get code out of there. Get code out of there. If this is real, if this guy is a real human man, if he is real, what shall we do? What shall we do with him? If he is a real man, in the true case, the aesthetic and vibes here are great so far. I'm glad. I feel like I'm sort of deep in the weeds. I'm sorry if I didn't introduce myself here. Hello. Hi. I'm LLLL Colonq. I like to go on the computer a lot, and this is mostly what we do around here. We pretend that we go on the computer, we do things. I play pretend, I guess. This seems like a crazy way to say it, maybe, but this is increasingly what I've come to recognize I am doing. I'm like, I don't know. I go on here and I enjoy messing around. Yeah. If you like this, you can go here. This is my home. I live here. It's my main home. We have a little Discord and an IRC where we chat in between times, and I don't know. It's kind of good. But mostly we just show up here and do a little bit of talking and programming and stuff, I guess. Okay, if the code symbol exists, what are we trying to do? We need ret. Ret is nil. We can push, what we want to do in this case is we want to push v ret, and we want to say set f code to 0. Otherwise, we want to set f code to this. At the end of the day, we're going to return ret, or rather, we're going to return reverse ret. Writing advent of code problems. This is good. A question for MX Doctor. Yes. Okay, can we compress things? Well, there's huff. Can we also say, I don't know, can I say test string is this guy, just for the sake of it? Can we huff generate off of test string? Generate this, and then can I say p huff compress test string? Can we decompress this? P huff decompress h this wrong. No, it's not. It's test huff, not h. Test huff. Okay, not the right answer. It doesn't seem like the right answer to be given. Those 32s are everywhere. It's not looking good. The problem is we're not checking the lengths, and the lengths, we need to check the lengths. The lengths are essential, right? This is an essential thing to be checking on. We see it in ASCII for fun. Yes. We can see. Can I say seek into string? It's not, because we're only getting the short characters. We're getting the three length, the ones that are most common, right? Because we're not properly disambiguating the thing, right? The like here, what we really need to do is we need to track the code len as well. Good night, Caddy Shot. Code len is also 0. In this case, we will say some additional things. We will say cl incf code len. We will say setf code len 0. We will only do this if this exists, and there's another thing we're going to check now. We're going to check also that equals code len, or let's say we need to do a number of things here. We need to say len is another ht get, because again we have to do this because it could be nil, right? You have to do this kind of thing. Code symbol, well, we have to go the other way around, right? Well, I guess it's fine, right? We can go like this, right? We can say things like this, where we say this V is the symbol. Hello Puke7, welcome in also. Hello. Hi, hello. Can we shout out Puke7? Puke7 is extremely cool and is involved in all sorts of cool things. Puke7 has developed some cool NES homebrew at some point. This is cool. I think I've told this story and been embarrassed by it before. You should definitely follow Puke7 though. This is really cool stuff. That is, we like this kind of thing. At MagFest 2 years ago, I very awkwardly approached the Puke7 booth and purchased Puke7 video game thing, and then I think very awkwardly gave them my card and fled. This is, I don't know. Hello. I apologize for being extremely awkward in person 2 years ago. It's good to see you. I hope you had a good stream. Hello, Vongo272 also. Hello. If you don't know me, I'm LLLL. I pretend to be letters or something like this. We go letters. I've heard this story vicariously. There's various things you can do with the letters. This is a concept you can have. You can do stuff like this. I don't know. There's things. We're currently learning about Huffman coding. We were implementing a little thing to do Huffman coding, compression and decompression in Emacs Lisp. With the goal of eventually maybe doing this, we're gonna maybe write a PNG decoder. That's the idea here. But we're just kind of tooling around a little bit. Hello, holla holla, we dem boys. Welcome in too. Does card have this? No, the card is a little bit freakish. I don't know. Anyway, it's please check out Puke 7. It's very cool stuff. How long have you been seriously coding? For a long time. Hello Mog too. Hi everybody. Sorry, I'm all over the place. And if you like this stuff, here's the link that I'd post. Okay, I'm gonna stop worrying about it. Let's please put the pieces together. We want to make sure that the length is equal to code len, right? Yeah, that's what we're trying to do. If we do this now, okay, now we get the empty string, which is also not gonna be ideal for us, I'm thinking. Actually, it should be equal to code len plus 1. I think the way that we're doing this. No. Also bad. Put a classifier to pick the letters of the consort. Yeah, we would like to do this. Right now we have like the text thing. Like we change the actual text that's backing it pretty often. I do want to do like better like edge like stuff maybe. Right, like border detection. I'll hang out after if you're still going, of course. Please enjoy your food. Thank you again. I started when I was young, but was super inconsistent and mostly tinkered around without really taking an effort to improve for improvement's sake, which is also what I've done with music and guitar. I enjoy a lot both though. That's what really matters, I guess. I have a crazy amount of it done in Python. There was a really good Orange post about this the other day. That had some cool stuff in this. If you're interested in this, yeah, ASCII characters are not pixels. A deep dive into ASCII rendering. This is quite good. They're doing that kind of stuff here, which produces like a nice, very good shading, right? Doing like subpixel stuff on the actual characters. I'm not doing any of this because again, that's what allows me to have these kind of funny effects. Anyway, I'll link this if people want to do this. If people are interested in this at all. It's not mine, but how do we do this? Twitch say. Whenever we do Twitch say, I think it's this feels like pig Latin, right? It's like ixnay on the whatever. The ixnaos. The ixnay sowe, I guess, or something. There's like a rule for vowels. I don't know this stuff. Why are we so fucked up and evil here? What has gotten us so bad? Why are we so... What is the origin of our horrendous... Like... We also save it uncompressed. Yeah, we could do this for... That's basically what we're doing right now, 100x Programmer, right? Right now what we're doing is we're using like a pre-processing thing to convert the PNGs to like a raw format. And then we're just reading those in Emacs. But I'm kind of interested. I just don't know much about this, so we're trying to explore it. Welcome in 100x Programmer. And Takeda too. Hello Takeda. So why are we like this? Can we print the values? Maybe. Message code is this. Maybe do this a little bit. Oh, the codes are not good. The codes are getting a little too big in there, it seems. Are we in fact putting every bit on them? Yes, we are. Ooh. That's not what we want at all. Well then. Why is that what's going on? Oh, it's clearly we're never finding a matching code, right? So we're just running out of stuff. Shouldn't we find a match pretty quick at the start? Huffman anti-compression, yes. We probably should find one pretty fast, you would think. What's the... Like, if we compress, what's the first value? It's 15. We get, like, we read 15 pretty quick here. This is one of the coolest ones I've seen. I'm glad you think so. Hello, Inspirator AG112. I appreciate. Thank you. It's kind of you to say. I thought it was a pretty cool idea when we thought of it. I haven't really. I think we sort of built it out in a strange direction. I have ideas for how we could do, but I don't know. It's kind of good. What is this going to give us? If we get 15. 15's not giving us the right answer. And 15, the code len should be 0, 1, 2, 3, and we have +1. It should be 4, right? What is the value here? Like if I say ht get p huff code symbols, p huff code symbols test huff 15, 15 rather, it's nil. Of course, this is the first whole byte, right? That's wrong, right? What are the code symbols? This is obviously wrong. Like the byte boundaries are arbitrary, right? We're looking for bit boundaries. What are the code symbols that are relevant here? What's the 7 is relevant. 7 should be giving us 109. Can we print this stuff? Maybe we should just print all these values, and if I just put, let me just put oh, we're reading code instead of V. Obviously, that's what we're doing. Can we do this? Okay, well that's not right still. That continues to be not correct. It's the same, it's the right length now. But it is not the right it's not the right things. But it does appear to be a like the symbols. It is like the right thing. It's the right stuff, right? It's like this is the same alphabet. How are we ending up like this? What has happened to us? Quake defrag is so cool. The Subway Surfers for older millennials. I really gotta play Quake probably at some point. I feel like one of these, I gotta have my get good at shooters arc, or at least become competent, become tolerably able. Because I feel like it sort of, it diminishes my gaming, and I don't game, but it diminishes my hypothetical gaming credibility if I were to do this. Like, yeah, it's like this. So why are we getting just the wrong values? What's the deal with that? Are we putting the wrong values in here? I mean, no, 0 is 32. Why does it end up like this? It's not even, like, the spaces are not even in the right, like, we're getting totally fucked up doing this. So it's very fucked up and evil. Like, what? Something very strange has occurred. Are we... Yeah, but I don't need to be that good at the game. I don't need to be enhanced in any kind of way. I just mostly want to... I don't know. This is where we are just flipping the guy. That seems fine, right? Like, what if we look at the symbol codes? Like, it should be the same. Symbol... Oh, give us not. Don't look it up. Get the thing. Get the thing itself. Yeah. 0 is 32. 97 is 2. You're right. These are the right things. Are we just fucking up the compression somehow? Is that what's going on here? Like, I don't think so. Like, all we do when we compress is we just read a byte and we push a number of bits equal to, right? Like, it's not that we're pushing bits back. If we were pushing like bits backwards and stuff, we would have, like, it would not even be the same alphabet, right? It'd be totally fucked up. We'd be reading, maybe not actually. Actually, it could be that we're pushing the bits are backwards. How could we observe that? How could we possibly observe that? Ugh. This stuff is a little bit complicated, isn't it, computer? There's a lot of moving parts here. Probably what Nyston said. What did Nyston say here? zlib uses multiple levels of table. Yeah, there is a simplified C example provided by the zlib people called Puff, which is sort of the inspiration for doing this at all, that this is kind of accessible. We haven't even looked at this yet, though, because we're not really doing deflate. We're doing the pre-deflate step. Do we have where have we mucked it up here? Claude, no, I will not touch the robot. This is my oath, I'm afraid. The oath is my I do not I'm a non-robotic. Where is I suppose What is the fuck? I'm so confused by this. It's so confusing. What have we done here? Perhaps we should try. Oh, we have Cactuar. We have hyper-realistic Cactuar if he real. Hello, Blizzberg. Welcome in. P Huff. Can we reverse a bit? Can we, like, if I say P bit reader, bit reader from string hello world, right? And if I then read all of the bits out of it and put them into a bit writer, is this a thing we can do? Image made of character overlays from a classifier. You may post any link you wish as long as it is not evil. As long as it is not going to, you know, you are good. You if you have made a thing, you are welcome to link this. In general. Let's call this, I don't know, test writer. S. If I say let's reader. If I say let's reader, let's call this P test reader writer. Let reader resent fake. I don't know. I think I don't have any sort of resentment towards this. I just have little interest in it. And I think at this point it's becoming enough of a, I don't know. I have it's not to my tastes. Oh, this is kind of good. This is a little bit exciting. We have the last stuff. Hello, Nitrix_dev as well. What is the? You got both power. This is sort of good. Oh, this is. I see. I open it in new. Yeah, this is like multiple layers of character, right? In RG and D. This is very sick, actually. This kind of compositing. This is like offset printing kind of stuff, right? This is really cool. The choose links alignments. Hello, Matthias x86. Also welcome in. Yeah, you have to make sure your link is. Mostly, we're preferring lawful neutral. Evil. Hello, Ice Cold Witch too. Can we shout out Bud VT? Does this go? Okay, reader is P bit reader from string S, right? While let's say writer. I just want to test these guys, right? Writer is P bit writer new. While let's B is P bit reader pop bit from reader. This green dude scared me for a second. They put a crazy green guy on the screen. This one's good. Thank you, Lumi, for this. Lumi has been innovating in the shader metagame. It's good. It's good. We have to test it a little bit, I'm afraid. Can we say P bit writer push bit B writer? And then at the end of this, can we return P bit writer Bitwriter bytes. Okay, does this give us... I bet there's something fucked up about this whole situation here, gamers, and we're gonna have to see. P test writer reader writer. Hello world. Well, that's not the right answer. Can you give it to us normal? Can we have it normal? Give it to us normal, please, computer. Well, that is backwards. Is that what we expect, though? Is that aligned with our expectations? Perhaps. I think, maybe it isn't. I think maybe it isn't at all. Why is it like this? Are we reversing it for no good reason? Why is it like this? Bit writer should be like the reason the natural thing, right, is the bit reader should be reading start from the front going, right? Like you're popping from the it's basically bit reader should be popping from the front, bit writer should be pushing to the back. That's the intention here. But I think why is that not happening? Clearly not happening. It's clearly getting, they're both How are these fellows implemented? Like bit reader just has an index and just it goes over the index, right? So this is naturally just kind of popping from the front, right? Because we're reading the first byte first, right? Like we're reading the right, and then we go from there. Bit writer has bytes internal. It's supposed to be consing to the front of bytes internal, and when you get the bytes at the end, it reverses this, right? Because we're kind of building them up in backwards order. But is this reverse on net? Like, what is the deal? What is the deal with this? I didn't make any, of course, but you're porting them, right? Like you're porting them and sending them. This is enough, I think. Do we have a reference to bits? My endianness senses are, well, it's not endianness, right? Because again, we're not working with any values that are like, we're not working with like 32-bit integers or something, right? We're working with bits, right? There's like a bit ordering thing, but like there is a where are we calling bit writer bytes? It's only So like, let's think of what happens here. Pop bit reader, this is the first bit, right? And then we push this. And after we pop the next one, like we should be pushing it should go after, right? It should go before in this, and it should get reversed to go after. We could have screwed up the bit order, yes. I mean, clearly I think we have. Hello, Ewo on site, welcome in. Something bad has happened. Something bad has happened. So, dude, hello. Hello, hello. There's a matter of there's something very wrong. Is this reverse is not unnecessary. This reverse is not unnecessary. We need this reverse, right? Because we're pushing things to the front. We are we? We are. We're saying setf car of, yeah, we're pushing things to the front. This cons here is what does it, right? We are pushing as we like if we have filled up a byte, we are pushing to the front, which is not the behavior that we expect, right? There's something strange and it don't look good here. Do I have like, have I not like redefined this? Do I need to like, is it possible that we have made some sort of significant error here? No. No. Like what? Am I just misinterpreting what I'm doing here? No, we should be popping. We're popping the first bit, and then we're like, that's the first bit that we write. So it should be at the start because we're push. This goes to this pushes to the back. This pops from the front. Like, what is the? Okay. Maybe we need to observe these more closely. Let's say setf test reader is p bit reader from string hello world, and let's say setf test writer is p bit writer new, right? If I say I don't know, the like let's see here. If I say p bit reader pop bits, 8 of them from test reader. This should be the character H. This is 104, right? If I take that pop bits and I put it on top of the other guy, if I say bit reader push or bit writer push bits 8 this onto test writer, we have 101 there. We put 108 before 100. This is reversing them naturally, right? If I keep doing this a couple of times, I don't know, there's the space, there's the next WORLD, right? And then if I say p bit writer bytes test writer, this should be the bytes reversed, right? And then if I say I don't know, seek into I don't know, this thing string, it's the thing forward. It's the thing like this, right? It's the right thing. What if I do this, like what if I do it this 1 byte at a time? Right? What if I do it 1 byte at a time instead of 1 bit at a time? If I say p test reader writer hello world, seek into vector or string rather. No, it's still wrong. It's still wrong. What is the idea here? What am I doing wrong? Like we literally did this exact thing. Oh, is bit reader from string somehow fucked up? No. It just converts it to a vector and does this. Like where is very strange computer. I feel like this is something so obvious that we're just missing, right? Like this must be something like that is just like an extreme obvious thing. Like there's no way, there's no chance that this is actually like a devil. We are just missing something extremely dumb. Where like we just did the thing by hand and we got the no, this is like we are wrong here. Like this flipping of the reversal is like what we were doing wrong. It's like our bit reader and bit write, our bitwise reader and writer are broken. And like where well, why? We're popping and then we're pushing. We are popping and then we are pushing repeatedly. B111 onto a stream. We certainly can, but like what's happening is at the end, like we're unnecessarily reversing or something. Like what is There's something about this in particular that we're doing wrong. I don't understand, like, the test function must be wrong because we did do it manually, okay. Why is the test function wrong? We're telling it the exact same thing. We're telling it bit reader pop bits from the reader, and then bit reader push bits to the writer. Right? Like this is all we need. This is well, popping and pushing is reversing, clearly, right? I mean, we're using popping in the wrong, like we're pushing to the front, we're popping from the front and pushing to the back of another thing. So this should not reverse, right? This should be a non-reversing thing, given our understanding of it, right? We are taking from the front of one thing and we are adding to the back of another thing. I call that shift and unshift. Yeah, sure. Can we just print, let's say popped this, let's say, where is push bits? Let's say pushing this, let's do it here. I do reverse the backwards list explicitly. I call bitwriter bytes at the end. Bitwriter bytes is just saying reverse that. Reverse the thing inside. Do we have a list of what's going on here? Can you tell us about it? Can you tell us about it? Can we look at hello world? Can we say seek into u vector? Okay, we're popping 104, we're pushing 104. We're popping 101, we're pushing 101. We're popping 108, we're pushing 108. Yeah, right? We're going through the whole guy. Right? We pop and we push. Let's print the innards too. Yes, good thing to do. Pushing. Let's say here we can say pushed inside is this, right? And this can be p bitwriter bytes internal, the b's, right? Defs, not prints. That way I have the actual, yeah, this is very useful, like doing setf for this. I do this occasionally as well. This is good for a loop like this. It's sort of annoying, right? Because we have to like because we're printing out like many iterations, but over a single thing I do this a lot. In fact, for a lot of stuff I'll just like have that built in, right? Like for like network requests, I usually like throw the value of the last request just in a variable, just so I can like get it if it ever fails. This is a good thing to be doing. Okay, 104, then 101 and 104. Okay, 108, sure, right? We're pushing all of the guys. We're pushing all of the guys. And eventually we get 100, 108, 114, 11, right? We get this at the end. That's what it appears to return. The problem is we should be... Oh, fuck. I know what's happening here. This is evil. This is so evil. This is the worst shit of all time. Okay. Here's what's happening. Get rid of this. Get rid of these message calls. What's happening is that we named this function p bitwriter dash bytes, right? When we were messing around with things, we were formerly calling this field p bitwriter dash bytes. Normally, you would just be able to redefine this, right? It would be totally fine, right? We could just redefine this thing, right? What I am speculating is happening here is that this p bitwriter bytes function is not, in fact, calling this function. It is still getting the field, because struct fields are implemented in some fucked up way that I think involves an elisp alias. Let me check this. Oh yes, you see it here. This function has a compiler macro, p bitwriter bytes underscore dash dash c macro. See the manual for details. I bet if we say hello from here, we will never see hello. We do not see our code is not actually being called due to, okay, so it is a devil. It is a devil, is what's happening here. Load it again. Sure, I guess we can do this if we want to. But even then, I don't know. What is the? How can we unload easily? There's a guy for this, right? it's just called unload. Unload feature unloads the whole library that provides feature. So we can probably just say unload feature puffer, right? Maybe. I guess we're never requiring puffer, right? Like if we look at bytes, we look at this guy. Does he exist now? No, he's still evil. I can probably just undefine this macro. We can probably just undefine him, right? Like there is F. We did not load the library. I loaded it. I just ran this interactively. I just called eval buffer. That's how I'm usually working. I just eval buffer on top of itself a whole bunch. Can we say p bitwriter bytes -- c macro? Nil. Okay. Maybe that solves our puzzle. No. It does not solve our puzzle. Can we, does that really not do it for us? Like we cannot say fsets this guy nil. This is not real. No, it is not real. What does the manual have to say about this topic? Compiler macro declare forms. The buffer is red, the color of hell. Yes. How can I get rid of this guy? Like this function does not exist. In fact, it thinks it's real, but it is not real. Like Emacs Lisp compiler macro, C macro. Is this like a thing that? Same thing in Python. I don't really write Python hooked up to an interpreter very often, but in Lisps I'm always just like in the buffer and I just run eval defun and eval buffer all the time. Not compiling macros. We want C macro here. And Lisp macros for this is all wrong. It's all wrong. Okay, you better tell. Okay, we gotta see. Its definition. Defines an expander to call. The expander could then cause the produced bytecode not to call the original function. Can we declare this compiler macro? Can I say this? If I say like declare like how do we do this? If it occurs in the declare argument of a defun, like what does this guy? It takes declare after the doc string. Can I say declare compiler macro nil? Is this? Can we do this? Can we get away with that? Okay, we can get away with that. Does work. Okay, good. Good. It's probably just a property attached to the symbol, so put would also do this. Okay, does it work now? Maybe. Maybe not. What are you saying? Thank you for producing huge number of A's, friend. Thank you for producing literally tens of thousands of the letter A. It's a super fun song with lots of silly sounds and catchy beats. It's a super fun song with lots of silly sounds and catchy beats. Thank you. Okay, now I fear we have produced a we have wound up in a bit of a snafu potentially. Okay, there we go. We just needed to redefine everything. The more you listen to it, the more you start to come up with a song that is about to start. Yes. Okay, well we can do this now. We can say seek into this string. That is insane that this caused a bug like this, right? That the consequence of this was us getting like garbled but sort of working decompression, right? That is really funny. Okay, it's still wrong. But it's still wrong for an amazing reason. It's still wrong for an amazing reason, I think. Maybe? No. It's not wrong for any good reason at all. It's wrong for no good reason. Do we know? Can we just rerun everything, I guess? If you use load library, I think it works better. Yeah, maybe so, but the problem is, like, if you're just in a buffer, right, you don't necessarily, you have to, like, then you have to, like, query, like, you have to do a bunch of nonsense, right? Like, load library, it wants, like, a name, right? And I don't, like, oftentimes I'm working in a buffer that isn't even on the load path, right? Like, this buffer, for example, is not on the load path, so load library would not find this buffer. So you have to kind of, like, I'm often just working with Lisp code that's lying around. Hello, Pixel Sorted, welcome. Computer. Well, that's clearly not test string, and it also has a trailing space. But it's also not right either. At all. Do we know what the deal is? Do we know what the deal is? What is our deal here, computer? There's some kind of deal that's being made, and I don't know quite what it is yet. I'm not very sure what the hell is going on with this deal thing, this whole deal business. We just rerun everything just so we know that we are in a pure state. Load file then, and this could work too, but sometimes maybe you're not even in a buffer that corresponds with a file. And I don't think this will get you this alarm. Bell. It's my own alarm. My own alarm telling me it's time to start the stream now. Like, what does this look like? We're not actually using the... Oh, I guess we are using the reader when we instruct the Huffman guy, right? No, we're not. We only look at bytes then. Why is this flawed? What are the flaws that exist inside of this one's heart? Can we consider this? Your own alarm letting you know you've been owned. Yes. Can we message I don't know. Let's say code this corresponds to this. Let's actually print what character it is. As well, we can say you are code, you are v, you are v. And we run this. Do we see something? To take a bit stream in a coding table and chunking the bits up into codes. I mean, we already have this. I'm pretty sure we have a guy who does this. What are they telling us about this? Code 27 corresponds to 100. Is that real at all? Is that actually a real deal thing? Like, what are the code symbols going on here? 27 does correspond to 100 apparently. That is true, in fact. What should it be? It should be T. It should be T. What is T? Yeah, we need to binary print the code. What is 116? Also, this should be 11. This should be 11. What is bin 27? What is bin 11? Ah, this sure looks like a backwards kind of scenario to me. That looks like well, it looks like we're missing a prefix. Like there's something very bad going on with this, right? Like the code for T is a prefix of the code for the other guy. That's not right. That's not how it's supposed to be. So my feeling here is T equals a drink with jam and bread. True. I have a feeling that we're probably doing the canonical code thing wrong. If this is likely. Hello, Miguel G.A. Mendez. Welcome in. I think it's likely that we are doing this incorrectly. It's also funny that we're not finding this first. Oh, you know what it is? They're probably both the same length, and this just has another 0 because it's supposed to be longer. Like if we look at symbol lengths, I bet the symbol 100 and whatever this guy is, 116, is also length 5. No, it's length 4. He is length 4. Use a system that's either fully module based or fully image based. I mean, it is. The modules in eLisp are just fake. They're just a fake thing. I pretend they don't exist, right? They're not real, right? There's like the unloading feature, and like this is just it's just shorthand for calling fset the right way or calling put the right way. They don't actually do anything. Can we I think there's a bit of a problem here, gamers. I think there's a bit of a problem here. Yeah. I think yeah, but you don't download an image from GNU.org, but you create an image interactively by loading source files, right? This is right. You don't have to distribute the image for the thing to be image based, right? I think the main thing that makes it feel this way is that there's just one big global namespace that everything fucks with, and everything can touch everything else, and like the hash table. I mean, of course, this is kind of sure, but like you're operating on one. You're fundamentally all the code sorts of things you do in eLisp are like interactive, right? They're operating on this big shared pile of state that is the image. Should the hash table key be a tuple of length plus code? Maybe. I think it's fine to have 2. It's the same basically. I think what's happening here is our codes are just wrong, right? I think our canonical codes are just incorrect. Because they are not this is not a valid prefix code. I'm pretty sure, right? Like if we look, right, like the symbol like 100 corresponding to 27 and 116 corresponding to 11 is just incompatible. Right? This is not a compatible thing. Right? This is 1101. This also has 1101 as a prefix. This is not a thing that is a legal move, right? A 0 in front equals another code, sure, but like that's not what it is, right? You have to read these backwards, kind of, right? Because it goes like the order of the bits is least significant bit to most significant bit. Is it possible that we are also handling them wrong? I think we're also like checking them backwards potentially also. But we have to do this. MSB binning, yeah. I mean, we're doing it like I want to just get it to work first. I think we'll worry about it in the future. Let's see. Maybe we should not make our code canonical. Yeah, it is LSB first. Our thing is LSB first too. I'm just saying you have to read them in Emacs backwards because of course it prints them MSB first, right? Like if I'm looking at these, or if I'm looking at these, right? This is most significant bit first, right? So this is actually like bit 0. This is bit 1. This is bit 2. This is bit 3. Okay, where are we? But our code is wrong. Like the not our like our software code is wrong, but also like the code our software code is the Huffman code we are producing is wrong. I think this is a matter of the canonical guy being wrong. I think the canonical guy is wrong because if it's LSB first, why don't we see big numbers? Because it's LSB first. We still represent the integer. The integer is, of course, the least significant bit is the least. We never invert an integer, right? Like the least significant bit is the least significant, like mathematically, right? However, the first bit that we like read, that like the first bit of a given code is the least significant bit of an integer, right? So like let's Emacs just, I mean, the way you print numbers usually is most significant to least significant, like the way you write numbers. But the way we are reading numbers is we are reading the least significant first. I think this makes more sense. And is the way that they do it usually. The way that probably Deflate will do it. The hash table key is integer. Yes, it's still an integer, right? It doesn't matter. It's still going to be the same integer. The integer that is there is just the entire code, right? It's the whole last code. Like, and we can get away with this. Oh yes, okay, yes. So actually, you're right. Hello, perspective distortion, right? We do lose that 0, right? Actually, it should be the length. You're totally right about everything, actually. You're actually so right about all of this. That it's unreal. Yeah. That's very real, I'm thinking. I don't want to read Lisp. So code symbols should perhaps just be a different fellow. We won't use strings. We'll use cons pairs. We'll use a pair of the length, and we'll use a pair of the length and the number, right? And the length here is just ht gets symbol lengths car it's, right? This is good. A conditional breakpoint slows the game down to sub 30 FPS. This is hell. Name is the same as the unique characters. The length of the hash. Yeah, I mean this would. I mean the bug is not just this. I think the bug is like this is relevant regardless of that bug, but I think like regardless of the thing we're currently encountering. But I think there is another mistake that is deeper. Can we get what is the default hash table hash function? I don't know what it is actually, but we won't worry about it. It's probably equal or something that is sensible. Cons. Well, it's kind of a problem, right? Because we don't actually know well, we do know the length. We can say code len here. And then we don't have to do this comparison step. We only have to do this one time. Yeah. Okay. Okay, now we get an empty string because we no longer have any valid comparisons. Oh, because of course we're constructing the huff guy wrong. Can we say setf test huff p huff generate test string? Okay, we're still wrong. What do we have in code symbols now? We have these guys here, right? We have a mapping of the length and the symbol to the code. Okay, sure. We probably should just have these be, we should probably merge these two tables also. Honestly, but we need to we generate them separately, so I think it's fine. It's just additional work for I think not much benefit. Can we why do we have nothing now? Why do they give us fucking nothing on this? Like what is the we message codes codelen.code is this. I just want to see them in the same format. Do this. Let's observe. They obviously grow huge because we are never identifying a valid code. Like what's the first guy who we get? I think our codelen is also off by our codelen's off by 1. That's what it is. We need to add 1 to codelen. This should be plus codelen 1. Okay. Yeah, still wrong for the same reason, but I think that is a good fix that is going to prevent future grief. Is that will be a problem. Okay. Where is where is the guy? Where is the fellow? Conjure the fellow, please. Our fellow, I think, is that our code is wrong. And our code is wrong because the way we are computing canonical codes is wrong. And in the RFC, there was a better example of that. And I think we would like to explore that. Potentially. Can we see this? They talk about this canonical guy here. They give a longer example here. Yes. The alphabet A, B, C, D, E, F, G, H with bit lengths 3, 3, 3, 3, 3, 2, 4, 4. Right? Hello, Zulfix again. Welcome. If we say P huff, what are we calling this? What is his name? What is your name? You have a name. You have a name on you, don't you? Canonical symbol codes, yes. If we say this for an HT from Alice, I guess who has to wake up at 6 a.m. tomorrow. I'm sorry to hear this. This is unpleasant. A is 3. B is 3. C is 3. D is 3. E is 3. What else do we have? F is 2. This is an F style alphabet. G is 4. H is 4. Okay. Well, we produced some codes. I do not believe they are the right codes. Let's observe. Let us observe these guys. What the fuck is F? What the fuck is A? A is 65. A is 65 and it's giving us 2. Well, that's the right code. That's the right number. 66 is 3. That's the right number also. 67, this is C. It should be 4, right? This is binary 4, right? D should be 5. Okay, all is good. And E should be 6. Okay, that's good. What is F though? F though should be 0. F is 0. G should be. It's claiming. What is 14? What the hell is 14? Well, G is the right number. And okay, it is right, actually. That is sort of unpleasant. Okay, we are in fact computing the correct code for this alphabet at least. But I feel like we're not computing the correct code for our thing, clearly, right? Like, we lost info that we still have that info, right? We're not throwing that away, right? We're keeping this info and the other info, and we're putting them together later on. We know we're keeping both of them, right? This is like a supplement to this thing, right? Which is the thing that has the lengths as well, right? So we have a map from symbols to lengths, and we now have if we call this, we get a map from symbols to an integer, right? The code. What is your code's in the wrong bit order? Oh yes, you may be right. We're reversing the bits on the codes. I think you're right. Can we think about that? Yeah, we are. We are. Teehee, yes. Where are we doing that? Where are we putting these guys together? It said shortest lengths first. No, I mean, I think they mean by, for example, G is 1110, right? That should not be binary 14, right? It should not be. This should be the least significant bit. This should be the most significant bit if we're treating it this way. So it should be binary 0111. right? So it should be 7 instead of 14, right? Which will, I think there's probably what we're doing here is we're clearly mixed. It doesn't actually matter what we choose as long as we're consistent in our representation. The problem is we're getting our wires crossed there somewhere, and then we're treating it in like one way in one spot, and we're treating it another way in another spot. So let's double check where we use these guys and where we disassemble these guys, right? So when we use them, we're building up the code, like we're reading this code. I think we're reading this back. Are we reading this backwards? Right? We're reading a bit. We're treating this like we're reading the most significant bit first, I think. Is that what we're doing? I think, right? I'm pretty sure that's what we're doing here. Yeah. Like we read a 1 first, and then we shift that over by 1, so we have 1, 0, right? We're reading this most significant bit first. How are we representing them? Because I thought from what Topiary Head said, it seemed like we were representing them backwards. That's what it seems like. Yeah, it depends on how we wrote it, right? In canonical symbol lengths, or canonical symbol codes rather, we are, I guess, doing the same thing. Maybe. Yeah, I mean that's fine. We're handling this the right way. Hello, Machka6. Thank you for a violent attack. No, don't. I won't. I'll choose not to do this instead. Thank you. Thank you. I think I'll keep going instead. Where is, right? If we encounter, yeah, we just start at 0. No, we're adding 1. Adding 1 here forces us to kind of do this a certain way, right? The fact that we're adding 1, it kind of demands that we are producing, we know we're producing the correct codes in MSB first order here. So if we just make sure that this is also this also leads to MSB first order, right? And I don't think this is what we are doing. Yeah, we want LSB first. But this is a purely internal representation, right? This has no bearing on like this is purely like how we represent the thing internally. Yeah, it is entirely, right? This is not how we, this is not what the order, this is not the order the bits are in the input. It's the order we like, or is it? Yeah, like it's as we read we're always reading bits one at a time, and as we read bits, we're reading bits LSB first, right? But we're reassembling those bits into like an intermediate value that we use to check the table, right? And that intermediate value could be assembled in one of the 2 orders, right? And I think that's what we're doing. We're mixing up right now. This is our mix up. Like we on the bit reader itself, we are LSB first. Where is fuck? Where is fuck? Where is fuck? Where is fuck? And we're just not reading any right now. That's the thing. No, we are reading some. We're getting the exact wrong answer. Who's they? Who is they? I don't know. My unnamed adversaries. Oh, the pixies who live in the walls. The even more confusing. Probably. Maybe not necessarily though, right? Like you can imagine a world where if we're representing a set of an array of bits as an integer, we're always representing it as MSB, right? It's always. No, I guess we could be inverting the guy. But I feel like if we're inverting the guy, how goes the bits and bytes? We're getting there. We're getting there, Ivalon. Welcome. How would we invert this, right? We would invert this by just saying we have to put things on one end instead of, we have to put things on the other ends. We got to put stuff on the other end instead of on this end, right? So what would this entail? What would this entail? We aren't freaking Motorola. What do we want to do with this guy? We gotta reverse it code len. I mean, like, we don't have to do any reversing. We can just build it a different way, right? Like when we set the guy, initially, we can just say, like, shift it by 1, right? No, this is going to build it back. How do we want to do this? If we read a 1, right? Right now, we are putting that 1 in the least significant bit. To put it in the most significant bit instead, we have to shift. We have to logi or it. We have to shift it left by code len, right? This is the guy, right? We have to ASHB by code len. I think that's it, right? This is the concepts. Okay. That's a good start. Okay. Good first steps there. Huff my balls, yes. The problem is we're missing the last character. I think the problem with the last character is that we are... There's probably something related to padding out to a byte, right? You know, here's the issue, right? I bet what's happening here is we're, you know, a single space is probably, I think 0. Maybe. All this for a Huffma joke, 6.5 hour prank. This would be good. If I was wrangling this, it'd be very good. It's a matter of you can't cleanly encode it into bytes always, right? There has to be some kind of terminator, right? You can't just be like, I'm just throwing bits, arbitrary number of bits in the last byte. There's, right? There has to be something that indicates the end, right? Because otherwise you just have like, you have a bunch of extra bits in there, right? That correspond, like whatever's left over in that final byte. And I assume that's what's causing this mischief with this space. What is the symbol for space? What is 32? It's 0, right? So a single 0 is this. You're missing half the message though? Yeah, we are. I think... Oh, we really are missing half the message, huh? Why are we missing half the message? I was like, I thought, oh, we just wrote... Obviously, we didn't just write that. I think there's... It is definitely something like this, though. We've made some progress. What are the codes we try and read after this, though? Like, what are we saying? If we say message code len, and we say this is good night 0x539. Thank you. If we say this is code, this is plus code len 1, something like this. Like we're clearly kind of right up to this point. We're clearly getting things a little bit right. Right here we're building up small numbers over and over again. Okay. Then we get to 49. And we're just getting longer and longer. We're getting longer and longer once we hit this. We hit like we keep increasing. Our power keeps increasing. Why do we keep increasing the code length? We're adding a bunch of zeros and we eventually add a 1, right? The first number is not very important, right? What is the deal with him? What is the deal with him? Also, what is the letter N? Does the letter N always fuck us if we try and do this using this table? We can use different tables on this string, right? I can say like this. This works, right? This is a right? That works. So there's an extra space at the end, but that's to be anticipated. The extra space thing is a separate kind of deal. If I say this, if I put an N here though, N destroys. N is known as the destroyer. It obliterates the rest of the string. Yes, this is good, but we're not actually doing anything related to deflate yet, real nice, right? We're not considering deflate at all. I'm merely trying to get our own little, like the Huffman part working, which is independent of this, right? We're only thinking about this. But I bet if you're linking this due to the fact that it mentions how to handle the Terminator thing, this is useful. We will investigate this. What is the deal with N? Hello, Avenel. Can we see this? Like, what is this? Euro 110. What does 110 correspond to? 110 has symbol length 4, and it's the number. It's 8. It does have an end of block code. Yeah. It's 8. It's 8. It's 8. Why are we not reading that? Code isn't shifting. Yeah, like we're not. Yeah. What's the deal? Is it? Yeah, the problem is we're reading it like these are this is like the I guess it should be 8, right? Why are we not? I'll be back. Of course, what's happening is we're putting this on top, right? We're not actually ever shifting code. We're just adding. How did A work then? Yeah. That's kind of the like A is 97. A is 97. 97 corresponds to 2, right? This is a different fellow. This is like I don't know how any of this like A works because we're putting a 0. Like the problem with this is we're putting a like Can we print when we actually emit a character too? Message found char this V and URV. Bad luck. Okay. We find a T, we find an H, etc., right? Etc., etc. We eventually find an S, but then we find a space. We find a space. And this once we find the space, it like misaligns us. Well, no, there should be a space. No. But right? There is a space naturally. That's just these, it's just this. There's the 3 zeros, right? But then we find another space, and then we have a problem. Once we get the second space, we have a problem. Space is 3, right? The second space though is a bit of an issue. And I think this is like, again, if we look at test huff, hello Cameron Reap. Can we do that? Like if I don't include a space, does it always treat it as a space? No, it just fucks up the subsequent stuff, right? This guy is evil. Hello Cameron Reap. Welcome. Yeah. This next, it's reading a space too early, right? I think this is because the space is a prefix, right? Like it's not a real prefix tree, right? It is the canonical. We have broken the canonical thing, which is frustrating because it works in both examples that we have in the RFC, but it does not work. It's not a Terminator thing yet, right? We will need a Terminator eventually. What's happening now though is that our tree is not a prefix tree. How are we doing, Chad? It's going well, Cameron Reap. Life is pretty good. We're currently trying to do this Huffman coding thing. We're trying to learn a little bit about compression today. This is the compression day for us. We're getting compressed. They're putting us into the hydraulic press. It's the idea. I don't know, something like this. And we're trying to learn a little bit about it. How can tree not be a prefix tree? Because the way we are computing the canonical representations is wrong. It happens to be right in some cases, but it is wrong in other cases. It's not actually a tree, right? We're not actually using the tree in any way, right? We compute the tree originally, but like when we are giving the things, we use the tree to get the lengths, and then when we are using the lengths to get the canonical codes. Use compressing algorithm, yes. Be the combined table by literally taking strings. No, I'm not going to give up in this. It's a matter of, like, we're not doing something wrong with the handling of integers at this point, I think. What we're doing wrong is we're actually computing the wrong tree. You actually see what's going on. Oh, sure. I mean, we can look at it, right? It's not that bad. Like, what is n, right? Again, n is 110. 110 is 8, right? 8 is 1000, right? Also known as from least significant bit first, it's 0001, right? Right. So the first bit 0, second bit 0, third bit 0, and then 1. How do you say? Why do we have 000? That's the question. I mean, it's more a question of why do we have this, right? This should not be a valid code. Okay. So let's look again at, I think it's probably the handling of, I don't know. I guess you can't really have wrapping, but like, where is canonical symbol codes? Again, what are we assigning? MSB first in the table. Yeah. I mean, this is MSB first here, right? Like, this is, like, 8 is written MSB first. However, like the zero, we're still treating it like the first bit, the 0th bit of this code is 0, right? Not 1. This is right. Whenever we represent things as integers, we store them like normal integers, right? We store them MSB first. But like, I mean, they're always, I don't know. I'm confusing myself with the terminology, right? We don't we have to be clear about this, right? This is being printed as 8 because we put right, the way it is being printed is like the way you normally print numbers, right? It is most significant to least significant. The way we interpret this is least significant is the first bit of the code. I am fairly confident. Yes. I think. Fuck, I'm gonna mix myself up now. Is this the case? I am a little bit dubious about this arithmetic that's happening in here. The CL Incaf is a scary fucker. This is a scary guy. I have a concern that this arithmetic is happening backwards, right? We're doing arithmetic on, but no, then the examples would be wrong. Count the number of codes. I mean, we could do what they say. I guess. Let's look at what they say to do in there. Let's look at the RFC. And we can see if it produces a different outcome. What do they say about it? They say count the number of codes of each code length. Put this in a table, right? So we know we can find this very easily. Find the numerical value of the smallest code for each code length. Which sure. This is what do they say for this, right? They iterate over from bits to max bits. We take We take the number of codes of this size. Hello, Kuju. Welcome in. Thank you for the raid, friend. Thank you for the raid. Can we shout out Kuju? Does it go? Kuju is very cool and is developing a game called Fat Goblins on Steam. It kind of fucks. Hello, we are writing an implementation of Deflate today, or at least we're trying. We're mostly writing an implementation of Huffman tables, Huffman coding. This is kind of fun though. We're learning a little more about compression today. Can we open this also? Fat Goblins Steam. Does it go? Does it go? It's a little bit exciting. I don't know very much about it, so it's fun to learn. But you should check out Kuju's game. Kuju is making this from scratch in Jai. It's kind of cool. It kind of rocks a little bit. How was your stream today, dude? How did it go? If you don't know me, I'm LLLL. I'm a guy. I pretend to be letters. That's my thing. We do programming for fun. This is the usual kind of situation around here. Oh, you have like a little cutscene now. I don't think I've seen this. This is kind of sick. We have animated cutscene. Oh shit. This is really good. Osu style event, official indie game status. This is really nice. The 0-bit codes are fake meant. Yeah. Assign numerical values to all codes just using consecutive values. Sure. Sure. Okay, that's not bad, I guess. We can certainly do this. In fact, is it only distract you? I'll grab some food. Yes. No. I mean, you're not distracting me, but of course, please get some food. Thank you again for the raid. Fine. We can do this rather than just let's do it like this. Let's say we'll just compute the starting value here, right? Because we already know, like we've already partitioned it, right? So XS is all of the right? We know length XS, right, is the appropriate length, right? So we want like length XS is Oh, we want to take bits minus 1. This is kind of funny. Of course, because we need the previous one. Yes. I guess this makes sense. We do need to pre-compute these. A bit far. No hate, I admire that. Yes, we've been doing this for some time. Hello, Solalicious. I am a big Emacs fan. I think it's great. I mean, I think it's like just pretty good, right? I'm not doing this for like meme purposes. I think it really is quite good if you're into a particular kind of thing, and I am, at least. So this is like this is pretty good. It's kind of good and fun. Can we loop over? Well, we can just look things up in grouped, I guess. Also, well, that's fine. Let's say, I mean, I guess we can just, yeah, this is not too hard. Okay, let's do this. Let's say, let's like p count, prev count. Let's say this is a list get this is a list get minus length xs1 from grouped. Default value is 0, right? So this is the count of the previous thing. I've had some conflicting key bindings. Yeah, there are some, like, I'm sure you could replicate your key bindings if you wished. There are some. I don't know the Emacs bindings at all. I just use VI bindings. But there are some projects. I think there's like this thing, meow mode Emacs, which is maybe a vaguely helixy thing. Kind of the advantage that I see is that, like, it's I don't know. It took me a long time to switch to it, but I just sort of treat it as just like a place where I can control. You know, I can make key bindings, right? I can display text on the screen and I can keybind keys, and then from there it's just like I can do whatever I want on top of that. Yeah. This is I don't know. Maybe people talk about the Helix thing quite a lot. I maybe should investigate this, and maybe I need to do this. Also, I'm gonna do some CL hacking. Nice. This is cool too. Okay, maybe we don't need to have Kerr anymore. How do they? I guess they do care about this, right? We do need to care a little bit. Fine, let's just do it the way they're doing it, rather than trying to fuck around and be clever. Thank you, Sololucious, for the follow. Okay. Let's say max bits. Max bits is I don't know. Max by or rather it's just max of map car groups is probably the thing to do. And then we also have next code is ht creates. And then we just loop this, right? We say do times and I guess we can actually say, I don't know, iota max minus max bits 1. Oh, I guess we want it to be max bits, right? Because we're gonna, yeah, this is good, I think. Each over this exwm my T420 thing. Oh, very nice. This is good. I have a T430. But this is I'm also a fan of this a little bit. Are we using SimD already somehow? Not. I guarantee we are not using SimD at all in any way. Unless you mean like in terms of the shape of the operations, but I think we are also not doing this. What is IOTA doing? IOTA is producing a range. We are using this to basically perform a for loop. This is our usual way of performing a for loop. We call this a classic type of guy, by constructing a cons list of the given length and then mapping over it. Yeah. Okay. We want to say for all of these guys, we want to say setf code setf code to plus code the thing we had before, right? alist get minus it 1 in grouped default empty nil. I guess nil will be the default anyway, and then we're just taking the length of this. And then we want to shift this left by 1. And then we want to, this is cur. And we want to say that ht set next code it is cur. Something like this. And then for all of these guys here, we can just do it like this. We can just do it this style. We're still gonna sort them. We're doing this in basically the worst of all possible ways, right? But it's okay. Let's call this start. Let's call this C rather. I don't know. And this, you can be ht get next code length x's. This is basically horrible. This is basically the worst shit ever. But it's okay. incfc do this. Okay. This is maybe something a little bit different. Proper multi-threaded Emacs for a thing, yeah, for certain. Huge. Okay, we're still wrong, and we're wrong for the same reason. But we're wrong because we're not recomputing the codes. We need to recompute this. Can we setf test huff p huff generate? It sure looks like elist. We are surely elisping. Hello again, LG. Okay, now we're wrong for a more amazing reason. We're wrong for a slightly better reason. Yes. Poof did find a bug also. We're wrong for a reason that involves... We have it a little bit mixed up in terms of our... I assume there's just not an entry here when we need there to be. Can we message ht alist next code when we run this? Okay. We have 1, 2, 3, 4, 5 here. 1 is 0, 2 is 0, 3 is 0, 4 is 2, 5 is 26. Those seem like reasonable numbers, but there's nothing of length 1 and 2, and then 3 and, you know, this sort of makes sense. What do we want to do with this? I mean, maybe we're not going far enough. That's also a possible thing. Oh, this is wrong. This, I think, is wrong. No, we're grouping by the lengths, right? I think we should be fine there. Oh, this is wrong. This is entirely wrong. This needs to be this. Yeah. We're confusing the number of things that have a particular length with the length. Okay, that's better. Can we now compress and decompress? No. And in fact, it is wrong for the same reason. Okay. Good. Good. Okay. What does the new table have to say about us now? What are the codes here? What are the freaking codes here? Well, we still have the same thing. The same thing is happening here. I think we may in fact be computing the same table, which is a little gruesome. It is slightly gruesome. The problem is, we can simply strongly type. I think we're again, we're being so sloppy, and we just really need to be less sloppy with the way we're handling these integers, right? We need to figure this out a little bit more nicely. Can we like like it should be what are they incrementing, and what are we? Let's all love Lane. Kind of true. Like I think we Oi computer. Maybe we're not computing the wrong code and we're still holding it wrong. I guess that's a question. But how would we be holding it wrong in a way that like maybe? Maybe. I don't know. What are the values that have... Can we go back to here? What are the lengths, right? What are the guys who have, like, what is N's length, right? His length is 4, right? What are the guys who have length 4? There's 109, right? 109 is length 4, 110 is length 4, 111 length 4, 112 is length 4. There's length 5, excuse me. But 100 and, right? There's a ton of guys who are length 4. Starting from like 104. There's a bunch of them. Can we see what these codes are? Average is like 6.5. This kind of gives us the codes in ascending order of the right. This sort of, this was a general's joke. I see. This is sure. What's the first guy who is length 4? It's 104, right? 102 is length 4 also. 101 length 4. 101 is Also length 4. Is 97? 97 is also length 4. 32 is the only length 3 guy. This should be 0, 0, 0. Right? This guy should be 0, 0, 0. This guy should be 0, 0, 1, 0. Right? This guy should be 0, 0. This guy should be 0, 0, 1, 1. This is, am I right? No, this is wrong. No, that's right. 3 is 0, 0, 1, 1. Yeah, sure. This guy should be 0, 1, 0, 0. This guy should be 0, 1, 0, 1. This is correct. I think, yes. This guy should be 0, 1, 1, 0. This guy should be 0, 1, 1, 1, and this guy should be 1, 0, 0, 0. So N is the first problematic guy. Okay, here's the problem. We're checking the suffix, right? That's the problem. I think this is it, right? It's kind of like this, right? We're checking the suffix first, right? 110 is like this number is 1000. That is his code. The code is the string of bits 1000. There is another code with the string of bits 000. These do not share a prefix, right? They do share a suffix, however. What's happening is that we're checking this, like we're looking at the suffixes first, instead of looking, because the way we're kind of building up the codes backwards a little bit, right? The last bug we fixed was not the bug that and it was right. No, that was a bug still, right? It's a bug in a different kind of way, but it's good to be doing that. This is the issue, right? This is the problem. How is the Steam Twitch alerts going? Have you worked on? We have not touched the Steam thing in forever. I actually kind of forgot we did that until I went through a bunch of old projects recently and saw we did. I need to get this. I think this is still, I need to become legally protected enough that I can put a thing on Steam and then also email them and be like, can I do this? Yeah, this is very real, saying Durinard. Where is, and this is sort of the thing that's happening here. I think it's a matter, so you can see why it's happening. It's happening because of this, like in decompress, we're checking the suffix, right? We're building up. But why? Shouldn't there be a 1 first? Should there not be a 1 at the right? Oh no, that's what it. The 1 is. Is it in the fuck? Like the only place that causes an error is when we have two when it starts breaking when there are two codes that have a shared suffix, right? We know it mostly works because it's working on the other codes, right? So we have we have our wires crossed in one particular place, and this is causing this to all fall apart. How can we do it? How can we do it? We're building a suffix tree. We're treating it like we're building the right tree. I am fairly confident that our tree, the actual code to symbol correspondence is correct now, right? The problem is the way that we check them, the way we use them, is what's going wrong. Or maybe it's either the way we encode or the way we decode. I'm inclined to say that it's the way we encode. Yeah, it is both because it's mostly right. Yeah, it has to be both most of the time, right? There's like a small thing that happens only in some edge case, right? What order does push bits push the bits? Well, let's just think about this. How are we popping these bits, right? When we pop the bits, we're popping the bits and we're assuming that the least, like, we're popping them directly into... Okay, here's what's wrong. We were right here before, I believe. I believe we were right before. I think we do just want to say logi or code B here. I think down here we do just want to say setf code ASH code 1, right? Right, this is this thing, right? This is true. This is true as hell. The problem is not that this was inversed, it's that compress is inversed. Compress is inversed because push bits is backwards, I think, is what's happening here. And I think push bits is backwards here. Push bits should be pushing the least significant bit first. Is that a cat? I don't know. I'm unsure if there's a cat. There might be a cat. I don't know. I'm being whispered at. How do we do this? How do we do this? I have did you get a cat? No, we've been like pet sitting, and there's a cat that's very like, it's new, and it also is all up in my business all the time. Like it like, instead of like remaining away from me, it like slide tackles the door. Like you'll hear it banging on the door constantly, and like in the middle of the night, and like yelling and stuff. And then so it's sort of a scary situation. Things are kind of becoming survival horror around here. Is this what we want? Is this what we fucking want? It likes you? Yeah, I think so, a little bit. Is this the thing that we wish for? Is this our pillow, the one that we dream on? Where you have to think, this is pushing the least significant bit of an integer first. Is that what we desire? Is that our heart's desire? No. Maybe? No. I think we want to be pushing the most significant bit of an integer first. It's the most significant bit of an integer. And you know what the thing that ties us to this most significant bit is the thing that is right? The thing about this, the reason why our integers are that way, despite not really wanting them to be that way, is because of the addition. It's the fucker. It's the fucker, because that's how the fucker works, right? The way that they are invoking the fucker, this plus here is necessary to make it go like this, right? Because plus sort of is direct, right? This is what it is, right? Plus is not a purely bitwise guy. Plus relies on the order, and that plus is what's causing it. So how can we? I'm just making another push bits. To not. Let's call this push bits LSB first. Let's call this push bits MSB first. And MSB first is going to have a different kind of way about him. We no longer need to have a burning comment section as a warning to the new push bits. Yeah. This guy, we want to shift the most significant first, right? We want John. I mean, this is just a matter of subtraction, right? It's a matter of subtraction, I think. The minus shifts minus len shift 1, something like this. Yes. And where are we doing push bits? We say this is MSB first instead. And we run the whole. Okay, good. It works. Okay, good. It works. We've solved the puzzle. The puzzle was what we thought. That's kind of satisfying, right? Because it was exactly what we thought it was going to be. So this is at the end of the day, right? Cool. We're still dealing with this final thing. This final space at the end is, again, it's just because there's extra zeros in the last byte, right? Because we're padding the thing out to a byte with zeros. Though the way to handle that is to have we'll have to have some kind of special, either save, save the message length somehow, or have some kind of terminate, the usual string stuff, right? We need some way to know when we're done. So this will be good. I think this is good for now. I'm gonna go get some food, and I think Maud wants to go to sleep. So I'm gonna, since she is ill, I'm going to make the executive decision that this is where we are for today. But I think this is a pretty satisfying point. It's time to null terminate the string. Yes, we're raiding dumb moths, by the way. We'll go raid over to moths. I think, is moths still going? We're always raiding over to moths, but this is the usual place. Nice stream, thank you. Of course, we'll be back again on Friday. We stream every Tuesday and Friday. If you don't know about this, if you want to know when it is, because Twitch is very bad at telling you when it is, it's this, but it's always the same time. Thanks for the stream, really nice. I'm glad you like this. I don't know, I'm trying. Thanks. We'll do more in this direction. Thank you everybody. Yeah. I'll generate the newspaper too, but yeah, for now, we'll see you soon. Next stream, Maud will not be here. We're going to have a non-Maud period for a couple of episodes here, for the rest of the interregnum period, actually, because Maud will be traveling. We'll make do. We'll make do, I suppose. Country girls make do. Okay, bye everybody. Be nice to Moss. Moss will be playing some kind of fucked up video games, I'm sure. Okay, we'll see you later. XO, join Discord IRC. Discord, yeah, that's the one. Yeah, okay, bye. Meat House end episode. Now, Meat House ending.